Yes everyone, so hello, hi, namaskaram my dear warriors. I hope you guys are doing really well. So from the past few days, so many students were continuously asking, Sir, when will you be uploading the CMA Final QT Marathon? And guess what? CMA Final QT Marathon is ready for you. Your search for simple, logical QT class ends here. Trust me, this marathon that you're going to see is going to be way more detailed, way more exam focused than so many other even regular class that you guys are going to see. So what all chapters we are going to cover, what all will not be covered, how to get the files, everything will tell you about it, but wait till the end. Now this is going to be a small introduction by me to the class. The class will be handled by Professor Taisir sir. Now Taisir sir is a faculty for maths as well as for QT, for CA as well as for CMA students. Now he has cleared his engineering and he has secured 99 percentile in JEE maths. One of the most difficult exams in the world. He has cracked that and secured 99 percentile in the paper of maths. So he knows the subject, the in and outs, the nuances of maths, how to teach it in the simplest way possible. And trust me, you listen to the class for approximately 1 hour, you will fall in love with it. All your doubts as to why we are doing QT the way we are doing, why is it, what is it trying to tell us, all those questions will be answered. You will see a completely different approach to the subject, a simpler approach, a logical approach to the subject. And you guys know, if you have understood logics for QT, it is one of the most scoring papers. It is one of the most scoring areas, even more scoring than costing, to be very frank. So to ensure that we have around 40% QT, roughly around 48 to 50 marks in the examination, to ensure that you guys get really good marks, we have come up with this marathon. By the way, CMA Final SCM costing portion marathon is already uploaded on YouTube. We've got amazing response. If in case you guys have not seen, boss, you'll have to see that. You're missing out on something. Okay, now quickly to tell you guys, yes, which all chapters will be covering in this marathon. Firstly, yes, out of 10 chapters, 6 chapters will be covered. In 10 chapters, 1 chapter is anyways theory. Out of 9 chapters, 6 chapters is covered. Close to 70% of the syllabus is covered in the most exhaustive, detailed way. All concepts are done, master questions are done, past paper MTP, whatever tricky adjustments were there, that is also done. So which all chapters are covered? In this order classes will be there. First we'll be having assignment, then we'll be having transportation, then we'll be having game theory. Yes, game theory is newly added. So many students feel it is very difficult, but trust me, we have made it very simple. Okay, a cakewalk. Simulation we are having business application of Maxima Minima. Again, so many students would not be understanding what exactly is happening. Boss, we have made it simple for you guys. Okay, and we are also having learning curve. Chapters which are not covered currently right now, LPP, network analysis, business forecasting and data analytics, which is theory. Now, yes, if in case you guys want us to come up with part 2 of the marathon wherein we cover this as well, boss, you'll have to show some love. Share it to all your CMA final friends. Tell one beautiful, crazy, QT marathon is there. Yes. Put in your comments, valuable comments. If in case so many students are requesting, definitely will come up with part 2 as well. Now, if in case you are a CMA Inter student, you are having, yes, OMSM, there also these chapters will be there. Assignment, transportation and simulation. So even if you are a CMA Inter student, assignment, transportation, simulation, you can be referring these chapters in the most detailed way, elaborate way we have done it. Is this clear everyone? Yes, now some additional things. Yes, for CMA final students, yes, we are having our classes for the subject of SCM and SFM. Trust me, group 3, 2 big papers, we'll be learning those entire 2 papers logically, conceptually, using simple relatable stories, and ensure that we finish off the entire subject without having the need to by heart even a single formula. Boss, where to purchase the classes? Simple. You can visit our website www.thinkwithtabish.com, or if you're having any queries, you can just contact 83102 Perfect everyone. Okay, demo lectures are available, sufficient number of videos are available. Yes, videos are recorded exclusively for CMA final, exclusively for you guys. So take benefit out of the same. And yes, SCM SFM marathon is also available. So please do refer the same. Yes, and if in case you want access to the files which the faculty has written, yes, whatever the running notes they've made, yes, we are having beautiful colored concept books. Okay, where to get that? Yes, you can just go to our Telegram group, Think with Tabish. Yes, Telegram group, its name is Think with Tabish. So please go to the Telegram group. There you will get access to the concept notes, the PDF files. Is this clear, everyone? That's all for this video. Yes, now onwards will be the marathon by Taisir sir. Do watch it. Yes, I'm requesting you guys, if you have loved the video, only if you have loved the video, and I'm sure you will definitely love the video, please do share it to all your CMA final friends. Do put in your valuable feedback. It really means a lot. A lot of hard work has gone in the background to ensure that we give this top-notch quality in the lowest possible duration. And whenever a new student comes, sees the video, they will not be seeing the entire video to judge if the video is good or not. What is it that they will be doing? They'll see the comments. So if in case it has added value to you and they see good comments, they'll get the motivation. They'll know that, okay boss, this is adding value. So humble request I'm making, if this has added value, and I'm sure it will definitely add 100% value to your preparation, please do put in your valuable comments. It really means a lot. So from here onwards, it is going to be the detailed marathon for QT in a simple, logical way by our own, very own Taisir sir. All the very best, my dear students.
Hi, hello, namaste. This is Mohammad Taisir Ali, and I hope you guys are doing well. Let's get started with the very first chapter of this marathon series, assignment. Assignment is a very interesting concept, but most importantly, it's one of the easiest chapter in your entire syllabus. Now, before we start solving an assignment problem, first let's try and understand what is an assignment problem. A lot of you out there, including me, have this crazy food cravings at the most random times of the day. But thanks to Swiggy and Zomato, all our midnight cravings is no longer a problem. Today, using this exact example of Swiggy and Zomato and how they deliver the food, we'll try and understand what is an assignment problem. Here's the scenario. 3 people placed orders from 3 different restaurants, that is order 1, order 2 and order 3, and there are 3 delivery partners, driver A, driver B and driver C, who can complete the delivery. Now, a driver can take up any delivery, but since all the drivers and all the restaurants are spread across different parts of the city, the time taken by every driver to complete every delivery is going to be different. Now, this data is given to you in this matrix. Suppose driver A is assigned with order number 1, he will take 25 minutes. If driver B is assigned with order number 1, he will take 15 minutes. Similarly, every value in this matrix represents the time taken by every driver to complete each delivery. Now, your goal is to ensure all the orders are delivered to the customers at the earliest time. Using this data, you will have to decide which driver takes up which order so that the total delivery time is minimum. Let's try solving this question. Based on mere observation, tell me which driver should be assigned to order number 1. Is it driver A, driver B or driver C? Since B is the fastest option, order number 1 is assigned to driver B. Moving on, for order number 2, among A, B and C, tell me which is the best option. Since B is the fastest option here, order number 2 is also assigned to driver B. Now coming to the last order, that is order number 3, A takes 20 minutes, B takes 15 minutes and C takes 30 minutes. Tell me which driver should be assigned. Since B can complete this delivery at the earliest time, order number 3 is also assigned to driver B. Now we have ensured all the orders are delivered to the customers. But here's the question. Is this the best solution? Let's try and analyze that. Suppose order 1, order 2 and order 3, all the 3 orders were placed at 10 p.m. Since B is the one who is going to deliver the food, B starts at 10 p.m., picks order number 1 and at 10:15 order number 1 is delivered. He'll again start at 10:15, picks order number 2 and after 10 minutes, that is 10:25, order 2 is delivered. Since all the 3 orders are assigned to a single driver, B will again start at 10:25, picks order number 3 and at 10:40, order 3 is delivered. Now let me ask you guys a question. Order 3 was placed at 10 p.m. and the customer had to wait for 40 minutes to get his food delivered. Do you think the customer is going to be happy? Absolutely not. Even if he had considered the worst scenario for order 3, that is driver C, who is the slowest driver, the food would have been delivered in 30 minutes. Now this delay happened because a single driver was assigned with multiple orders. Our approach was wrong, but we take out a key learning which is going to be core and fundamental principle of an assignment problem. In an assignment problem, one person is only assigned to one task and one task is only assigned to one person. Now this is called as 1:1 allocation. So what exactly is assignment problem? Let's look into that. Assignment problem is a method of assigning a set of resources. Now resources can be workers, machines, people to a set of tasks on a one-to-one basis, meaning each person gets exactly one task and each task is handled by exactly one person, such that the total cost of the total time is minimized or the total profit is maximized. What is assignment problem? It is a way of assigning a set of resources to a set of tasks on a one-to-one basis so that the total time or total cost is minimized or the total profit is maximized. As discussed earlier, always ensure while solving an assignment problem, this condition is satisfied. That is, each person is assigned to exactly one task and each task is assigned to exactly one person. Now coming back, in the initial approach, since a single driver was assigned with multiple orders, our approach was wrong. But now we know what an assignment problem is. Let's try solving this question again. Now the objective is reframed. The goal is to ensure all the orders are delivered to the customer at the earliest time, also keeping in mind that a single driver can only be assigned to one order. Let's try solving this question using trial and error method. Tell me, for order number 1, which driver should be assigned? Is it A, B or C? Since B takes the least time, order 1 is assigned to driver B. Moving on, for order number 2, among A, B and C, B takes the least time to complete order 2. But since B is already assigned to order number 1, this assignment is not possible. So the next best option we have is driver A. So order number 2 is assigned to driver A. Now if you observe carefully, driver A and driver B are already assigned with a task. So the only option for order number 3 is driver C. So the last order is assigned to driver C. Now we have ensured that all the customers get their food delivered and the 1:1 rule is also followed. Let's calculate the total delivery time for this combination. So the total time is going to be 15 plus 25 plus 30, that is 70 minutes. Now tell me, is this the right solution? I don't think so. For that reason, we'll try out one more combination. Now for order number 3, instead of driver C, I'll assign it to driver A. For order number 2, instead of driver A, I'll assign it to driver B. And for the very first order, instead of driver B, I'll assign it to driver C. Now we have ensured that all the orders are delivered to the customers and the 1:1 rule is also followed. Let's calculate the total delivery time for this particular combination. So the total delivery time is 20 plus 10 plus 20, which is 50 minutes. For sure, this combination is better than the previous one, but I am still not sure if this is the best solution. For that reason, I will try out all the combination that is possible for this particular matrix. So for a 3 cross 3 matrix, the total number of combination we'll have is 3 factorial, which is 6 different combination. If I go through each combination one by one and calculate the total delivery time, I'll get the combination where the total delivery time is minimum. Assignment problem is successfully solved. But here's the catch. Now instead of 3 orders and 3 drivers, what if we have 10 orders and 10 drivers? If we use the same approach, the total number of combination for this particular scenario is 10 factorial, which is more than 36 lakhs. Now tell me, is this practically possible for us to go through each combination one by one and find the best solution? The answer is no. And that is exactly why a special method was introduced, specifically designed to solve an assignment problem. Now let's look at the different methods to solve an assignment problem. The first one is basic enumeration method, also known as trial and error method. The second one is simplex method, which comes in linear programming chapter. Transportation method can also be used to solve an assignment problem. But let me tell you, all the three methods are time consuming and inefficient. Therefore, a special method was developed using which any assignment problem can be solved efficiently, which is known as Hungarian method. In this chapter, we'll make use of Hungarian method and solve different variations of assignment problems. Now, based on the number of rows and number of columns, assignment problem can be of two types. It's either balanced problem or unbalanced problem. For a given question, if the number of rows and number of columns are equal, then it is a balanced problem. On the other hand, if the number of rows and number of columns are unequal, it is an unbalanced problem. Let's look at a few examples to identify the difference between a balanced problem and unbalanced problem. If you have a look at example number 1, we have 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. Since the number of rows and number of columns are equal, the given question is a balanced problem. Moving on to example number 2, here we have 1, 2, 3 rows and 1, 2, 3, 4 columns. Since the number of rows and number of columns are unequal, the given example is an unbalanced problem. This concludes unit number 0, that is basics of assignment problem. Now let's go on to unit number 1 and discuss how to solve an assignment problem using Hungarian method. Keep in mind, be it any assignment problem, before you start applying Hungarian method, there are two necessary conditions that needs to be verified. Only after verifying these two conditions, you can start solving the problem. Condition number 1 is to check if the given question is balanced or not. We'll do this by counting the number of rows and number of columns. Condition number 2 is to look into the objective of the question and identify if the given question is a minimization problem or a maximization problem. Once both the conditions are verified, you can start solving the question using Hungarian method. Now, Hungarian method is a 5-step process. If I directly start explaining you guys each step of Hungarian method, you guys will find it difficult and confusing. For that reason, we'll solve an assignment problem and subsequently discuss each step of Hungarian method. Let's solve this question. What does the question say? A factory has 4 workers and there are 4 tasks that needs to be completed. Now, a worker can take up any task, but due to the varying efficiency of every worker, the time taken by each worker to complete every task is going to be different. Now, this data is given to you in this matrix. Now, using this data, your goal is to assign each worker to exactly one task so that the total time taken to complete all the tasks is minimum. This is the question in hand. Let's solve this question. As discussed earlier, be it any assignment question, before you start solving it using Hungarian method, there are two necessary conditions that needs to be verified. Condition number 1 is to check if the given question is balanced or not. We do it by counting the number of rows and number of columns. The given question has 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. Since the number of rows and number of columns are equal, the given question is balanced. Condition number 1 is verified. Condition number 2 is to look into the objective of the question and identify if the given question is a minimization problem or a maximization problem. Now, before we verify condition number 2, let's understand something very important. Based on the objective of the question, an assignment problem can be of two types. It's either a minimization problem or a maximization problem. If the given question is in terms of cost or time, then the goal is to minimize the total cost or minimize the total time, which is nothing but a minimization problem. On the other hand, if the given question is in terms of profit, sales or revenue, your goal flips. Now your goal is to maximize the total profit or maximize the total sales, which is a maximization problem. Let me ask you guys a question. If I am running a business, tell me what would I want? Would I want to earn maximum profit or would I want to earn minimum profit? The answer is obvious. My goal is to earn maximum profit, which is nothing but a maximization problem. Now, based on the type of the objective, the approach with which you solve an assignment problem can change slightly. If the given question is a minimization problem, no tension, no drama, straight away you can start solving the question. But if the given question is a maximization problem, you'll have to make slight changes, slight adjustments, convert it into a minimization problem and then solve it. Do not worry, later on in this marathon video, we'll discuss how to solve a maximization problem. Now coming back, in the given question, it is clearly mentioned, minimize the total time. Therefore, it is a minimization problem. Condition number 2 is also verified. Now we can start solving the question using Hungarian method. So step number 1 is going to be row operation. What exactly is row operation? We'll be visiting every row of the matrix one by one. For every row, first we'll identify the smallest value and subtract it from every element of that row. Coming to the very first row, the values here are 5, 9, 3 and 5. Tell me which is the smallest value here. The smallest value here is 3. Now once I've identified the smallest value, I'll subtract this value from every element of this row. As a result, I'll have 5 minus 3, that is 2. 9 minus 3 gives me 6. 3 minus 3 is 0 and 5 minus 3 is 2. Similarly, row operation is performed for all the rows. Now before we proceed further, let's try and understand what is row operation and the importance of 0 in an assignment problem. Now if you have a look at this matrix carefully, you'll notice that among all the jobs, worker 1 takes the least time to complete task C, that is 3 hours. So after performing row operation, this value has become 0. Therefore, in an assignment problem, 0 represents the best choice to make an assignment. Now what about all the other non-zero values? Now we know that for worker 1, the best choice we have is task C. But instead of task C, if worker 1 is assigned with task B, he'll have to work for 2 extra hours. That is shown here. Instead of task C, if worker 1 is assigned with task B, he'll have to work for 6 extra hours. That is shown here. Instead of task C, if worker 1 is assigned with task A, he'll have to work for 2 extra hours. That is shown here. So always remember, in an assignment problem, 0 represents the best choice to make an assignment and all the non-zero values represents the extra cost or the extra time incurred if the best choice is not made. Now let's perform row operation for the remaining rows. Coming to row number 2, the values here are 2, 2, 6 and 8. Tell me which is the smallest value here. The smallest value here is 2. Now subtracting 2 from every element of this row, we'll have 2 minus 2, that is 0, 2 minus 2 is 0, 6 minus 2 gives me 4 and 8 minus 2 is 6. Coming to row number 3, the values here are 9, 2, 6 and 7. Tell me which is the smallest value here. The smallest value here is 2. Now subtracting 2 from every element of the third row, we have 9 minus 2, that is 7, 2 minus 2 is 0, 6 minus 2 is 4 and 7 minus 2 gives me 5. Now let's perform row operation for the last row. The values here are 6, 4, 9 and 8. Tell me which is the smallest value here. The smallest value here is 4. Now subtracting 4 from every element of the last row, we have 6 minus 4, that is 2, 4 minus 4 is 0, 9 minus 4 is 5 and 8 minus 4 gives me 4. Step 1, that is row operation, is completed. Now step number 2 is column operation. This step is very similar to step number 1. The only difference here is instead of every row, this operation is performed along every column. So here we'll be visiting every column one by one. For every column, first we'll identify the smallest value and subtract it from every element of that column. Coming to the first column, the values are 2, 0, 7 and 2. Tell me which is the smallest value here. The smallest value here is 0. Now subtracting 0 from every element of this column, we'll have 2 minus 0, that is 2, 0 minus 0 is 0, 7 minus 0 is 7 and 2 minus 0 gives me 2. If you notice, even after performing column operation, the first column remains unchanged. Now why did this happen? In this column, the smallest value is 0. Now subtracting 0 from a number is not going to change that number. 2 minus 0 is 2, 5 minus 0 is 5, 10 minus 0 is 10. So always remember, while performing row operation or a column operation, if a row or column already has a 0, then that particular row or column remains unchanged. Moving on, column number 2 already has a 0, so this column remains unchanged. So we'll write 6, 0, 0, 0. Now moving to column number 3, there is already a 0 present in this column, so column 3 remains unchanged. So we'll write 0, 4, 4 and 5. Now coming to the last column, the values here are 2, 6, 5 and 4. Tell me which is the smallest value here. The smallest value here is 2. Now subtracting 2 from every element of this column, we'll have 2 minus 2, that is 0, 6 minus 2 is 4, 5 minus 2 is 3 and 4 minus 2 is 2. Step 1 and step 2 is completed. Now if you observe carefully, after performing row operation and column operation, every row has at least one 0 and every column has at least one 0. We also know that in an assignment problem, 0 represents the best choice to make an assignment. So now can I start making an assignment? The answer is no. In an assignment problem, assignments are only made once you are 100% sure that the given matrix is optimal. For that reason, we'll perform step number 3, that is optimality test, by drawing minimum number of lines. Keep in mind, the goal here is to not draw lines randomly to cover all the zeros. If you follow this approach, your answer is going to be wrong and you'll end up losing your marks. The goal here is to make use of minimum number of lines and cover all the zeros. Now this means that I'll have to draw lines in that row or column where you have maximum number of zeros. This is one of the most important steps in an assignment problem. I'll tell you guys a fact. While solving an assignment problem, this is that one particular step where a lot of students commit mistake. To ensure you guys don't make the same mistake, I'll teach you guys a simple trick so that you guys ensure you don't make a mistake. So the first step is to identify the maximum number of zeros in a row or column. We'll do this by counting the number of zeros for every row and every column. So first row has 2 zeros, row 2 has 2 zeros, third and fourth row has 1 zeros respectively. Along the column number 1 has 1 zeros, column number 2 has 1, 2, 3 zeros, column 3 and column 4 has 1 zeros respectively. Once you have counted the number of zeros for every row and every column, you will notice that column number 2 has maximum number of zeros, that is 3. Therefore, right now my priority is all the rows and columns where there are 3 zeros. So I will draw the first line along column number 2. Once a line is drawn, look for any other rows or columns where you can find 3 zeros. Since there are no more rows or columns having 3 zeros, priority 3 is exhausted. Now I will shift my priority to all the rows and columns having 2 zeros. Row number 1 has 2 zeros, so I will draw a line along row number 1. If you notice, row number 2 had 2 zeros initially. Since this 0 is already covered by a line, right now we only have 1 zeros. Line cannot be drawn. See if there are any more rows or any more columns where you can find 2 zeros. I can't find any. Therefore, priority 2 is also exhausted. Finally, my priority are all the rows and columns having single 0. Now this is the only 0 left in the matrix. So I can either draw a line this way or this way. The choice is yours to make. So I'll draw the last line along column number 1. Now keep in mind, once the lines are drawn, you'll count the number of lines drawn and the number of rows in the matrix. So I've made use of 3 lines and there are 4 rows in the matrix. Since the number of lines drawn and the number of rows are unequal, the given matrix is not optimal. We'll have to go to step number 4 and obtain an improved matrix. Now before we obtain an improved matrix, let's pause for a moment and do one more example on optimality test. Now I've taken one more example just to ensure that you guys don't make a mistake while performing optimality test. We'll use the same trick. The first step is to identify the maximum number of zeros in a row or column. We'll do this by counting the number of zeros for every row and every column. Row number 1 has 2 zeros. Row 2 has 2 zeros. Row number 3 has 2 zeros. Row number 3 and row number 4 has 3 zeros respectively. Along the column, column number 1 has 2 zeros. Column number 2 has 2 zeros. Column number 3 has 2 zeros. Column number 4 has 2 zeros. And the last column has 4 zeros. Once you have counted the number of zeros for every row and every column, tell me what's the maximum number of zero in a row or column. That is 4. Therefore, right now my priority are all the rows and columns where you have 4 zeros. So I'll draw the first line along column number 4. Once a line is drawn, see if there are any more rows or columns where you can find 4 zeros. I can't find any, therefore priority 4 is exhausted. Now I'll shift my priority to all the rows and columns having 3 zeros. If you notice, row number 4 has 1, 2, 3 zeros. So I'll draw a line along row number 4. Row 5 had 3 zeros initially, but since this zero is already covered, right now we only have 2 zeros. See if there are any more rows or any more columns where you can find 3 zeros. I can't find any. Therefore priority 3 is also exhausted. Now I'll shift my priority to all the rows and columns having 2 zeros. Column number 1 has 2 zeros. So I'll draw the line along column number 1. Row 5 has 2 zeros. So I'll draw a line along row number 5. See if there are any more rows or any more columns where you can find 2 zeros. I can't find any. Therefore priority 2 is also exhausted. Finally, my priority is going to be all the rows and columns having a single zero. Now this is the only zero left in the matrix. So I can either draw a line this way or this way. The choice is yours to make. So I'll draw the last line along row number 1. Keep in mind, once the lines are drawn, calculate the number of lines drawn and the number of rows in the matrix. We've made use of 5 lines and there are 5 rows in the matrix. Since the number of lines drawn and the number of rows are equal, the given matrix is optimal. You can straight away go to the final step and start making an assignment. So let's have a quick overview of what exactly is optimality test. So the first step here is to make use of minimum number of lines and cover all the zeros. I've already taught you guys the trick to do it properly. Once the lines are drawn, calculate the number of lines drawn and the number of rows. If the number of lines and number of rows are equal, the given matrix is optimal. This means you can directly go to the final step and start making an assignment. On the other hand, if the number of rows and number of lines drawn are not equal, the given matrix is not optimal. You'll have to go to step number 4 and obtain an improved matrix. I hope this is clear. Now let's come back to the question which we were solving. So in this example, since the number of lines drawn and the number of rows are unequal, the given matrix is not optimal. Therefore, we'll have to go to step number 4 and obtain an improved matrix. Now if you observe carefully, after performing optimality test, you'll notice 2 types of elements. Elements that are covered by lines and elements that are not covered by any lines, which are called as uncovered elements. So the very first step is to find the smallest uncovered value and subtract it from all the uncovered elements. So the uncovered elements here are 4, 4, 4, 3, 5 and 2. Tell me which is the smallest uncovered value? That is 2. Once you have identified the smallest value, you will subtract this from all the uncovered elements. As a result, I'll have 4 minus 2, that is 2. 4 minus 2 is 2. 3 minus 2 gives me 1, 4 minus 2 is 2, 5 minus 2 is 3 and 2 minus 2 is 0. Let me explain you this step again. The very first step is to identify the smallest uncovered value, that is 2, and subtract it from all the uncovered elements. As a result, I have obtained this value. Now step number 2 is to take the same value and add this value to all the intersection elements. Now intersection elements are the elements that are passing through two lines. If you observe carefully, you'll notice a plus symbol like this. So the given matrix has two intersection elements. Now adding 2 to both the intersection elements, we'll have 2 plus 2, that is 4, and 6 plus 2 gives me 8. All the remaining values in the matrix that are elements passing through single line are written as it is. No changes are made. So I'll write 0 0, 0 0, 7 0 and 2 0. Improved matrix is obtained. So what did we do here? Let me explain it again. The first step is to find the smallest uncovered value, that is 2, and subtract it from all the uncovered elements. As a result, I have obtained these values. Step number 2 is to take the same value and add this value to all the intersection elements. As a result, I have obtained these values. All the remaining values in the matrix are written as it is. No changes are made. So tell me, can I start making an assignment now? The answer is still no. As we have already discussed, assignments are only made if you are 100% sure that the given matrix is optimal. We'll use the same trick to cover all the zeros in the matrix using minimum number of lines. The first step is to identify which row or column in the matrix has maximum number of zeros. We'll do this by counting the number of zeros for every row and every column. Row number 1 has 2 zeros, row 2 has 2 zeros, row number 3 has 1 zero, and the last row has 2 zero. Along the column number 1 has 1 zero, column number 2 has 3 zeros, column number 3 has 1 zero, and the last column has 2 zeros. Once you have counted the number of zeros for every row and every column, tell me what's the maximum number of zeros in a row or column? That is 3. Therefore, right now my priority is going to be all the rows and columns having 3 zeros. I'll draw the first line along column number 2. Once a line is drawn, see if there are any more rows or any more columns having 3 zeros. I can't find any. Therefore, priority 3 is exhausted. Now I'll shift my priority to all the rows and columns having 2 zeros. If you observe carefully, row number 1 has 2 zeros. So I'll draw a line along row number 1. Column number 4 had 2 zeros initially, but since this 0 is already crossed out, right now this column has only 1 0. So I cannot draw a line. See if there are any more rows or any more columns having 2 zeros. I can't find any. Therefore, priority 2 is also exhausted. Finally, my priority is going to be all the rows and columns having single 0. Now, these are the only zeros left in the matrix, and there is no way we can connect both the zeros using a single line. So for this particular 0, I can either draw a line this way or this way, and for this particular 0, I can either draw a line this way or this way. So I'll draw a line along column number 1 and draw a line along row number 4. We've made use of minimum number of lines and covered all the zeros. Keep in mind, once the lines are drawn, you'll have to count the number of rows and the number of lines used. There are 4 rows in the matrix and have made use of 4 lines. Since the number of lines used and the number of rows are equal, the given matrix is optimal. I can straight away go to the final step and start making assignment. This is the last step of solving an assignment problem, that is making assignment. Now before you start making an assignment, make sure you copy all the values from the previous matrix. I've done this here. Now assignment is performed systematically by performing row scanning and then column scanning. First we'll begin with row scanning. Examine each row one by one and look for the row that has exactly 1 zero. If a row has 2 zeros, ignore that row. If a row has 3 zeros, ignore that row. But if a row has exactly 1 zero, make an assignment by boxing the 0. Coming to row number 1, you'll notice that there are 2 zeros. So I'll ignore this row. Moving on, row number 2 has multiple zeros. So I'll again ignore this row. Coming to row number 3, you will notice that there is exactly 1 0. So I will make an assignment here by boxing the 0. Now what does this mean? This means that worker 3 is assigned to job B. Keep in mind, once an assignment is made, all the zeros along its row and column are crossed out. So I will cancel both the zeros. Now this particular step is performed to indicate that this particular worker and this particular job is no longer available for assignment. Coming to the last row, there was 2 zeros initially, but since this 0 is already crossed out, right now we have exactly 1 0. So I will make an assignment here by boxing the 0. As discussed earlier, once an assignment is made, we will have to make sure that all the zeros along its row and column are cancelled. Therefore, I will cancel this 0. Row scanning is done. Now let's perform column scanning. You will examine each column one by one and look for the column that has exactly 1 0. If a column has 2 zeros, ignore that column. If a column has 3 zeros, ignore that column. But if a column has exactly 1 0, make an assignment by boxing the 0. Coming to column number 1, you will notice that there is exactly 1 0. So I will make an assignment here by boxing this 0. As discussed earlier, once an assignment is made, all the zeros along its row and column should be cancelled. Since this 0 is already crossed out, there is nothing new to cancel here. Now this particular operation is performed to indicate that this particular worker and this particular task is no longer available for assignment. Moving to column number 2, assignment is already made here. Coming to column number 3, you will notice that there is exactly 1 0. So I will make an assignment here by boxing the 0. Once an assignment is made, all the zeros along its row and column should be cancelled. Since this 0 is already crossed out, there is nothing new to cancel here. Assignment problem is successfully solved. Now keep in mind, once all the assignments are done, you will have to write down all the assignments in the form of a table. Let me write down all the assignments. Worker 1 is assigned to task C. Worker 2 is assigned to task A. Worker 3 is assigned to task B. And the last worker, that is worker 4, is assigned to task D. Once all the assignments are written down, in the next column, write the time taken for each assignment. Now keep in mind, this value is not taken from the previous matrix. Instead, this value is taken from the initial matrix. For your reference, I have kept the initial matrix next to the table. So if worker 1 is assigned to task C, he will take 3 hours. If worker 2 is assigned to task A, he will take 2 hours. If worker 3 is assigned to task B, he will take 2 hours. If worker 4 is assigned to task D, he will take 8 hours. Therefore, the total time taken to complete all the tasks is 3 plus 2 plus 2 plus 8, which is 15 hours. Assignment problem is successfully solved. Now let's have a quick overview of Hungarian method. Step number 1 is row operation. What do we do here? We'll visit every row of the matrix one by one. For every row, first we'll identify the smallest value and subtract it from every element of that row. Once row operation is performed for all the rows, we'll go to step number 2, that is column operation. Very similar to row operation. The only difference here is, instead of every row, this operation is performed for every column. For every column, first we'll identify the smallest value. Once you have identified the smallest value, you will subtract it from every element of that column. Once row operation and column operation is performed, you will notice that every row in the matrix has at least 1 0 and every column in the matrix has at least 1 0. We have also discussed that in an assignment problem, 0 represents the best choice to make an assignment. So now can I start making an assignment? The answer is no. In an assignment problem, assignments are only made once you are 100% sure that the given matrix is optimal, that the given matrix is going to give you the best solution. For that reason, we'll perform step number 3, that is optimality test. The first step here is to make use of minimum number of lines and cover all the zeros in the matrix. Now keep in mind, the lines used can either be vertical or horizontal. diagonal lines cannot be used. I've also taught you guys a simple trick on how to get this step right. Once the lines are drawn, you'll have to count the number of lines drawn and the number of rows in the matrix. If the number of lines drawn and the number of rows are equal, this means that the matrix is optimal. You can straight away go to the final step and start making assignment. But if the number of lines and the number of rows are unequal, this means the matrix is not optimal. You'll have to go to step number 4 and obtain an improved matrix. Now, how to obtain an improved matrix? After performing optimality test, you will notice that there are two types of elements. Elements that are covered by lines and elements that are not covered by any lines, which are called as uncovered elements. The first step is to identify the smallest uncovered value and subtract it from all the uncovered elements. Step number 2 is to take the same value and add this value to all the intersection elements. Now, intersection elements are the elements that are passing through two lines. All the remaining values in the matrix are kept as it is. No changes are made. So, how to obtain improved matrix? The first step is to identify the smallest uncovered element. Let's say this value is k. Step number 2 is to subtract this value from all the uncovered elements, add this value to all the intersection elements. All the remaining values in the matrix that are elements passing through single line are kept as it is. No changes are made. Now, the final step of Hungarian method is making assignment. Now, assignment is done by performing row scanning and column scanning. First, we'll perform row scanning. You'll examine each row one by one and look for the row that has exactly 1 0. If you find a row with exactly 1 0, make an assignment by boxing the 0. Once you make an assignment, cancel out all the zeros along the rows and columns of that particular assignment. Once you perform row scanning for all the rows, you can start with column scanning. This is very similar to row scanning. You will examine each column one by one and look for the column that has exactly 1 0. If a column has multiple zeros, ignore that column. Once you identify a column with a single 0, make an assignment by boxing that 0. Once an assignment is made, all the zeros along its row and column should be crossed out. Row scanning and column scanning is done again and again until all the zeros in the matrix are either crossed or assigned. This is how you solve any assignment problem using Hungarian method. The next topic is assignment problem with multiple solutions or alternate solutions. We'll understand this by solving a question. So this is the cost matrix for the given question. The objective here is to identify which worker to be assigned to which job so that the total cost required to complete all the job is minimum. Let's try solving this question. Now, since this is a marathon video and we do have a time constraint, we'll directly go to the final step, that is making assignment, and understand how to make assignments if a given question has multiple solutions. Now, assignment is done by performing row scanning and column scanning. First, we'll begin with row scanning. I'll examine each row one by one and make an assignment if a row has exactly 1 0. If a row has multiple zeros, I'll ignore that row. Coming to row number 1, if you observe carefully, there is exactly 1 0. So I'll make an assignment here by boxing the 0. As discussed earlier, once an assignment is made, all the zeros along its row and column are crossed out. Therefore, this 0 is cancelled. Moving to row number 2, we have multiple zeros here. Assignment is not possible. Moving to row number 3, there are more than 1 zeros. Assignment is not possible. Now coming to the last row, there are more than 1 zeros. Unique assignment is not possible. Now let's perform column scanning. I'll examine each column one by one and make an assignment if a column has exactly 1 0. If a column has multiple zeros, I'll ignore that column. Coming to the very first column, if you observe carefully, there is exactly 1 0. So I'll make an assignment here by boxing this 0. As discussed earlier, once an assignment is made, all the zeros along its row and column are crossed out. Therefore, both the zeros are cancelled. Now coming to column number 2, we have multiple zeros here. Assignment is not possible. Coming to column number 3, there are more than 1 zeros here. Unique assignment is not possible. Assignment is already made in column number 4. Now if you notice, Even after performing row scanning and column scanning, all the assignments are not made. Right now we have a special scenario. If you observe carefully, there are no rows which has exactly 1 0 and there are no columns which has exactly 1 0. Now this particular scenario indicates that the given question has multiple solutions. Now how to make all the assignments if a question has multiple solutions? Keep in mind, when a question has multiple solutions, you can box any 0 arbitrarily as per your choice. Coming to row number 2, if you observe carefully, we have two zeros here. So I can either box this 0 or this 0. The choice is totally yours. We'll consider both the scenarios. So this is going to be solution number 1 and this is going to be solution number 2. In the first solution, I'll make an assignment here. As already discussed, once an assignment is made, all the zeros along its row and column are crossed out. Therefore, both the zeros are cancelled. Now coming to row number 3, if you observe carefully, we have exactly 1 0. So I can make an assignment here. All the assignments are made successfully. Now let's look into solution number 2. Now instead of this 0, we'll box this 0. Once an assignment is made, all the zeros along its row and column are crossed out. Therefore, both the zeros are cancelled. Now coming to row number 3, if you observe carefully, there is exactly 1 0. So yes, I can make an assignment. So I'll make an assignment here by boxing the 0. Solution number 1 and solution number 2 is obtained. Now let's calculate the total time or the total cost for this particular assignment. Let me mark all the assignments made for solution number 1, that is 80, 80, 100 and 90. Now let's calculate the total cost for the completion of all the jobs, that is 80 plus 80 which is 160 plus 100 that is 260 plus 90 that is 350. Now for solution number 2, let me mark all the assignments made, that is 80, 70, 110 and 90. So what is the total cost for the completion of all the jobs for solution number 2, that is 80 plus 70 which is 150 plus 110 that is 260 plus 90 which is 350. Now if you observe, for solution 1 and solution 2, the assignments made are different but the final value, that is the total cost, is same. So keep in mind, if a given question has multiple solutions, the assignments made can be different but the optimal value, that is minimum cost or maximum profit, will be same for all the solutions. I hope this is clear. Let's begin with unit number 2, where we learn about special adjustments in an assignment problem. So far we have learned how to solve an assignment problem using Hungarian method. Now let me remind you, Hungarian method is the foundation to solve any assignment problem in this particular chapter. But before we apply Hungarian method, we'll have to make few checks and adjustments depending on the type of the question. As we have already discussed earlier, be it any assignment problem, before you start solving the question using Hungarian method, you'll have to verify two necessary conditions. Condition number 1 is to check if the given question is balanced or not. Condition number 2 is to look into the objective of the question and identify if it is a minimization problem or a maximization problem. If the given question is a minimization problem, condition number 2 is also verified. Now Hungarian method can only be applied if both the conditions are verified. Now let me ask you guys a question. How to solve an assignment problem if these conditions are not verified? That is exactly what we are going to learn in this particular unit. We look at 4 different cases here. In the first case, we learn how to solve an assignment problem if it is unbalanced. In case number 2, we learn how to solve an assignment problem if the objective is maximization. Now the third one is a special case. We learn how to solve an assignment problem if it is unbalanced and the objective here is maximization. Finally, we learn how to solve a restricted assignment problem. We learn each of these cases one by one understand the logic, and learn how to make these adjustments before applying Hungarian method. Let's move to the first special case. Using these two examples, we'll learn how to solve an unbalanced problem. As we have already discussed before we apply Hungarian method, these two conditions has to be satisfied. Only if these conditions are verified, we can proceed further and apply Hungarian method. Now the first condition is to check if the given question is balanced or not. We do it by counting the number of rows and number of columns. For example number 1, if you observe carefully, we have 1, 2, 3, 4 rows, 1, 2, 3 columns. Since the number of rows and number of columns are unequal, the given matrix is unbalanced. Now remember, we can only proceed further if this is converted into a balanced problem. If you look carefully, this particular matrix has 4 rows and 3 columns. This means we'll need one extra column to make it balanced, and for that reason, I'll introduce a dummy column. And since this is a dummy column, all the entries in this column will be 0. Now the matrix is balanced, condition number 1 is verified, we can proceed further and solve this question. Let's move to example number 2. First let's check if the given question is balanced or not. We'll do it by counting the number of rows and number of columns. If you observe carefully, this particular example has 1, 2, 3 rows, 1, 2, 3, 4 columns. Since the number of rows and number of columns are unequal, the given matrix is unbalanced. Remember, we can only proceed further if this is converted into a balanced problem. If you look carefully, we have 3 rows here and 4 columns. This means we'll need one extra row to make it balanced. For that reason, I'll introduce a dummy row here, and since this is a dummy row, all the entries in this row will be 0. Now this matrix is balanced, condition number 1 is verified, we can go ahead and solve this question. So always keep in mind, if the given problem is unbalanced, you must make it balanced by either adding a dummy row or a dummy column. All the entries in a dummy row or dummy column will be 0. Now let me ask you guys one more question. When should we make use of dummy row and when should we make use of dummy column? Let's look into that. If I look at example number 1, initially we had 4 rows and 3 columns. Since the number of columns were less than the number of rows, we made use of a dummy column. In example number 2, initially we had 3 rows and 4 columns. Since the number of rows were less than the number of columns, we made use of a dummy row. So keep in mind, we make use of a dummy row or dummy column depending on which side is short. I hope this is clear. Let's move to the next special case, that is solving an assignment problem where the objective is maximization. You guys already know that assignment problem is solved using Hungarian method. Here's the fact. Hungarian method is specifically designed only to solve a minimization problem. So how to solve an assignment problem if the objective is maximization? The trick is simple. You'll convert the given maximization problem into a minimization problem. That is, the given profit matrix is converted into a loss matrix, also known as opportunity loss matrix. Let's look into this with the help of an example. This is the given profit matrix for the question. Since this is a maximization question, the first step is to convert it into a minimization problem by finding the opportunity loss matrix. The first step is to identify the maximum value from the entire matrix. Let me repeat it. Find the highest value from the entire matrix. If you have a look at this matrix carefully, you'll notice that among all the elements, the highest value is 20. Once you have identified the highest value, subtract every element of the matrix from this value. That is 20 minus 10, 20 minus 14, 20 minus 8, 20 minus 12, 20 minus 8. Similarly, every value in this matrix is subtracted from this value. Let's obtain opportunity loss matrix. So 20 minus 10 is going to be 10. 20 minus 14 is going to be 6. 20 minus 8 is going to be 12. 20 minus 12 is going to be 8. Similarly, every value in this matrix is subtracted from 20. 20 minus 8 is 12. 20 minus 12 is 8. 20 minus 16 is 4. 20 minus 14 is 6. 20 minus 6 is 14. 20 minus 10 is 10. 20 minus 12 is 8. 20 minus 8 is 12. Coming to the last row, 20 minus 8 is 12. 20 minus 20 is 0. 20 minus 14 is 6. 20 minus 12 is 8. We have successfully obtained the opportunity loss matrix. Now this opportunity loss matrix represents that the given maximization problem is converted into a minimization problem. So once you have obtained opportunity loss matrix, you can apply Hungarian method on this particular matrix and all the assignments can be made. So remember, if the given question is a minimization problem, Hungarian method can be applied directly. But if the given question is a maximization problem, first you will have to obtain an opportunity loss matrix. Now how to obtain opportunity loss matrix? The first step is to identify the maximum value in the entire matrix, that is 20. Once you have identified the maximum value, you will subtract every element of the matrix from this value. As a result, you will obtain opportunity loss matrix. Now on this opportunity loss matrix, you will apply Hungarian method and all the assignments are made. Let's move on to the next special case. So far we have already discussed two cases. We have learned how to solve an assignment problem if it is unbalanced, and we have also learned how to solve an assignment problem if the objective is maximization. Now let's have a look at the third case. Here we learn how to solve an assignment problem if it is unbalanced and the objective is maximization. Let's understand this with the help of this example. What does the question say? A factory has 4 workers and there are 3 tasks that needs to be completed. Suppose worker 1 is assigned with task 1, the company earns a profit of 10,000 rupees. If worker 1 is assigned with task 2, company earns a profit of 7,000 rupees. Similarly, every value in this matrix represents the profit earned by the company if a worker is assigned with the task. Now using this data, you will have to decide which worker to be assigned to which task so that the total profit earned by the company is maximum. As we have already discussed earlier, before we solve any assignment problem, there are 2 necessary conditions that needs to be satisfied. The first condition is to check if the given question is balanced or not. We'll do it by counting the number of rows and number of columns. The given matrix has 4 rows and 3 columns. Since the number of rows and number of columns are unequal, the given matrix is not balanced. In order to proceed further, we'll have to convert this matrix into a balanced matrix. Now how do we do it? If you observe carefully, the given matrix has 4 rows and 3 columns. This means I'll have to add an extra column to make it balanced. For that reason, in order to make it balanced, I'll add a dummy column, and since this is a dummy column, all the entries in this values are 0. Condition number 1 is verified. Now let's look at condition number 2. Condition number 2 is to look into the objective of the question and identify if it is a minimization problem or a maximization problem. In the question it is clearly mentioned, maximize the total profit. Therefore it is a maximization problem. Now to proceed further, we'll have to convert this matrix into a minimization problem. And that is done by obtaining an opportunity loss matrix. Now how to obtain opportunity loss matrix? From this particular matrix, first we'll identify the maximum value. If you observe carefully, the maximum value in the entire matrix is 12. Once you have identified the maximum value, you will subtract all the values of the matrix from this value. That is 12 minus 10, which is 2, 12 minus 7, that is 5, 12 minus 8 gives me 4, 12 minus 0 gives me 12. Similarly, every value in this matrix is subtracted from this value. As a result, we obtain this matrix. Condition number 2 is also verified. Now we can apply Hungarian method step by step and make all the assignments. Step number 1 is performing row operation. For every row, First we'll identify the smallest value and subtract it from every element of that row. Coming to the very first row, the values here are 2, 5, 4, 12. Tell me which is the smallest value here. The smallest value here is 2. Now subtracting 2 from every element of this row, we'll have 2 minus 2, that is 0. 5 minus 2 gives me 3. 4 minus 2 gives me 2. 12 minus 2 gives me 10. Similarly, row operation is performed for all the rows. As a result, this matrix is obtained. Now step number 2 is column operation. Very similar to row operation. We'll visit every column one by one. For every column, first we'll identify the smallest value and subtract it from every element of that column. In the first column, the values are 0, 1, 5 and 0. Tell me which is the smallest value here. The smallest value here is 0. Now subtracting 0 from every element of this column, we'll have 0 minus 0, that is 0. 1 minus 0 gives me 1. 5 minus 0 is 5. 0 minus 0 is 0. Column 1 remains unchanged. Similarly, column operation is performed for all the columns, and as a result, we obtain this matrix. Now keep in mind, after performing row operation and column operation, if you observe carefully, every row has at least one 0 and every column has at least one 0. Now in an assignment problem, 0 represents the best choice to make an assignment. So now can I start making assignment? The answer is no. In an assignment problem, assignment are only made if you are 100% sure that your matrix is optimal. For that reason, we perform step number 3, that is optimality test. The goal here is to make use of minimum number of lines and cover all the zeros in the matrix. Earlier in this marathon video, I've taught you guys a trick on how to get this step right. We'll be using the same trick. The first step is to identify which row or which column has maximum number of zeros. We'll do this by counting the number of zeros for every row and every column. Now tell me, what's the maximum number of zeros in a row or column? That is 3. Therefore, my priority is going to be all the rows and columns where you have 3 zeros. Row number 2 has 3 zeros, so I'll draw a line along row number 2. Row number 4 has 3 zeros, so I'll draw a line along row number 4. There are no more rows and no more columns where you have 3 zeros. Priority 3 is exhausted. Now I'll shift my priority to all the rows and columns having 2 zeros. Row number 1 has 2 zeros, so I'll draw a line along row number 1. Now there are no more rows and no more columns having 2 zeros. Priority 2 is exhausted. I'll shift my priority to all the rows and columns having single 0. Now this is the only 0 left in the matrix, so I'll draw the last line along column number 2. Once the lines are drawn, count the number of lines drawn and the number of rows in the matrix. So I've made use of 4 lines and there are 4 rows in the matrix. Since the number of lines and number of rows are equal, the given matrix is optimal. Now I can straight away go to the final step and start making assignment. Improved matrix is not required. Now let's go to the final step and start making assignment. Now assignment is performed by doing row scanning and column scanning. First we'll begin with row scanning. We'll examine each row one by one and look for the row that has exactly 1 0. If a row has multiple zeros, ignore that row. Row number 1 has multiple zeros, so I'll ignore that row. Row 2 has multiple zeros, I'll ignore this row. Coming to row number 3, if you observe, there is exactly 1 0. So I'll make an assignment here by boxing this 0. As we have already discussed, once an assignment is made, all the zeros along its row and column are crossed out. Therefore, both the zeros are cancelled. Now coming to the last row, we have multiple zeros here. Unique assignment is not possible. Now let's perform column scanning. I'll examine each column one by one and look for the column that has exactly 1 0. Coming to the first column, we have multiple zeros here. Assignment cannot be made. Assignment is already made in column number 2. Coming to column number 3, we have multiple zeros here. Unique assignment is not possible. Now coming to the last column, if you observe carefully, we have exactly 1 0. So I'll make an assignment here by boxing the 0. Once an assignment is made, all the zeros along its row and column are crossed out. Therefore, this 0 is cancelled. Now if you notice, even after performing row scanning and column scanning, all the assignments are not made in this matrix. We have a special situation here. There are no more rows and no more columns where you can find exactly 1 0. No more unique assignments are possible. Now this particular situation indicates that the given question has multiple solutions. Now for a question, if multiple solutions exist, then you can box any 0 arbitrarily as per your choice. Coming to row number 1, we have two choices here. So I can either box this 0 or this 0. I'll go ahead and make an assignment here. Once an assignment is made, all the zeros along its row and column are crossed out. Therefore, both the zeros are cancelled. Now, if you have a look at the last row carefully, you will notice that there is exactly 1 0. So I can make an assignment here by boxing this 0. All the assignments are made. Now keep in mind, once all the assignments are made, you'll have to write down all the assignments in the form of a table. Worker 1 is assigned to task 1. Worker 2 is assigned to dummy column. Worker 3 is assigned to task 2. Worker 4 is assigned to task 3. I have shown all the assignments made. In the next column, I will write down the profit earned for each assignment. Now keep in mind, this particular value is not taken from this matrix. Instead, this particular value is taken from the initial matrix. For your reference, I have kept the initial matrix next to the table. So if worker 1 is assigned to task 1, a profit of 10,000 rupees is earned by the company. If worker 2 is assigned to dummy, no profit is earned. If worker 3 is assigned to task 2, a profit of 12,000 rupees is earned by the company. If worker 4 is assigned to task 3, a profit of 8,000 rupees is earned by the company. Therefore, the total profit earned is 10 plus 12 plus 8, which is 30,000 rupees. The given assignment problem is solved. Let's move on to the last special case, that is the restricted assignment problem. To understand this, we'll make use of a real world example. Imagine a big director, let's say Rajamouli. He is making a new movie, and for this movie, he is casting 3 actors for 3 different roles. Technically, any actor can be assigned to any role, but the cost of assigning each actor for every role is different. This data is given to you in this matrix. Here's the catch. Actor B is a mega superstar and he says, I'll never play the role of a villain. Now this means actor B cannot be assigned to this role. This assignment is not possible. Similarly, actor C is a very talented actor, but due to his age, director doesn't want to cast him as the hero of the movie, which means actor C cannot be assigned to this role. This assignment is not possible. Now this particular scenario, wherein an assignment problem where you have certain restrictions is called as a restricted assignment problem. Now the question is, how to solve an assignment problem where you have these restrictions? The trick is simple. Whenever you have restrictions in an assignment problem, mark these values as m or infinity. Now m tends to a very large number. Let's do that. So instead of this value, and since there are restrictions here, I'll mark these values as m. Once this is done, as usual, you'll solve this problem using Hungarian method. The given restricted assignment problem is solved successfully. Now let's understand how is this done. For this particular matrix, if I apply row operation and column operation, you'll notice that this particular value remains unchanged. Let me tell you how. Infinity minus 2 is infinity. Infinity minus 10 is infinity. Infinity minus 100 is infinity. We have also learned that in an assignment problem, assignments are only made for 0 values. Since these values will never become 0, assignments here are avoided automatically using Hungarian method. The given assignment problem is successfully solved. So remember, if an assignment is restricted or not possible, mark it as m or infinity. Once this is done, you'll solve the problem as usual using Hungarian method. The given assignment problem where you have restrictions is solved successfully. I hope this is clear. Let's have a quick revision of the entire chapter using a simple flowchart. Here we'll cover how to solve any assignment problem and all the preliminary checks that we have to make. We'll see how to solve an assignment problem if it is unbalanced, how to solve an assignment problem if the objective is maximization, how to solve an assignment problem if there are any restrictions, and we'll also see step by step how to solve an assignment problem using Hungarian method. Let's dive into this flowchart. So the moment you get an assignment problem, the first thing you'll do is count the number of rows and number of columns and see if the given question is balanced. If the number of rows and number of columns are equal, the matrix is balanced, you can proceed further. If the number of rows and number of columns are unequal, the given matrix is unbalanced, you cannot proceed further. Now in order to proceed further, you'll have to convert it into a balanced problem. Now this is done by introducing a dummy row or dummy column. Since this is a dummy row or dummy column, all the values in this row or column are 0. Once this is done, you look into the objective of the question and identify if the given question is a minimization problem or a maximization problem. Now keep in mind, Hungarian method is specifically designed only to solve a minimization problem. So if the given question is a minimization problem, you'll proceed further. But if the given question is a maximization problem, in order to proceed further, you'll have to convert it into a minimization problem. Now how is this done? This is done by obtaining an opportunity loss matrix. Now what are the steps to be followed to obtain an opportunity loss matrix? From the previous matrix, the first thing you'll do is identify the maximum value from the entire matrix. I'll repeat it, you'll find the maximum value from the entire matrix. Once you've identified the maximum value, you'll subtract every element of the matrix from this value. As a result, the new matrix obtained is an opportunity loss matrix. Once this is done, you'll see if there are any restrictions mentioned in the question. If there are any restriction, you'll introduce m or infinity and proceed further. We have made all the initial verification that is required. Now we can start solving the question using Hungarian method. Step number 1 is row operation. You'll visit every row one by one. For every row, first you'll identify the smallest value. Once you have identified the smallest value, you'll subtract every element of a row from this value. You'll perform this operation for all the rows. Step number 2 is column operation. Very similar to row operation, but this operation is performed along every column. For every column, first you'll identify the smallest value. Once you have identified the smallest value, you'll subtract every element of the column from this value. You'll repeat this step for all the columns. Now after step 1 and step 2, that is row operation and column operation, you will notice that every row in the matrix has at least 1 0 and every column in the matrix has at least 1 0. We have also discussed that in an assignment problem, 0 represents the best choice to make an assignment. So now can I start making an assignment? The answer is no. We can only make assignment if you are 100% sure that the matrix is optimal, and for that reason we'll perform optimality test. Now how to perform optimality test? This is done by drawing minimum number of lines to cover all the zeros. I'll repeat it. You'll cover all the zeros in the matrix using minimum number of lines. If you can make use of 4 lines and cover all the zeros in the matrix, you'll have to use 4 lines. You cannot use 5 lines. Once the lines are drawn, you'll count the number of lines drawn and the number of rows in the matrix. If the number of lines drawn and the number of rows in the matrix are equal, the given matrix is optimal. You can straight away go to the final step. But if the number of lines drawn and the number of rows are unequal, the matrix is not optimal. You'll have to obtain an improved matrix. Now how to obtain improved matrix? From the matrix on which you performed optimality test, you'll notice that there are 2 types of elements. Elements that are covered by lines and elements that are not covered by any lines, which are called as uncovered element. The first step is to identify the smallest uncovered value from all the uncovered element. You'll have to find the smallest uncovered value from all the uncovered element. Let's say this is x. So step number 2 is to subtract this value from all the uncovered element and add this value to all the intersection elements. Now intersection elements are the elements that are passing through 2 lines. Now all the remaining elements in the matrix that are elements passing through single line are kept as it is. No changes are made. As a result, the new matrix obtained is an improved matrix. So on this improved matrix, you will again perform optimality test by following the same procedure, and once this is done, you will count the number of rows and number of lines used. If the number of lines and number of rows are equal, the given matrix is optimal. You can go to the final step and start making assignment. Now how is assignment made? Assignment is done systematically by performing row scanning and then column scanning. First we will begin with row scanning. We will examine each row one by one and look for the row that has exactly one zero. If a row has multiple zeros, you will ignore that row. But if a row has exactly one zero, make an assignment there by boxing the zero. Once an assignment is made, all the zeros along its row and column are crossed out. Now this is performed for all the rows. Once you have examined all the rows, you will begin with column scanning. Similar to row scanning, you will examine each column one by one and look for the column that has exactly one zero. If a column has multiple zeros, you will ignore that column. But if a column has exactly one zero, you will make an assignment there by boxing the zero. Once an assignment is made, all the zeros along its row and column are crossed out. Now row scanning and column scanning are continued until all the zeros in the matrix are either covered or boxed. Now this is how you solve any assignment problem. I hope this is clear. Let's begin with the next chapter, transportation. So what exactly is a transportation problem? Let's understand that with the help of a simple story. The hero of the story is Raj. Right from a young age, Raj always wanted to be a businessman. He was smart, he was passionate, and he had one thing that made him different, his vision. Now Raj's dad used to run a small bread business, a small setup just behind their house. He used to make breads in small batches and supplied it to nearby bakeries. But the breads he made was soft, fluffy, and perfectly baked. His dad had cracked the secret to make the perfect bread. Now Raj saw the bigger picture here. Right after graduating from college, he took a bold step and set up the first bread manufacturing factory in Bangalore. Now imagine this is the map of Bangalore. So Raj set up the first bread manufacturing factory right in the heart of Bangalore. He named his brand Bread Raja because when it comes to bread, he is the king. He was passionate and most importantly hardworking. Soon the people of Bangalore fell in love with his brand. Sales boomed, and as of today he owns not one but 3 different factories across different locations in Bangalore. He set up his second factory here and he set up the third factory here. Now let's talk about consumers, people who buy bread. Breads are required in almost every household, be it for breakfast, sandwiches or late night toast. Now this means consumers of bread are spread across every street, every location of Bangalore. Now let's say I live here. Every morning I go to a nearby bakery and buy bread. Now think from Raj's perspective. If I want to buy bread from his brand, then he'll have to ensure that his bread is available in this bakery. Now how does he get it there? He has 3 options. He can either send it from this factory, or he can send it from this factory, or he can send it from this factory. Now the big question is, from which factory should he send it? Now what you'll have to understand here is, transporting an item from one place to another incurs a cost, and this cost is called as transportation cost. Now this means transporting an item from a faraway factory is going to cost high, and transporting an item from a nearby factory will cost less. Now Raj has to be very smart and make the right call. So if he transports bread from the first factory, transportation cost is rupees 10. If he supplies bread from the second factory, transportation cost is rupees 8 per unit. And if he transports bread from the third factory, transportation cost is rupees 5 per unit. Practically speaking, the best option is this particular factory because the transportation cost is minimum. The goal is to minimize the transportation cost. Therefore, this is the best choice, and we'll supply bread to this bakery from this particular factory. Now here's the catch. Right now we discussed about this particular bakery, but there are hundreds of bakeries all across Bangalore present in every street and every locality. Now each of these bakeries will require bread from Raj's company. Let's say this particular bakery sells around 50 packets of bread every single day. This means every day this bakery will require 50 packets of bread. Similarly, each of these bakery will demand for a certain number of breads based on the customer requirement. Now there are hundreds of bakeries all across Bangalore, but there are only 3 factories which can supply bread to all these bakeries. Now tell me, can a factory make unlimited breads? Absolutely not. Each factory can only make limited quantity of bread. If this particular factory makes 1000 units of bread every single day, this means we can only supply up to 1000 packets of bread to different bakeries. We cannot transport or we cannot supply more than 1000 units of bread. Similarly, each of these factories has a certain supply limit, which means these factories can only transport those many number of breads that it manufactures. Now comes the real challenge. Making the bread is not the challenge anymore. Delivering the bread to the right location at the cheapest cost is the real challenge. Now you will have to ensure all these bakeries get the exact number of bread as it demands, and you will have to decide how many breads to be transported from this factory, how many breads to be transported from this factory, how many breads to be transported from this factories to all these bakeries such that the total transportation cost is minimum. So Raj's challenge is deciding how many units of bread to be transported from which factory to which bakery such that each bakery gets the exact number of bread it requires. No factory sends more than what it has, and most importantly, the total transportation cost is minimal. Minimizing the total transportation cost is the heart of a transportation problem. Now this exact scenario, this decision making process where you have multiple factories and multiple delivery points and deciding how to transport goods from factories to delivery points in the cheapest way possible is what we call as transportation problem. Today companies like Zomato, Swiggy, Instamart, all these companies use this to plan deliveries every single day. So what exactly is a transportation problem? Let's look into the definition. Transportation problem is a special type of business problem where goods or products are transported from multiple factories to multiple destinations. Now destinations can be warehouses, shops or retail outlets in such a way that the total transportation cost is minimized. In simple words, transportation is how to deliver goods or products from factories to warehouses in the cheapest way possible. As we have already discussed, while solving a transportation problem, you'll have to ensure that the supply value should be utilized, meaning no factory supplies more than what it has. So if a factory has a supply value of 1000 units, it can only transport up to 1000 units. It cannot transport more than 1000 units. Similarly, the demand value should be fulfilled. You'll have to ensure that each destination gets exactly what it needs. If a warehouse has demanded for 50 units of a product, you'll have to ensure that 50 units of products are transported there. You cannot transport 45, you cannot transport 46, you'll have to transport 50 units of bread. So while solving a transportation problem, supply value should be utilized and the demand value should be fulfilled. Now let's have a look at the structure of the transportation table with the help of the example that we discussed. Now in the example that we discussed, Raj owned 3 factories, that is factory 1, factory 2 and factory 3. Now the breads manufactured in these factories were supplied to multiple bakeries all across the city. But for now, we'll consider 3 bakeries, that is bakery 1, bakery 2 and bakery 3. So in a transportation problem, factories are represented along the rows and destinations or delivery points are represented along the columns. Now tell me, can a factory make unlimited breads? Absolutely not. Each factory has a certain limit, has a certain capacity on the number of breads it can make. So the number of breads each factory can make and supply is called as the supply value. So for each factory, we'll write its supply value in the last column. Now let's say factory 1 makes 350 units of bread every single day. Now this means this is the supply value of factory 1 and I'll write it in front of factory 1 in the last column, that is 350. Similarly, factory 2 makes 200 units of bread every single day and factory 3 makes 150 units of bread every single day. Now let's talk about demand. Based on the customer requirement and business happening in each locality, every bakery will demand for a certain number of breads. So the quantity of bread each bakery requires or demands is called as the demand value. So for each bakery, we'll write its demand value in the last row. Let's say bakery 1 has demanded for 100 units of bread. So this is the demand value of bakery 1 and I'll write it in front of bakery 1 in the last row. Similarly, bakery 2 has demanded for 200 units of bread and bakery 3 has demanded for 300 units of bread. Now comes the most important part, the cost of transportation from each factory to each bakery. This is written here. So if breads are transported from factory 1 to bakery 1, let's say the cost of transportation is rupees 3 per unit. If breads are transported from factory 1 to bakery 2, let's say the cost of transportation is rupees 5 per unit. Similarly, every value here represents the cost of transportation for every route. This is how a transportation problem looks like. This is the structure of a transportation table. Now in your exams, all this data will be given to you and using this data, you'll have to decide how many units of bread should be transported from which factory to which bakery such that each factory transports only those many number of bread it has. Each bakery gets the exact number of bread it demands and most importantly, the total cost of transportation is minimum. So in a transportation problem, factories are represented along the rows, destinations or delivery points are represented along the column. Now the supply value of each factory is represented in the last column. Similarly, the demand value for each destination is written in the last row. And the most important thing, that is the cost of transportation per unit for each route is written here. I hope now you guys have got a basic idea of what is a transportation problem and you've also understood the structure of a transportation table. Moving on to the next concept, that is balanced versus unbalanced transportation problem. Now based on the total supply and total demand, transportation problem can be of two types, that is balanced transportation problem and unbalanced transportation problem. So for a given problem, if the total supply and the total demand are equal, then the given question is a balanced problem. On the other hand, if total supply is not equal to the total demand, the given question is an unbalanced problem. Let's understand this with the help of an example. Now tell me if this particular problem is a balanced one or an unbalanced problem. For that, we'll have to calculate the total supply and total demand. The total supply here is 250 plus 200 plus 150, which is 600, and the total demand is 100 plus 200 plus 300, which is again 600. Since the total supply and the total demand are equal, which is 600, the given question is a balanced one. Let's have a look at one more example. Tell me if this particular problem is a balanced one or unbalanced one. Let's find that out by first calculating total supply and total demand. The total supply here is 100 plus 400 plus 200, which is 700, and the total demand here is 150 plus 200 plus 100, which is 450. If you observe carefully, the total supply and total demand are not equal. Therefore, this is an unbalanced problem. Now, while solving a transportation problem, if the given question is unbalanced, first you'll have to make it balanced by adding a dummy row or dummy column. We'll discuss this later on in this video. Now, in transportation chapter, there are two types of solution. The first one is basic feasible solution and the second one is optimal solution. Now, basic feasible solution gives you a feasible plan. It tells you how many units to be transported from which factory to which destination. It satisfies all supply and demand values, but it does not ensure that the total transportation cost is minimum. It tries its best to minimize the total transportation cost, but it is not 100% guaranteed that the total transportation cost is minimum. Now the second type of solution is optimal solution. Now the meaning of the word optimal is the best. So in optimal solution, it tells you how many units to be transported from which factory to which destination, and it also ensures that the total transportation cost is minimum. It is 100% guaranteed that the transportation cost is minimum in optimal solution. So in your exam, two types of question can be asked. Either you can be asked to find basic feasible solution, or you can be asked to find optimal solution. In this particular chapter, in this particular video, we'll discuss how to find basic feasible solution and optimal solution in detail. Let's move on to unit number 1 and learn how to find basic feasible solution for a given transportation problem. Now similar to what you have already done in assignment chapter, before we find basic feasible solution, first we'll have to verify two conditions. Only after verifying these two conditions, you can find basic feasible solution for a problem. So the first condition is to look into the objective of the question and identify if the given question is a minimization problem or a maximization problem. Now 90% of the time, the objective will be minimization, where you'll have to minimize the total transportation cost. So if the objective is minimization, no changes are required, condition number 1 is verified, we can proceed further. But if the objective is maximization, you'll have to convert it into a minimization problem in order to proceed further. The steps followed, the procedure followed to convert a maximization problem into a minimization problem is similar to what you have already done in assignment chapter. Now condition 2 is to check if the given question is balanced or not. We've already learned this before. In a transportation problem, we check if the given question is balanced or not by computing the total supply and total demand. If total supply and total demand are equal, then the given question is a balanced problem. Condition number 2 is also verified. But if the given question is unbalanced, in order to proceed further, first we'll have to make it balanced by either adding a dummy row or dummy column as per the requirement. Do not worry, later on in this marathon video, we'll discuss how to solve an unbalanced problem, and we'll also see how to solve a problem where the objective is maximization. Now once both the conditions are verified, we can find basic feasible solution for a given problem. Now there are three different methods to find basic feasible solution. The first one is northwest corner method, the second one is least cost method, and the third one is Vogel's approximation method. Now generally what you'll notice is, if there are multiple methods to find solution for a given problem, the final value obtained is going to be same. But here, that is not the case. Total transportation cost obtained in northwest corner method, total transportation cost obtained in least cost method, and total transportation cost obtained in Vogel's approximation method may be same or may not be same. There is no surety that the final transportation cost obtained in all the three methods are going to be same. Now before applying any method, that is northwest corner method, least cost method or Vogel's approximation method, always make sure you perform initial verification. Only after performing initial verification, you are supposed to find basic feasible solution. Now let's go to the first method, that is northwest corner method. We'll use the same example and find basic feasible solution for all the three methods. Now the first method is northwest corner method. Northwest corner method is a jujube method. It is easiest among all the three methods. As we have discussed earlier, no matter which method you use, before we find basic feasible solution, we'll have to perform initial verification. Let's do that. So first condition is to check if the given question is a minimization problem or a maximization problem. Now in the question it is clearly given, minimize the total transportation cost. Therefore it is a minimization problem. Condition number 1 is verified. Now condition number 2 is to check if the given question is balanced or not. We've already discussed this. This is done by computing the total supply and total demand. Now the total demand here is 100 plus 200 plus 300, which is 600. And the total supply here is 250 plus 200 plus 150, which is again 600. Since total supply and total demand are equal, the given question is balanced. Condition number 2 is also verified. Now let's find basic feasible solution using northwest corner method. Now as the name suggests, in northwest corner method, we'll identify the northwest corner of the matrix and make allocation there. So what exactly is northwest corner of a matrix? Let's understand that. Now this arrow here represents north direction, this is south direction, this is west direction, and this arrow here represents east direction. Now let me draw a matrix around these directions. If this is north direction and this is west direction, then this particular arrow represents northwest direction. Now this means in a matrix, this cell right here is the northwest corner of a matrix. So the trick here is simple. All you have to do is identify the northwest corner of the matrix and make allocation there. So step number 1 is identifying the northwest corner of the matrix. Now in this particular matrix, this is the northwest corner, so we'll make allocation here. Now how many units should we allocate? Talking about allocation, there is a supply of 250 and the demand here is 100. So should we allocate 250 units or should we allocate 100 units? Now factory 1 has 250 units, it can transport up to 250 units, but bakery 1 has demanded for only 100 units. Since only 100 units are required, we'll allocate 100 units here. Now this means from factory 1, we'll be transporting 100 units to bakery 1. Mathematically speaking, allocation to be made is minimum of supply and demand. Among 250 and 100, the minimum value is 100, so we've allocated 100 units here. So keep in mind, no matter which method you use, allocation to be made is minimum of supply and demand. Now 100 units are allocated here, therefore supply of factory 1 becomes 250 minus 100, which is 150, and demand of bakery 1 becomes 100 minus 100, which is 0. If you observe carefully, bakery 1 had demanded for 100 units initially and it received 100 units from factory 1. Now this means bakery 1 does not require any more units. So we'll cross out column number 1 indicating that all the demand of bakery 1 is satisfied. Now suppose supply of factory 1 had become 0, we would have crossed out row number 1. So keep in mind, based on supply and demand, among which value becomes 0, we'll cross out the corresponding row or column. Now this is the revised matrix. Let's repeat the steps again. So the first step is to identify the northwest corner of the matrix. Now the northwest corner cell is this one, so we'll make allocation here. Now tell me, how many units should we allocate? Supply here is 150 and the demand is 200. Bakery 2 has demanded for 200 units. Bakery 2 has a requirement of 200 units, but there are only 150 units in factory 1. Since factory 1 can only transport up to 150 units, we'll allocate 150 units here. In simple words, allocation to be made is minimum of 150 and 200, which is 150. Now this means from factory 1, we'll transport 150 units to bakery 2. Since 150 units are allocated here, supply of factory 1 becomes 0 and demand of bakery 1 becomes 50. Now if you observe, factory 1 had 250 units initially, but right now all the units of factory 1 are exhausted. There are no more units left in factory 1. So we'll cross out row number 1 indicating that there are no more units left in factory 1 and factory 1 cannot transport any more units. Now this is the revised matrix. Let's repeat the steps again. So the first step is to identify the northwest corner of the matrix. Now this is the northwest corner of the matrix and we'll make allocation here. Now tell me, how many units should we allocate? The supply here is 200 and the demand here is 50. Among 50 and 200, the minimum value is 50, so I'll allocate 50 units here. Now this means from factory 2, we'll transport 50 units to bakery 2. Since 50 units are allocated here, supply of factory 2 becomes 150 and demand of bakery 2 becomes 0. All the demand of bakery 2 is exhausted, so we'll cross out column number 2 indicating that all the demand of bakery 2 is satisfied. Now this is the revised matrix. First step is to identify the northwest corner of the matrix, which is 6. Now tell me, how many units should be allocated here? The supply here is 150 and the demand is 300. Among 150 and 300, the minimum value is 150, so I'll allocate 150 units here. Since 150 units is allocated, supply becomes 0 and demand becomes 150. If you observe carefully, supply of factory 2 is exhausted, so we'll cross out row number 2. Now this is the only value left in the matrix. Supply here is 150 and demand is also 150, so I'll allocate 150 units here. Both supply and demand becomes 0. We have successfully solved the problem using northwest corner method. Now let's write down all the allocations that we have made. From factory 1, we have transported units to bakery 1 and bakery 2. The cost of transportation here is 5 and 3, and the number of units transported is 100 and 150. 5 into 100 is rupees 500 and 3 into 150 is rupees 450. Now from factory 2, we have transported units to bakery 2 and bakery 3. The transportation cost is 3 and 6. Number of units transported is 50 and 150. 3 into 50 is rupees 150 and 6 into 150 is rupees 900. From factory 3, we have transported units to only bakery 3. The cost of transportation is 5 and the number of units transported is 150. 5 into 150 is rupees 750. Therefore, the total transportation cost is 500 plus 450 plus 150 plus 900 plus 750, which is rupees 2750. This is how you find basic feasible solution using northwest corner method. I hope this is clear. Now let's have a quick recap. So in northwest corner method, the first step is to identify where to make allocation. As the name suggests, we'll identify the northwest corner or the topmost left cell of the matrix and make allocation. Now once you have identified the northwest corner of a matrix, step number 2 is making allocation. We'll compare the supply and demand values. Allocation made is minimum of supply and demand. Now once allocations are done, we'll subtract the allocated value from supply and demand. After this, you'll notice that one among supply and demand becomes 0 and we'll strike off that particular row or column. Now this is how we make allocation. Now once allocations are done, we'll get a revised matrix, and on this matrix, we'll repeat step number 1 and step number 2 until all the allocations are made. This is how we solve a question using northwest corner method. Now in this particular matrix, the first step is to identify the northwest corner of the matrix, which is 3. Now step 2 is making allocation. The supply here is 200 and the demand is 150. Now among 200 and 150, the minimum value is 150, so I'll allocate 150 units here. Once allocations are done, we'll update supply and demand. So supply becomes 200 minus 150, that is 50, and demand becomes 150 minus 150, that is 0. Now once this is done, one among supply and demand becomes 0. Since demand has become 0, we'll cross out column number 1. Suppose supply had become 0, we would have crossed out row number 1. Now this is how you solve a question using northwest corner method. I hope this is clear. The second method to find basic feasible solution is the least cost method. Now we'll use the same example and learn how to find basic feasible solution using least cost method. Now let me tell you, among all the 3 methods, the only difference is identifying where to make allocation. Steps followed or procedure followed to make allocation is same for all the 3 methods. We'll compare supply and demand values. Allocation made is minimum of supply and demand. Once allocation is done, we'll subtract the allocated value from supply and demand. Now once this is done, you'll notice that one among supply and demand becomes 0 and we'll cross out the corresponding row or column. So this is how we make allocation, and this is applicable for all the 3 methods, be it northwest corner method, be it Vogel's approximation method, or be it least cost method. Now in northwest corner method, we'll make allocation in the northwest corner or the topmost left cell of the matrix. Coming to least cost method, as the name suggests, we'll identify the least cost or the minimum value in the entire matrix. So the trick here is simple. All you have to do is identify the least cost or the minimum value in the entire matrix and make allocation there. Now let's solve this question using least cost method. So step number 1 is to identify the least cost among all the values. If you observe carefully, among all the values, the least cost is 2. So we'll make allocation here. Now tell me, how many units should we allocate? Talking about allocation, there is a supply of 150 and the demand here is 200. Now bakery 2 has demanded for 200 units. Bakery 2 has a requirement of 200 units. But factory 3 has only 150 units. Since there are only 150 units in factory 3, we'll allocate 150 units here. In simple words, allocation is minimum of 200 and 150, which is 150. Now this means from factory 3, we'll transport 150 units to bakery 2. Since 150 units is allocated here, supply becomes 0 and demand becomes 50. Since supply of factory 3 is exhausted, we'll cross out row number 3. Now these are the remaining values. Let's repeat the step again. So the first step is to identify the least cost or minimum value among all the values. So if you observe carefully, the least cost is 3, but 3 is present in multiple places. We have a 3 here, we have a 3 here, and we have a 3 here. Now the question is, where should we make allocation? Should I make allocation here? Should I make allocation here? Or should I make allocation here? Let's consider all the 3 options. Now if I go ahead with this option, the supply here is 100 and the demand is 200. Among 100 and 200, the minimum value is 100. So I can allocate 100 units here. Now if I go with this 3, supply is 50 and demand is 200. Among 50 and 200, the minimum value is 50. So I can allocate 50 units here. Now if I go with the third option, supply is 250 and demand is 50. Among 50 and 250, the minimum value is 50. So I can allocate 50 units here. Now tell me, why are we making all these allocations? What is the objective of a transportation problem? The objective of a transportation problem is to minimize the total transportation cost. I want you guys to pause for a moment and think about it. If I want to minimize the total transportation cost, then I'll have to make maximum allocation where the transportation cost is least. Now if you observe carefully, among the 3 options, I can allocate maximum units here. So I'll go with these options and not these options. So keep in mind, if there is a tie between least cost, if least cost is present in multiple places, then you'll have to select the one where maximum allocations are possible. This point is very important. Now this means from factory 2, we have transported 100 units to bakery 1. Since 100 units are allocated here, supply becomes 100 and demand becomes 0. Now demand of bakery 1 is exhausted, so we'll cross out column number 1, indicating that all the demand of bakery 1 is satisfied. Now these are the remaining values. Let's repeat the steps again. So the first step is to identify the least cost or the minimum value in the entire matrix. Now the minimum value here is 3, but 3 is present in multiple places. Now if I select this option, I can allocate 50 units, and if I select this option, I can again allocate 50 units. So no matter with which option I proceed further, I can only allocate 50 units. So the option is yours to make. You can either allocate here or you can allocate here. Now I'll go ahead with this option and allocate 50 units here. Now this means from factory number 1, we've allocated 50 units to bakery 2. Since 50 units are allocated here, demand becomes 0 and supply becomes 200. Since demand of bakery 2 is exhausted, we'll cross out column number 2. Now these are the only 2 values left in the matrix. Among 4 and 6, the minimum value is 4, so I'll allocate here. The supply is 200 and demand is 300. Among 200 and 300, the minimum value is 200, so I'll allocate 200 units here. Now supply becomes 0 and demand becomes 100. Now this is the only value left in the matrix. The supply here is 100 and demand is also 100, so I'll allocate 100 units here. Therefore, both supply and demand becomes 0. This is how you solve a question using least cost method. Now let's write down all the allocations that we have made. From factory 1, we have transported units to bakery 2 and bakery 3. The cost of transportation here is 3 and 4 and the number of units transported is 50 and 200. Now 3 into 50 is 150 and 4 into 200 is 800. Now coming to factory 2, we have transported units to bakery 1 and bakery 3. The cost of transportation here is 3 and 6 and the number of units transported is 100 and 100. 3 into 100 is 300 and 6 into 100 is 600. And finally, from factory 3, we have transported units to only bakery 2. The cost of transportation is 2 and the number of units transported is 150. 2 into 150 is rupees 300. Therefore, the total transportation cost is rupees 150 plus 800 plus 300 plus 600 plus 300, which is rupees 2150. This is how you solve basic feasible solution using least cost method. Now let's have a quick recap. In least cost method, step number 1 is deciding where to make allocation. As the name suggests, we'll identify the least cost or the minimum value in the entire matrix. Once you have identified the minimum value, we'll go to step number 2 and make allocation. You guys already know it. First, we'll compare the supply and demand values. Now, the minimum of supply and demand is the allocation to be made. Once allocation is done, we'll subtract the allocated value from supply and demand. After this, you'll notice that 1 among supply and demand becomes 0 and we'll strike off that corresponding row and column. Now, after making allocation, on the new matrix obtained, we'll repeat step 1 and step 2 until all the allocations are made. This is how you solve a given question using the least cost method. Now, there is one important point which you'll have to keep in mind. Now, in least cost method, in step number 1, when you are identifying the least cost, if there is a tie between least cost, if least cost is present in multiple places, then what you have to do? So, if there is a tie between least cost, you will have to select the one where maximum allocations are possible. Let's understand this with the help of an example. So, the values here are 4, 3, 3 and 6. So, in this particular matrix, the least cost is 3, but 3 is present in 2 different places. Now, if I select these options, the demand is 100 and the supply is 150. Among 100 and 150, the minimum value is 100, so I can allocate 100 units here. Now, if I select this option, the demand is 200 and supply is 150. Among 150 and 200, the minimum value is 150, so I can allocate 150 units here. Now, if you observe, among the two options, I can allocate maximum units here, so I'll make allocation here and not here. So, keep in mind, if there's a tie between least cost, then select the one where maximum allocations are possible. I hope this is clear. Now, let's go to the last method, which is Vogel's approximation method. Now, among all the 3 methods, Vogel's approximation method is the best one to find basic feasible solution. Now, in your exams, if it is clearly mentioned, use northwest corner method or use least cost method, then make use of the specified method to find basic feasible solution. But if no method is specified, make sure you use Vogel's approximation method to find basic feasible solution. Now, what you'll have to understand here is, in all the 3 methods, the only difference is identifying where to make allocation. The steps followed to make allocation is same in all the 3 methods. In northwest corner method, we make allocation in the northwest corner or the topmost left cell. In least cost method, as the name suggests, we'll make allocation in the least cost or the minimum value in the entire matrix. Now, coming to Vogel's approximation method. In Vogel's approximation method, we make allocation in the least cost. Vogel's approximation method is an extension of least cost method, but before we make allocation in the least cost, we'll have to compute something called as penalty. So, what exactly is penalty? Let's understand that. Now imagine you are buying a t-shirt online. Now the same t-shirt is available in 3 different websites, but the cost for the same t-shirt is different in all the 3 websites. If you buy this t-shirt from Myntra, you'll have to pay 300 rupees. If you buy this t-shirt from Ajio, you'll have to pay 320 rupees. And if you decide to buy this t-shirt from Amazon, you'll have to pay 350 rupees for the same t-shirt. Now tell me, from which website will you buy the t-shirt? It is very obvious. Since the t-shirt is cheapest at Myntra, this is the best option and you'll buy the t-shirt from Myntra. Now imagine this. You got unlucky and the t-shirt got sold out just now in Myntra. Now this means we cannot buy this t-shirt from Myntra. So the next best option you have is Ajio and you'll have to pay 320 rupees to buy the same t-shirt. This means you'll have to pay an extra cost of 20 rupees. Now if you had bought this t-shirt one day before, you could have bought it from Myntra and you could have paid 300 rupees. But since you missed the best choice, you have incurred a loss of 20 rupees. Now this extra cost that you have paid, the loss that you have incurred is called as penalty. In simple terms, penalty is the loss incurred if the best choice is not made. Mathematically, we can write this as penalty is the difference between least cost and the next least cost. In this case, the least cost is 300 and the next least cost is 320. Therefore, penalty is difference between 320 and 300, which is rupees 20. This implies that we have incurred a loss of 20 rupees for not picking the best option. I hope you guys have understood what is penalty. Now coming back to the question, in Vogel's approximation method, the first step is calculating penalty. Let's do that. In the first row, the values are 5, 3 and 4. Tell me which is the least cost. The least cost here is 3 and the next least cost is 4. Penalty is the difference between the least cost and the next least cost, that is 4 minus 3, which is 1. Now this means if we don't make an allocation here, if we don't pick the best option, then we'll incur a loss of 1 rupees. Now similarly, let's calculate penalty for all the remaining rows and column. In row number 2, the least cost is 3 and the next least cost is also 3. Therefore, penalty is the difference between least cost and the next least cost, that is 3 minus 3, which is 0. Moving to the last row, the least cost here is 2 and the next least cost is 4. 4 minus 2 is 2. Similarly, let's compute penalty for all the columns. In the first column, the least cost is 3 and the next least cost is 4. Penalty is the difference between least cost and the next least cost, that is 4 minus 3, which is 1. In the second column, the least cost is 2 and the next least cost is 3, therefore penalty is 1. In the last column, least cost is 5 and the next least cost is 4. Now the difference between 4 and 5 is again 1. Now we have computed penalty for all the rows and all the columns. Now if you observe carefully, among all the penalties computed, the maximum penalty is 2. Now this means the best choice here is 2, but if we don't make an allocation here, we'll have to make allocation here and we'll incur a loss of 2 rupees. Now our objective is minimization of the total transportation cost. So in order to minimize the total transportation cost, I'll have to avoid paying maximum penalty. I'll have to avoid the maximum loss incurred. So for that reason, I'll make allocation in this particular row. So why are we making this allocation? In order to avoid the maximum penalty, I'll be making allocation in this particular row. Now tell me, among 4, 2 and 5, which is the least cost or which is the minimum value? The minimum value here is 2. Therefore, I'll be making allocation here. So what did we do here? So first we computed penalty for all the rows and all the columns. Now penalty is the difference between the least cost and the next least cost. Once we have computed penalty, we compared all the row penalties and all the column penalties. You'll notice that the maximum penalty is 2. Now in order to avoid a maximum loss of 2 rupees, we'll make allocation in the least cost of this particular row. I hope this is clear. So what is step number 1? In step number 1, we'll calculate penalty for all the rows and columns. Once we have computed penalty for all the rows and columns, we'll identify the maximum penalty and make allocation in the least cost of that particular row or column. I hope this is clear. So now we will be making allocation here. Now tell me, how many units should we allocate? Supply here is 150 and demand is 200. Among 150 and 200, the minimum value is 150, so I'll allocate 150 units here. Now this means from factory 3, we'll transport 150 units to bakery 2. Therefore supply becomes 0 and demand becomes 50. Since all the supply of factory 3 is exhausted, we'll cross out row number 3. Now these are the remaining values. Let's repeat the same steps again. So first we'll compute penalty for all the rows and columns. Penalty is the difference between the least cost and the next least cost. Once all the penalties are computed, we'll identify the maximum penalty and make allocation in the least cost of that particular row or column. Now on the revised matrix, we'll repeat these steps until all the allocations are made. Let's do this. So step number 1 is calculating penalty. In the first row, the values are 5, 3 and 4. The least cost is 3 and the next least cost is 4. Now penalty is the difference between the least cost and the next least cost. That is 3 minus 4, which is 1. Now coming to row number 2, the least cost is 3 and the next least cost is also 3. Therefore penalty is 0. Now since we have crossed out row number 3, computation of penalty is not required here. Now let's calculate penalty along the column. In the first column, the least cost is 3 and the next least cost is 5. The difference between 3 and 5 is 2. In the second column, the least cost is 3 and the next least cost is also 3. Therefore penalty is 0. Coming to the last column, the least cost is 4 and the next least cost is 6. Now penalty is the difference between the least cost and the next least cost, that is 4 minus 6, which is 2. Step number 1 is done. We have computed penalty for all the rows and columns. Now let's compare all the penalty values and identify the maximum penalty. If you observe carefully, among all the computed penalties, the maximum penalty is 2, but we have a problem here. 2 is present in 2 different places. Now the question is, where should we make allocation? Should we make allocation in this particular column or should we make allocation in this particular column? Let's consider both the cases. Now if I go with this particular column, the values here are 5 and 3 and the least cost in this particular column is 3. Therefore I can make allocation here. Now if I go with option number 2, in this particular column, the least cost is 4. Now if you observe carefully, among 3 and 4, the least cost is 3. Therefore I will make allocation here and not here. So keep in mind, this point is very, very important. If there is a tie between maximum penalty, then select the least cost among all the tied penalties. Let's look at this example. In this particular example, among all the computed penalties, the maximum penalty is 2, but 2 is present in 2 different places. Now the question is, where should we make allocation? Should we make allocation in this particular row or should we make allocation in this particular row? Let's consider both the cases. In the first row, the minimum value is 2 and in the second row, the minimum value is 3. Now since 2 is less than 3, we'll make allocation here and not here. So remember this point. If there is a tie between maximum penalty, then select the least cost among tied penalties. Let's look at one more example. Now in this particular example, we have computed all the penalty values. The maximum penalty here is 2, but 2 is present in 2 different places. Now the question is, where should we make allocation? Should we make allocation here or should we make allocation here? Now in this particular row, the minimum value is 2 and in this particular column, the minimum value is again 2. Now if you observe, there is a tie between maximum penalty and there is again a tie between least cost. So in such cases, we have already discussed how to make selection in least cost method. If there is a tie between the least cost, select the one where maximum allocations are possible. Now since there is a tie between least cost, for this particular value we can allocate 150 units, and for this particular value we can allocate 100 units. Since maximum number of allocation is possible here, we will make allocation here and not here. So remember these two points. These are very important while solving Vogel's approximation method. So the first point says that if there is a tie between maximum penalty, select the least cost among the tied penalty. Here there is a tie between these two penalty. Since the least cost is 2, we will make allocation here and not here. Now point number 2 says, if there is again a tie between least cost, select the one where maximum allocations are possible. Now in this particular example, maximum penalty is 2 and there is a tie between maximum penalty. Now the least cost in this particular column is 2 and the least cost in this particular row is again 2. Now for this 2, we can make 150 units of allocation, and for this 2, we can allocate 100 units. Since maximum allocations are possible here, we will make allocation here and not here. I hope this is clear. Now let's come back to the question. Now among these two penalties, since the least cost is present here, we will make allocation here and not here. Now tell me, how many units should we allocate? Talking about allocation, there is a supply of 200 and there is a demand of 100. Now among 200 and 100, the minimum value is 100, so I will allocate 100 units here. Now this means from factory 2, we will transport 100 units to bakery 1. The supply becomes 100 and demand becomes 0. Since all the demand of bakery 1 is exhausted, we will cross out column number 1. Now these are the remaining values. Let's repeat the steps again. So the first step is calculating penalty. In the first row, the minimum value is 3 and the second minimum value is 4. Therefore penalty is 1. In the second row, minimum value is 3 and the next minimum value is 6. Therefore penalty is 3. Now along the column, in column number 2, minimum value is 3 and the next minimum value is also 3. Therefore penalty is 0. Now in the last column, minimum value is 4 and the next minimum value is 6. Therefore penalty is 6 minus 4, which is 2. Now once we have computed all the penalties, let's compare all the penalties and identify the maximum penalty. Now if you observe carefully, among all the penalties, the maximum penalty is 3. Therefore we will be making allocation in this particular row. Now if you observe carefully, among 3 and 6, the least cost is 3. Therefore we will allocate here. Now tell me, how many units should we allocate? Talking about allocation, there is a supply of 100 and the demand here is 50. Among 50 and 100, the minimum value is 50. So I will allocate 50 units here. Supply becomes 50 and demand becomes 0. Now since all the demand of bakery 2 is exhausted, we will cross out column number 2. Now these are the only two values left in the matrix. Now I will teach you guys a simple trick. In Vogel's approximation method, if there are only 2 or less than 2 values left in the matrix, then you can make use of least cost method to complete the remaining allocations. Now among 4 and 6, the minimum value is 4, so we will make allocation here. Now talking about allocation, supply here is 250 and demand here is 300. Now among 250 and 300, the minimum value is 250, so I will allocate 250 units here. Supply becomes 0, demand becomes 50. Now this is the only value left in the matrix. The supply here is 50 and demand is also 50, so I will allocate 50 units here. Therefore both supply and demand becomes 0. This is how you solve a question using Vogel's approximation method. I hope this is clear. Now let's compute the total transportation cost. So for this particular problem, the total transportation cost is 4 into 250, that is 1000, plus 3 into 100, which is 300, plus 3 into 50, which is 150, plus 6 into 50, which is 300, plus 2 into 150, which is 300. Now 1000 plus 300 plus 150 plus 300 plus 300 is rupees 2050. Therefore total transportation cost is rupees 2050. Now keep in mind Since this is a marathon video, I have directly computed the total transportation cost. But in your exam, make sure you use this format to compute the total transportation cost. Now let's have a quick recap of Vogel's approximation method. In Vogel's approximation method, step number 1 is deciding where to make allocation. So first we'll calculate penalty for every row and every column. Now penalty is the difference between the least cost and the next least cost. Once penalty is computed, we'll compare all the penalties and identify the highest penalty. Now we'll make allocation in the least cost of this particular row or column. Now this is how we identify where to make allocation. Now in step number 2, we'll make allocation. You guys already know it. We'll compare supply and demand values. Allocation made is minimum of supply and demand. Now once allocation is done, we'll subtract the allocated value from supply and demand. After this, you will notice that 1 among supply and demand becomes 0 and you'll strike off the corresponding row or column. Now once this is done, you'll get a new revised matrix, and on this revised matrix, you'll repeat step 1 and step 2 until all the allocations are made. Now we have used the same example and we learned how to find basic feasible solution using northwest corner method, least cost method and Vogel's approximation method. Now let's compare the total transportation cost obtained using all the 3 methods. So in northwest corner method, the total transportation cost obtained is rupees 2,750. In least cost method, the total transportation cost obtained is rupees 2,150. And in Vogel's approximation method, the total transportation cost obtained is rupees 2,050. Now if you observe carefully, the total transportation cost obtained using Vogel's approximation method is less than the total transportation cost obtained using least cost method, which is less than the total transportation cost obtained using northwest corner method. Now in a transportation problem, our objective is minimization of the total transportation cost. Therefore, Vogel's approximation method is the best method to find basic feasible solution. I hope this is clear. Now let's compare all the 3 methods. If you observe carefully, be it northwest corner method, least cost method or Vogel's approximation method, the only difference is deciding where to make allocation. Steps followed to make allocation is same in all the 3 methods. In northwest corner method, we make allocation in the northwest corner or the topmost left cell. Coming to lowest cost method or least cost method, we make allocation in the least cost or minimum value in the entire matrix. Now the third method is Vogel's approximation method. Now Vogel's approximation method may be lengthy, but it is one of the best methods to find basic feasible solution. So in Vogel's approximation method, first we'll compute penalty for all the rows and columns. Now penalty is the difference between the least cost and the next least cost. Once penalty is computed, we'll identify the maximum penalty and make allocation in the least cost of that particular row or column. Now this is the difference between northwest corner method, least cost method and Vogel's approximation method. Step number 2 is making allocation, which is same for all the 3 methods. Let's have a look at these important points. So point number 1 says that the total transportation cost obtained using Vogel's approximation method is less than or equal to the total transportation cost obtained using lowest cost method, which is less than or equal to the total transportation cost obtained using northwest corner method. Now this implies that Vogel's approximation method is the best method to find basic feasible solution. Now in your exams, if no method is specified, make sure you use Vogel's approximation method to find basic feasible solution. Now the last point says that the main difference between all the 3 methods lies in step number 1, that is deciding where to make allocation. The process of making allocation is common for all the 3 methods. Now this concludes unit number 1, where we have learned how to find basic feasible solution using northwest corner method, least cost method, and Vogel's approximation method. I hope this is clear. Let's go to Unit 2, where we learn how to find optimal solution for a given transportation problem. As you guys already know, in transportation problem, there are two types of solution. The first one is basic feasible solution and the second one is optimal solution. Now in basic feasible solution, there are three different methods: northwest corner method, least cost method, and Vogel's approximation method. Among all the three methods, Vogel's approximation method is the best method to find basic feasible solution. But there is one limitation of Vogel's approximation method. Now Vogel's approximation method tries its best to minimize the total transportation cost, but it is not 100% guaranteed that the final transportation cost obtained here is optimal. For that reason, we learn how to find optimal solution for a given transportation problem. Now let's understand the basic flow or basic structure of how to find optimal solution. So the first step here is to find the basic feasible solution using VAM. As you guys already know, VAM tries its best to minimize the total transportation cost, but it is not guaranteed that the solution obtained here is optimal. Now in order to be 100% sure on this particular solution that we have obtained, we will be performing optimality test. After performing optimality test, if it returns true, then this particular solution is optimal and we have successfully solved the question. But if not, if optimality test returns false, then this is not optimal solution and we'll have to obtain an improved matrix. This is the basic idea of how to find optimal solution. Let's understand this with the help of an example. Now we'll use the same example using which we learned how to find basic feasible solution using all the three methods. As you guys know, the first step here is to find basic feasible solution using VAM. We have already done it and this is the solution obtained. Now here the total transportation cost is rupees 2050. Now tell me, can we further minimize the total transportation cost? In order to answer this question, we'll be performing optimality test. If you guys remember, before we computed basic feasible solution, we had performed initial verification. We checked if the given question is balanced or not. Similarly, before we perform optimality test, we'll have to verify one condition. Only after verifying the condition, we can proceed further and perform optimality test. So the condition states that the number of allocations made should be equal to m plus n minus 1. Here m is the number of rows and n is the number of columns. Now let's count the number of allocations that we have made. So the number of allocations made are 1, 2, 3, 4, 5. So we have made 5 allocations here. Now let's compute the value of m plus n minus 1. Here we have 3 rows and 3 columns. Therefore m plus n minus 1 is 3 plus 3 minus 1, which is again 5. If you observe, number of allocations made and value of m plus n minus 1 are equal. Therefore the given solution is non-degenerate. The condition is satisfied. We can proceed further and perform optimality test. So keep in mind, based on number of allocations made, solution can be of two types. If number of allocations made and the value of m plus n minus 1 are equal, then the given solution is non-degenerate. We can proceed further and perform optimality test. But if the number of allocations made and the value of m plus n minus 1 are not equal, then the given solution is degenerate. We cannot proceed further and perform optimality test. Now let's perform optimality test and check if this solution obtained using VAM is optimal or not. Now optimality test is performed in two phases. In phase 1, we'll obtain U plus V matrix. Once this is done, we'll go to phase 2 and here we'll obtain delta Ij matrix. Now this might sound all confusing and complicated, but do not worry, we'll simplify this as much as possible and understand each of these phases one by one. Now let's jump into phase 1 and understand how to obtain U plus V matrix. If you observe carefully, in this particular matrix, we have two types of cells. Cells where we have made allocations, which are called as allocated cells, and cells where we have not made any allocations, which are called as unallocated cells. So in U plus V matrix, step number 1 is to copy all the cost values where we have made allocations. That is 4, 6, 3, 3 and 2. Now in U plus V matrix, we have introduced two new variables, U and V. Here U represents every row and V represents every column. Now this means the first row is U1, second row is U2 and third row is U3. Similarly, the first column is V1, the second column is V2 and the third column is V3. Now our goal here is to find all the U values and V values. Now in order to find all U values and V values, we'll assume any of U value or V value to be 0. So step number 2 is assuming any of U value or V value to be 0. Now in this particular matrix, I'll assume that value of U1 is 0. Now if you notice, this particular cost here corresponds to V3 and U1. This particular cost corresponds to U2 and V2. Similarly, every cost value here corresponds to a U value and a V value. So now we'll compute all U value and V values using a simple formula, that is cost is equal to U plus V. So using this formula and all these cost values, let's find all the U values and V values. So the formula to find all U values and V values is cost is equal to U plus V. Now here we have three variables, cost, U and V. Now tell me, if I know the value of any two variables, can I find the value of the third variable? The answer is yes. Let's understand this with the help of an example. Now let's say value of cost is 5 and value of U is 2. Tell me what is the value of V. Now the formula is cost is equal to U plus V. We are asked to find the value of V, therefore V is cost minus U. Now cost here is 5 and U is 2, therefore value of V is 5 minus 2, which is 3. Let's look at one more example. Let's say value of cost is 4 and value of V is 3. Now tell me what is the value of U. Now we know the formula is cost is equal to U plus V. Now since we are asked to find the value of U, U becomes cost minus V. Now cost here is 4 and V is 3, therefore U is 4 minus 3, which is 1. Now this means if I know the value of any two variables, I can find the value of third variable. So if cost is equal to U plus V, I can write V as cost minus U and I can write U as cost minus V. So if cost is U plus V, U becomes cost minus V and V becomes cost minus U. Now using these formulas and all these cost values, let's find all the U values and V values. Now let me tell you a simple trick here. All you have to do is assume this as a puzzle and play it smartly to find all U and V values. If you notice, this particular cost here corresponds to U1 and V3. Now value of U1 is 0, so using these two values we can find the value of V3. Now V is cost minus U, therefore V3 becomes 4 minus 0, which is 4. So using the value of U1 and this cost value, we have obtained the value of V3. Now this particular cost here corresponds to U2 and V3. Now the value of V3 is 4. So using these values, we can find the value of U2. Now U is cost minus V, therefore value of U2 is 6 minus 4, which is 2. Now similarly, let's find all U values and V values. So as we have discussed, the trick here is simple. We'll have to assume this is a puzzle, and by playing smartly, by playing it like a puzzle, we'll find all the U and V values. So here initially we made use of U1 and this cost value and computed the value of V3. Once we found the value of V3, with the help of V3 and this cost value, we computed the value of U2. This is nothing but a puzzle. With the help of two variables, we can find the value of third variables. Similarly, with the help of U2 and these cost values, we can find the value of V1 and V2. Let's do that. Now this particular cost here corresponds to U2 and V2. Now the value of U2 is 2. So using these two values, we can find the value of V2. We know V is cost minus U, therefore V2 becomes cost minus U2, that is 3 minus 2, which is 1. So with the help of U2, we computed the value of V2. Now let's find the value of V1. If you observe, this particular cost corresponds to U2 and V1. Now value of U2 is 2. So using these two values, we can find the value of V1. We know V is cost minus U, therefore V1 becomes 3 minus 2, which is 1. So now with the help of U2, we have also computed the value of V1. Now if you notice, this is the only value that is left out. If you observe carefully, this particular cost corresponds to U3 and V2. Now value of V2 is 1. So using these two values, we can find the value of U3. We know U is cost minus V, therefore U3 becomes 2 minus 1, which is 1. Step 3, that is finding all U and V values, is done. Tell me, was this difficult? Absolutely not. What you had to do was play it smart, assume this is a puzzle, and with the help of two variables, we can find the value of third variables. So step number 3, that is finding all U values and V values, is done. Now if you observe, in phase 1, our objective is to find U plus V matrix. Now we have obtained all U values and V values. So using these values, let's find all U plus V values for these unallocated cells. So step number 4 is computing U plus V values for all unallocated cells. Now for this particular cell, value of V1 is 1 and value of U1 is 0. Therefore V plus U becomes 1. Now for this particular cell, V2 is 1 and U1 is 0. Therefore U plus V becomes 1. Now for this particular cell, V3 is 4 and U3 is 1. Therefore U plus V is 4 plus 1, which is 5. And finally, for this particular cell, value of V1 is 1 and value of U3 is 1. Therefore U plus V becomes 2. So step number 4, that is computing all U plus V values for unallocated cells, is done. Now this is how we obtain U plus V matrix. Let's have a quick recap. So before we perform optimality test, we'll have to verify whether the number of allocations made and the value of m plus n minus 1 are equal. Now here, for this particular solution, we have made 5 allocation and the value of m plus n minus 1 is also 5. Since the number of allocations made and the value of m plus n minus 1 are equal, the given solution is non-degenerate, condition is verified, and we can proceed further. Now optimality test is performed in 2 phases. In phase 1, we'll obtain U plus V matrix. So U plus V matrix is obtained using these 4 steps. So the first step is to copy cost value of all allocated cells, that is 4, 6, 3, 3 and 2. Now our goal here is to find all U values and V values. So in step number 2, we'll assume any U or V value to be 0. Here we have assumed value of U1 is 0. Now in step 3, we'll compute all U values and V values with the help of the simple formula, that is cost is equal to U plus V. So once we obtained all U values and V values, in step number 4, we'll compute U plus V values for all unallocated cells. Now this is how we obtain U plus V matrix. Now let's go to phase 2 and obtain delta Ij matrix. So in phase 2, we'll obtain delta Ij matrix. Now tell me, why exactly are we performing optimality test? Why is it required that we'll have to obtain delta Ij matrix? Let's understand the logic behind it. Now this is the solution that we obtained using Vogel's approximation method. As you guys already know, it is not 100% guaranteed that the solution obtained using VAM is the best one. Now in order to be 100% sure, we'll be performing optimality test. Now these are all the allocations made using Vogel's approximation method. If you observe carefully, we have not made any allocations here. So in optimality test, what we'll do is we'll check if total transportation cost will increase or decrease if we make any allocations here. This point is very important. I'm giving you guys the logic behind optimality test. So in optimality test, in delta Ij matrix, what we'll do is we'll check if the total transportation cost will increase or decrease if you make any allocations in unallocated cells. Now this means we'll be computing delta ij values only for unallocated cells. Allocated cells are no more required. So in delta ij matrix, step number 1 is crossing out all the allocated cells. So in all the 3 matrices, we'll cross out the cells where we have made allocations. Let me do it in the first matrix. Now in the second matrix, that is U plus V matrix, I'll cross out all the cells where we have made allocations. Similarly, in delta ij matrix, I'll cross out all the cells where allocations are made. Now step number 1 is done, that is crossing out all the cells where we have made allocations. Now delta ij values is computed using a simple formula, that is Cij minus Ui plus Vj. Using this formula, we'll compute delta ij values for all the unallocated cells. Now in this formula, we know what is U plus V value, which is this particular matrix, but what exactly is Cij? Do not get confused. Cij means the initial cost matrix or the original cost matrix given to you in the question, which is nothing but this particular matrix. So I'll write this matrix as Cij matrix. So using Cij matrix and U plus V matrix, we can find delta ij value for all the unallocated cells. Is this clear? Let's do that. So for the first cell, Cij value is 5 and U plus V value is 1. Therefore delta ij value is 5 minus 1, which is 4. Now tell me, what exactly is the meaning of this value? What is the interpretation of delta ij values? Let's understand that. Now this value means that we have saved 4 rupees by not making an allocation here. If we had made an allocation here, the total transportation cost would have increased by 4 rupees. Now our objective is to minimize the total transportation cost. Therefore we have saved 4 rupees by not making an allocation here. Now suppose this value was minus 4. Now what is the meaning of this? Now this means the total transportation cost could have reduced by 4 rupees if we had made an allocation here. Now our objective is to minimize the total transportation cost, but since we have not made an allocation here, this particular solution is not optimal. Now that means after computing all delta ij values, if all the delta ij values are positive or if all delta ij values are greater than or equal to 0, then that means we have made the right allocation and the solution obtained is optimal. But even if one delta ij value is negative, even if one delta ij value is less than or equal to 0, that means the total transportation cost could have reduced further. We have not made the right allocation and the solution obtained is not optimal. I hope you guys have understood what is the interpretation of delta ij values. Now coming back to the question, let's find delta ij values for all the remaining values. Now for this particular cell, delta ij value is 3 minus 1, which is 2. For this particular cell, delta ij value is 4 minus 2, which is again 2. And finally, for this particular cell, delta ij value is 5 minus 5, which is 0. Now if you observe carefully, all the delta ij values are greater than or equal to 0. That means we have made the right allocation and the solution obtained using BAM is optimal solution. Now this is how you perform optimality test and this is how you obtain optimal solution. I hope this is clear. Let's have a quick recap. So in order to perform optimality test, before we perform optimality test, we'll have to verify one condition. We'll check if the number of allocations made and the value of m plus n minus 1 are equal. If the number of allocation made and the value of m plus n minus 1 are equal, that means the solution is non-degenerate. We can proceed further and perform optimality test. Now optimality test is performed in 2 phases. In phase 1, we'll obtain U plus V matrix and in phase 2, we'll obtain a delta ij matrix. Now after obtaining delta ij matrix, if all delta ij values are greater than or equal to 0, that means the solution is optimal. But even if one delta ij value is less than or equal to 0, that means the solution is not optimal. I hope this is clear. We've covered almost 90% of this chapter. We've learned how to find basic feasible solution using all the three methods, and we have also discussed how to find optimal solution for a given transportation problem. Now let's go to unit 3 where we learn special cases in a transportation problem. Now the first special case is solving a transportation problem which is unbalanced. Let's understand this with the help of an example. So the first step here is to check if the given question is balanced or not. Now this is done by computing the total supply and total demand. For this particular question, the total supply is 100 plus 120 plus 80, which is 300, and the total demand is 100 plus 80 plus 100, which is 280. If you observe, the total supply is not equal to the total demand. Therefore, the given question is unbalanced. Now we can only proceed further if we make it balanced. Now the question is how to make it balanced. If you observe carefully, total demand is less than the total supply. Now in order to make it balanced, since the total demand is less than the total supply, I'll add a dummy column here. Now because this is a dummy column, because this is a temporary column, all the cost values in this column will be 0. Now the question is, what should be the demand value of this dummy column? The trick is simple. For a dummy column or a dummy row, the supply or demand value is nothing but the difference of total supply and total demand, that is 300 minus 280, which is 20. Now if you see, the total demand is 100 plus 80 plus 100 plus 20, which is 300, and the total supply is also 300. The given question is balanced. We can solve the given question. Now let's look at one more example. Now in this particular example, the total supply is 60 plus 70 plus 40, which is 170, and the total demand is 100 plus 50 plus 50, which is 200. Since total supply is not equal to the total demand, the given question is unbalanced. Now in order to make it balanced, we'll either add a dummy row or a dummy column. Now the question is, should we add a dummy row or dummy column? If you observe carefully, the total supply here is less than the total demand, and for that reason, I'll be adding a dummy row. Now since this is a dummy row, all the cost values here will be 0. Now tell me, what should be the supply value of this dummy row? The trick is simple. For a dummy row or a dummy column, the supply or demand value is nothing but the difference of total supply and total demand, which is 200 minus 170, which is 30. Now the total supply is 200 and the total demand is also 200. The given question is balanced. We can proceed further and solve this question. So remember, for a given question, if the problem is unbalanced, if total supply and total demand are not equal, we'll make it balanced by either adding a dummy row or a dummy column as per the requirement. Now since this is a dummy row, all the cost values in this particular row or column will be 0. Now you might have a question, when should we make use of a dummy column and when should we make use of a dummy row? In example number 1, if you observe, the total demand is less than the total supply, and for that reason we have added a dummy column. And in example number 2, the total supply is less than the total demand, and for that reason we've added a dummy row. So remember this, we'll add a dummy row or dummy column depending on which side is short. I hope this is clear. So if the given problem is unbalanced, we'll make it balanced by either adding a dummy row or a dummy column as per the requirement. Meaning, we'll add a dummy row or dummy column depending on which side is short. Now since this is a dummy row or a dummy column, all the cost values here will be 0. Now moving on to the next special case, where we'll learn how to solve a given transportation problem if the objective is maximization. Now let me tell you, transportation algorithm is specifically designed only to solve a minimization problem. So if the given question is a maximization problem, in order to proceed further and solve the given problem, you'll have to convert the given maximization problem into a minimization problem. Now this matrix obtained after converting a maximization problem into a minimization problem is called as opportunity loss matrix. Let's understand this with the help of an example. Now this is the given question and the objective here is maximization. Now since this is a maximization problem, we'll have to convert it into a minimization problem. We have discussed the same case in assignment chapter. The steps followed, procedures followed to convert a maximization problem into a minimization problem is similar to what you guys have already learned in assignment chapter. So step number 1 here is identifying the maximum value in the entire matrix. Now if you observe carefully, in the entire matrix, the maximum value is 8. Now once you have identified the maximum value, we'll subtract each and every element of this matrix from this particular value. As a result, the matrix obtained is a minimization problem. Let's do this. Now in the first row, we'll subtract every element from 8. As a result, we'll have 8 minus 4, which is 4, 8 minus 5, which is 3, and 8 minus 7, which is 1. Similarly, let's subtract each and every element of the matrix from 8. Coming to the second row, 8 minus 8 is 0, 8 minus 3 is 5, and 8 minus 4 is 4. Now in the last row, 8 minus 6 is 2, 8 minus 4 is 4, and 8 minus 5 is 3. We have successfully converted the maximization problem into a minimization problem. Now on this particular problem, we can either find basic feasible solution or optimal solution depending on what exactly is asked in the question. I think this is clear. So keep in mind, if the given question is a maximization problem, you'll have to convert it into a minimization problem by finding opportunity loss matrix. So step number 1 here is identifying the maximum value in the entire profit matrix. Now in this particular example, in the entire matrix, the maximum value is 8. Now once you have identified the maximum value, you will subtract each and every value in the matrix from this value. Now in the entire matrix, I will subtract each and every element from 8, and as a result, I have obtained this value. I hope this is clear. Let's move to the last special case, that is degenerate solution. As you guys already know, before we perform optimality test, we'll have to check if basic feasible solution obtained is degenerate or non-degenerate. Now this is done by counting the number of allocations made and computing the value of m plus n minus 1. Here m is the number of rows and n is the number of columns. So if the number of allocations made and the value of m plus n minus 1 are equal, the given solution is non-degenerate, we can proceed further and perform optimality test. But if the number of allocations made and the value of m plus n minus 1 are not equal, that means the solution is degenerate. We cannot proceed further and perform optimality test. So in this particular special case, we'll learn how to solve a collision if it is degenerate. So if the solution is degenerate, in order to proceed further and perform optimality test, we'll have to make it non-degenerate. Now this is done by adding a dummy allocation epsilon, which is a very small value, almost equivalent to 0, in the least cost unallocated independent cell. Now you guys know what is least cost cell. You guys know what is unallocated cells. There are cells where no allocations are made. But you guys may not be familiar with the term independent cell. Now in simple terms, independent cells means the cells where loops cannot be formed. So first we'll have to understand what exactly is a loop and how to draw a loop. Let's understand that. Now in order to draw loops, there are 3 different rules. So the first rule says that loops are drawn using vertical and horizontal lines. So while drawing a loop, we can make use of vertical lines and horizontal lines, but diagonal lines cannot be used. Now point number 2 says that loops should start and end at the same point. So if I start a loop from here, I should end at the same point. If I start a loop from here, no matter how I move, I should end at the same point. Now tell me, is this a loop? If you observe, the starting point and ending point are different, therefore this is not a loop. So keep in mind, loops should start and end at the same point. Now comes the most important point. While drawing a loop, you can only change the direction if there is an allocation in that particular cell where you are changing the direction. Let's understand this with the help of an example. Now let's try drawing a loop at this particular cell. So I'll start from this point and move towards right. If you notice, there's an allocation at this particular cell. That means I can change the direction and I'll move downwards. Now tell me, can I change the direction at this particular cell? Since there is no allocation here, I cannot change the direction. Now this is the end of the matrix and I cannot proceed further. If you observe carefully, loop started at this point and loop ended at this point. Since the starting point and ending point are different, this is not a loop. Let's look at one more option. Now from this particular point, I'll move towards left. If you notice, there's an allocation here. That means I can change the direction and I'll move downwards. Now at this particular point, there's again an allocation. That means I can change the direction and I'll move towards right. Now there's again an allocation here. So I'll change the direction and I'll move upwards. Now if you notice, the loop started and ended at the same point. And in this loop, we change the direction only at allocated cells. Therefore, this is a loop. So keep in mind, while drawing a loop, you'll have to ensure that the loop starts and ends at the same point. And most importantly, in a loop, you can only change the direction if there's an allocation in that particular cell. Now for this particular example, let's check if this is degenerate or not degenerate. Now this is done by counting the number of allocations made and the value of m plus n minus 1. Here we have made 1, 2, 3, 4 allocations. Therefore number of allocations made is 4. Now let's compute the value of m plus n minus 1. Here m is the number of rows and n is the number of columns. We have 3 rows here and 3 columns here. Therefore value of m plus n minus 1 is 3 plus 3 minus 1, which is 5. Now if you observe carefully, number of allocations made and the value of m plus n minus 1 are not equal. Now that means this particular solution is degenerate. Now we can only proceed further and perform optimality test if we make it non-degenerate. Now in order to make it non-degenerate, we'll introduce a dummy allocation epsilon, which is a very small value. Now the question is, where should we allocate a dummy value? Where should we allocate epsilon? Let's understand that. Now if you observe, we've already made allocation in this particular cell. That means allocations cannot be made here. Now this implies that epsilon can be allocated only for unallocated cells. Now among all these cells, tell me what is the least cost or what is the minimum value. If you observe carefully, among all the unallocated cells, the least cost is 2. Now let me check whether loops can be formed here or not. If loops cannot be formed at this particular cell, then we'll allocate epsilon here. But if loops can be formed, then we'll eliminate this option and we'll look at the next least cost. Now let's check whether loops can be formed or not. Now if I start from this point, I'll start from this point and move towards left. Since there's an allocation here, I'll move upwards. There's again an allocation here, so I'll change the direction and move towards right. Now if you notice, there's an allocation at this point, so I can change the direction and I'll move downwards. If you notice, the loop started and ended at the same point and the direction of the loop changed only where there was an allocated cell. Therefore loops can be drawn here. That means epsilon cannot be allocated here. Let's look at the next best option. Now among these values, tell me what's the least cost. The least cost here is 4. So on this particular value, we'll check whether loops can be formed or cannot be formed. Now I'll start from this point and move towards right. There is no allocation here, so direction cannot be changed. I'll again proceed further, and since there is no allocation here, I cannot change the direction. Now the starting point and ending point are different, therefore this loop is not possible. Let's look at one more option. Now from this particular point, I'll move upwards. Since there is an allocation here, I'll change the direction and move towards right. There is again an allocation here, so I'll change the direction and move downwards. Now at this particular point, there is no allocation and I cannot proceed further. Now since the starting point and ending point are different, this particular loop is not possible. Let's look at the last option. Now from this particular point, I'll move downwards. Since there is an allocation here, I'll change the direction and move towards right. There's again an allocation here, so I'll change the direction and move upwards. Now if you notice, we cannot change the direction here since there's no allocation. I'll again proceed further, and even here we cannot change the direction. Now this is the end of the matrix and we cannot proceed further. Since the starting point and ending point are different, even this loop is not possible. Now that means we have considered all the options, and even in one option, loops cannot be formed. This means this particular cell is an independent cell, and we'll eliminate degeneracy, we'll remove degeneracy by allocating epsilon here. Now if you notice, we have made 5 allocations and the value of m plus n minus 1 is also 5. That means this is a non-degenerate solution and we can proceed further to perform optimality test. So keep in mind, if the given solution is degenerate, then we'll make it non-degenerate by adding a dummy allocation epsilon in the least cost unallocated independent cell. Now independent cell are cells where loops cannot be formed. I hope this is clear. Now this concludes the end of this chapter. Now let's have a quick recap. So in transportation chapter, there are 2 types of solution. The first one is basic feasible solution. Now before we obtain basic feasible solution, we'll have to perform initial verification and verify these 2 conditions. So the first condition is to check if the given question is a minimization problem or a maximization problem. If it is a minimization problem, we can proceed further. But if the given question is a maximization problem, we'll have to convert it into a minimization problem. Now this is done by identifying the maximum value in the maximization problem and subtracting it from each and every element of that particular matrix. Now condition number 2 is to check if the given question is balanced or not. This is done by computing the total supply and total demand. If total supply and total demand are equal, the given question is balanced, condition 2 is also verified. But if the given question is unbalanced, then we'll have to make it balanced, and this is done by either adding a dummy row or a dummy column as per the requirement, depending on which side is short. Now once both the conditions are verified, we can find basic feasible solution. Now there are 3 different methods to find basic feasible solution. The first one is northwest corner method, the second one is least cost method, and the third one is Vogel's approximation method. Now in all the 3 methods, the only difference is identifying where to make allocation. Steps followed to make allocation is same in all the 3 methods. In northwest corner method, as the name suggests, we'll make allocation in the northwest corner or the topmost left cell. Coming to least cost method, as the name suggests, we'll make allocation in the least cost or minimum value of the entire matrix. Now the third method to find basic feasible solution is Vogel's approximation method. Now Vogel's approximation method may be lengthy, but it is the best method to find basic feasible solution. First we'll calculate penalty for every row and every column. Now penalty is the difference between the least cost and the next least cost. Once penalty is computed for all the rows and all the columns, we'll identify the maximum penalty and we'll make allocation in the least cost of that particular row or column. Now in all the 3 methods, we'll keep making allocations until all the supply value and demand value becomes 0. This is how we find basic feasible solution using all the 3 methods. As discussed, Vogel's approximation method is the best method to find basic feasible solution, but there is one drawback of WAM. Now WAM tries its best to minimize the total transportation cost, but it is not 100% guaranteed that the total transportation cost obtained here is minimum. And that is the reason we go to the second type of solution, which is optimal solution. Now before we perform optimality test, we'll have to check whether the solution obtained using WAM is degenerate or non-degenerate. Now this is done by counting the number of allocations made and computing the value of m plus n minus 1. If number of allocations made and the value of m plus n minus 1 are equal, the solution is non-degenerate. We can proceed further and perform optimality test. But if the number of allocations made and the value of m plus n minus 1 are not equal, that means the solution is degenerate. Now in order to proceed further and perform optimality test, we'll have to make it non-degenerate. Now this is done by adding a dummy allocation epsilon which is a very small value, almost equivalent to 0, in the least cost unallocated independent cell. Now optimality test is performed in two phases. In phase 1, we'll perform U plus V matrix, and in phase 2, we'll obtain delta Ij matrix. Now let's understand how to obtain U plus V matrix. So the first step is to copy cost values of all allocated cells. So we'll copy the value 4, 6, 3, 3, 2. Now once this is done, in U plus V matrix, U represents every row and V represents every column. Now our goal here is to compute all U values and V values. So in order to compute all U values or V values, in step 2, we'll assume any U or V value to be 0. Here we have assumed value of U1 is 0. Now in step number 3, we'll compute all U values and V values using a simple formula, that is cost is equal to U plus V. Now once all U values and V values are computed, for all the unallocated cell, that is empty cells, we'll compute the value of a U plus V. Now this is how we obtain a U plus V matrix. Now phase 2 is delta Ij matrix. Now delta Ij matrix is computed only for unallocated cells. Delta Ij values is not required for allocated cells. So step 1 here is crossing out all the cells where allocations are made. So delta Ij values is computed only for unallocated cell using a simple formula, that is Cij minus Ui plus Vj. Once delta Ij values are computed, if all the delta Ij values is greater than or equal to 0, if all delta Ij values are positive, that means the solution obtained is optimal. But even if one delta Ij value is less than 0, that means the total transportation cost could have reduced further and we have not made the right allocation. Therefore, the solution obtained is not optimal. Now this is how we perform optimality test, and this is how we obtain optimal solution. I hope you guys have understood everything that we have discussed in this particular chapter. Let's begin with the next chapter, that is business application of Maxima and Minima. Now you guys have been studying business concepts from day 1 of your CMA journey. So let me ask you guys a simple question. What exactly is business? In simple terms, business is an activity performed to earn money. So if I am running a business, my goal is to grow my business, sustain in the market and earn profits from my business. So if I want to grow my business and earn money from my business, there are two golden principles, or there are two golden rules which should always be in the back of your mind. The first one is maximization and the second one is minimization. Now if I want to grow my business and earn money from my business, I'll have to ensure that my business makes maximum sales, I earn maximum revenue from my business so that maximum profits can be attained. Now this is what we call as maximization, getting the best out of your business. Similarly, there's one more factor which will affect my business. Now if I want to earn maximum profits from my business, I'll have to also cut down unnecessary cost. This is what we call as a minimization of cost. So there are two golden rules or two golden principles of a business. The first one is maximization, where the goal is to maximize the sales, maximize the revenue so that maximum profits can be earned. And the second one is minimization of cost. Guess what? These exact words, that is maxima and minima, is what we are going to study in this chapter. Now mathematically speaking, if this is the graph of a function, then this is the highest value of a function, which is called as maxima, and this is the lowest value of a function, which is called as minima. Now let's understand the application of maxima and minima in business scenarios with the help of an example. Meet the new businessman in the town, Mr. X. Mr. X starts a small business of selling handmade chocolates. But here's the problem. He's totally confused about one thing. What should be the selling price? Now if he charges too much, sales drops, and if he reduces the price too much, revenue drops. Now in both the cases, profit is affected. So Mr. X has to decide what is the perfect selling price so that he can earn maximum profits. Here's what he observed. If he sets the price at 50 rupees, Mr. X earns a profit of 400 rupees per day. Now he increases the price to 55. So at 55, Mr. X earns a profit of 500 rupees. Now if Mr. X sets the price at 60 rupees, he earns a profit of 600 rupees, and if he increases the price to 65, profit drops to 500 rupees. Now if you observe carefully, every time price changes, profit earned also changes. Now that means price of the product and profit are directly linked. Profit earned depends on the price of the product. Now let's depict this relationship with the help of a graph. Now if you notice, when we set the price at 60 rupees, Mr. X earned a maximum profit of 600 rupees. Now that means this is the maximum value of the function. Now had he increased the price to 65, profit would have dropped to 500 rupees. Now if you notice carefully, this curve started increasing and after a point it started to fall. Now this is a graphical representation of a business scenario. Now this is the point of maxima, and in this particular chapter our goal is to find such sweet spots where profit is maximized or cost is minimized. So the question is how to find such point, how to find this point where profit is maximized or cost is minimized. Now in the example that we discussed, we had considered only 4 prices, and with the help of these data we were able to recognize the perfect selling price where profit was maximum, which was rupees 60. Now shift your focus and think about brands like Nestle and Amul. Now these brands has 20 different products, 50 different markets, and price of a product depends on multiple factors. That means if we use the same approach of trial and error, we'll have thousands of combinations, and using trial and error method here is not practical, and that's where differential calculus steps in. Now do not panic. I know a lot of students already have this assumption that differential calculus is tough. Differential calculus is not my cup of tea. Now let me tell you guys, differential calculus is not as difficult as it sounds. It is slightly tricky and new to you guys. So if you invest a good amount of time in making your basic strongs, trust me, this chapter is going to be easy. Now you guys are very lucky because hardly 1 to 2% of differential calculus is included in this chapter. So making your basic strongs is very important, and I'll ensure I invest a good amount of time to make your basic strongs and ace this chapter. Now this particular chapter of Maxima and Minima is also present in SPM BV paper. So if you understand this chapter, if you invest a good amount of time to learn this chapter, it will not only benefit you in SCM paper, but it will also help you in SPM BV paper. Now in both the subjects, this particular chapter is very important, and there is a high chance a 7-mark question will come from this chapter. So the question is, what exactly is differentiation? Now at its heart, differentiation is the study of change. Think about it. The world around us is constantly changing. The price of a product, the growth of a population, even people around us are constantly changing. Now with the help of differentiation, we can study this change with precision and accuracy. Let's go back to the example that we discussed. Here if you notice, every time price changed, profit also changed. Now that means profit earned by Mr. X depends on the price of the product. Now our goal is to maximize the total profit and identify the perfect selling price. So in order to identify the perfect selling price, I should know what is the change in profit when there is a small change in price. And this is done with the help of differential calculus. Let's say profit earned is Y and price is X. Now every time price changes, profit earned is also affected. Now mathematically, this is written as dy by dx. So this tells us what is the change in profit, that is Y, when there is a small change in price. So in this particular chapter, we will make use of differentiation, differentiate the equation, and identify the point of maxima and minima. So in simple words, differentiation tells us what is the change in one value with respect to a small change in another value. I hope you guys have got a basic idea of this particular chapter and what is differentiation. Now let's have a quick recap. As you guys already know, business is an activity performed to earn money. Now this particular chapter, that is business application of maxima and minima, refers to the process of finding the optimal strategies by a firm. Business application of maxima and minima is a process to find the best strategies by a firm or business in order to attain its objective. Now, if you take any business in this world, every business will have two core principles or objective. The first one is maximization. Here the goal is to maximize the total sales, maximize the revenue earned so that maximum profits can be earned. And the second one is minimization of cost. Now, in order to attain the point of maxima or minima, we'll make use of differential calculus. So the question is, what is differentiation? In simple words, differentiation is the study of change. It tells us by how much is one value changing when the other value changes slightly. Let's understand this with the help of an example. Let's say profit earned is Y and price is X. You guys already know this. Profit earned by a company depends on the price set. If price changes slightly, profit earned is also affected. Now, using differentiation, we'll know what is the change in profit for a small change in price. Now, mathematically, this is written as dy by dx. So, this value tells us what is the change in profit, which is y, for a small change in price. Now, in this particular chapter, questions will be given to you in the form of equations. Now, with the help of differentiation, let's learn how to find derivative of all these values. So, there are 4 set of standard formulas which we will be learning here. The first rule is power rule. Here we learn how to find derivative of a term which has a power value. Let's understand this with the help of an example. Let's say y is equal to x square. If you observe carefully, y here is in terms of x. That means y is a function of x. So I can also write this as function of x is equal to x square. Now derivative of this value is written as dy by dx, which tells us what is the change in the value y with respect to change in x, or it can also be written as f dash of x. So the trick here is simple. If a term has a power value, then on differentiation, the power value comes down, which is 2. X is written as it is, and the power value of x reduces by 1, which is 2 minus 1. Therefore, dy by dx is 2x. Let's look at one more example. Tell me what is the derivative of y is equal to x to the power 3. If you observe carefully, variable x has a power value which is 3. So on differentiation, according to power rule, the power value comes down, x is written as it is, and the power value of x reduces by 1, which is 3 minus 1, which is 2. Therefore, dy by dx of y is equal to x to the power 3 is 3x square. Let's look at one more example. Tell me what is the derivative of y is equal to x to the power 5. If you observe carefully, this particular term has a power value which is 5. So according to power rule, on differentiation, the power value comes down, x is written as it is, and the power value of x reduces by 1, which is 5 minus 1, that is 4. Therefore, derivative of y is equal to x to the power 5 is 5 into x to the power 4. Tell me, is this difficult? Absolutely not. All you guys need to do is practice more number of questions. If you practice more number of questions, trust me, this chapter is not going to be as difficult as it sounds. Now let's look at a tricky example. Tell me what is the differentiation of y is equal to x to the power minus 3. If you observe carefully, this particular variable here has a power value which is minus 3. So on differentiation, the power value comes down, which is minus 3. X is written as it is, and the power value of x reduces by 1, which is minus 3 minus 1. Therefore, dy by dx is minus 3 x to the power minus 4. Is this clear? Okay, let's proceed further. Now let's look at a special case in power rule. Now power rule can only be applied if the term is present in numerator. If the term is present in denominator, power rule cannot be applied. Let's have a look at an example. Tell me what is the derivative of 1 divided by x square. Now if you observe carefully, we have a power term here, but this power term is present in denominator. As we discussed just now, power rule can only be applied if the term is present in numerator. So in order to apply power rule, first we'll have to bring it to numerator. So the question is, how do we bring it to numerator? Now let me teach you guys a simple math trick which you have learned while you were in 6th or 7th grade. Now this math trick tells that if a term moves from numerator to denominator or denominator to numerator, then the sign of power value changes. For example, let's say the value is x to the power minus 2. Now I want to move this term to denominator. So if I move this term to denominator, this becomes 1 divided by x square. So how did this happen? If a term moves from numerator to denominator, then the power value of sign changes. So minus 2 became plus 2. Let's look at one more example. So the value is 1 divided by x to the power minus 3. Now I want to move this term to numerator. So on moving this term to numerator, this becomes x to the power plus 3. How did this happen? If a term moves from denominator to numerator or numerator to denominator, the sign of power value changes. So minus 3 became plus 3. Is this clear? Now let's come back to the question. So in the question, you are asked to find the derivative of y is equal to 1 divided by x square. As discussed, power rule can only be applied if the term is present in numerator. Now since the term is present in denominator, first let's move this term to numerator. So this value becomes x to the power minus 2. Plus 2 became minus 2 when it moved to numerator. Now on this term, let's apply power rule. So on applying power rule, differentiation becomes minus 2 x to the power minus 2 minus 1, which is minus 2 x to the power minus 3. Is this clear? Now this value can also be written as minus 2 divided by x to the power plus 3. What did I do here? I moved this term from numerator to denominator and the sign of power value changed from minus 3 to plus 3. That's it. Let's look at one more example to make this concept crystal clear. Tell me, what is the differentiation of 1 divided by x to the power minus 3? As we have discussed, power rule can only be applied if the term is present in numerator. So the first thing to do here is bring this term to numerator. So this becomes x to the power plus 3. Now on this value, let's apply differentiation. If you observe carefully, this is a power term and the power value here is plus 3. So on differentiating, this becomes plus 3 x to the power 3 minus 1. Therefore dy by dx is 3 into x square. Is this clear? Okay. So according to power rule, if y is equal to x to the power n, then on differentiating, that is dy by dx or f dash of x, this value becomes n into x to the power n minus 1. That is, the power value comes down, that is n, x is written as it is, and the power value n reduces by 1. Now let's go to rule number 2. Rule number 2 is actually an extension of power rule. Here we learn how to find derivative of a variable where power value is 1. Let's understand this with the help of an example. So value of y is x. Now x can also be written as x to the power 1. Now let's apply power rule. So according to power rule, the power value comes down, x is written as it is, and the power value reduces by 1, which is 1 minus 1. So this is 1 into x to the power 0. Now I will teach you guys one more math trick which you have already learned while you were in school. Now value of 1 to the power 0 is 1. Value of 10 to the power 0 is also 1. Value of 100 to the power 0 is also 1. That means any value or any variable to the power 0 is always 1. Therefore I can say that value of x to the power 0 is also 1. Therefore this value becomes 1 into 1, that is 1. That means if the power value is 1, then dy by dx is also 1. Is this clear? In order to make this concept crystal clear, I'll give you guys one more logic. So if y is equal to x, then its derivative becomes dy by dx. Is this right? So can I write this as d by dx of value of y is x. Now numerator also has dx and denominator also has dx. So both get cancelled and this value becomes 1. I have given you guys one more logic behind why is this 1. So keep in mind, if the power value is 1, then dy by dx is also 1. Now let's go to rule number 3. Here we learn how to find derivative of a constant value. Let's understand this with the help of an example. Let's say y is equal to 100. Now tell me what is the derivative of this value. Now on differentiating, this becomes dy by dx. As you guys already know, dy by dx tells us what is the change in value y, which is 100, with respect to change in x. Now the value y here is 100. This is a constant value. So no matter how x changes, value of y is not going to change. Even if x becomes 100, 1000, 10,000, value of y is going to remain same, that is 100. Therefore, change in the value y with respect to x, if y value is constant, is always 0. Is this clear? So keep in mind, if the given term is a constant value, then dy by dx is 0. So right until now we have studied 3 rules. The first one is power rule, the second one is power value being 1 where dy by dx is 1, and third rule is constant rule. So in constant rule, dy by dx is always 0. Now let's go to the last rule, which is rule number 4. Now what if the given term is a combination of a constant value into a power term? Let's learn how to find derivative of such values. So example here is y is equal to 3x square. If you observe carefully, this term is a combination of constant value multiplied by a power term. Now we know differentiation of a constant value is 0, and we also know how to find differentiation of a power term. But since this is a combination of both, derivative of this value is going to be slightly different. The trick here is simple. So if the given term is a combination of a constant value into power term, then in its derivative, we'll write the constant term as it is and find the derivative of only the power term. So the power value here is 2. So on differentiation, this becomes 2 into x to the power 2 minus 1. Therefore, dy by dx is 3 into 2, that is 6x. Is this clear? Let's look at one more example. Tell me what is the derivative of y is equal to minus 40 x to the power 3. If you observe carefully, this is a combination of constant value into power term. So the trick here is simple. We'll write the constant value as it is and find a derivative of only the power term. The power value here is 3. So on differentiation, 3 comes down, x is written as it is, and the power value of x reduces by 1, which is 2. Therefore, dy by dx is minus 40 into 3, which is minus 120 x square. Let's look at a last example. Tell me what is the derivative of y is equal to minus 20 divided by x square. If you guys remember, we discussed a simple concept in rule number 1. Now, power rule can only be applied if the power term is present in numerator. If it is present in denominator, power rule cannot be applied. If you observe carefully, this particular power term is present in denominator. So the first thing to do here is bring this term to numerator. So this becomes minus 20 x to the power minus 2. Since the term moved from denominator to numerator, the sign of power value changed from plus 2 to minus 2. Now let's find derivative of this value. If you observe carefully, this particular term is a combination of a constant value multiplied by a power term. So on differentiation, constant value is written as it is and we find derivative of only the power term, that is x to the power minus 2. Here the power value is minus 2. So on differentiating, minus 2 comes down, x is written as it is, and the power value of x reduces by 1, which is minus 2 minus 1. Therefore, dy by dx is minus 20 into minus 2, which is plus 40 x to the power minus 3. Is this clear? Now in your textbook, there are some other rules which are given, but let me tell you, if I talk in terms of your exam, These are only the rules which are required. If you are thorough with these 4 rules, you can solve any questions from this particular chapter. Now in your exams, questions will be given to you in a form of equations which will have multiple terms. Now we guys learned how to find derivative of individual terms. Now the question is, how to find derivative of an equation which has multiple terms? The trick is simple. We'll understand this with the help of an example. Tell me, what is the derivative of y is equal to x square plus 100 minus 3x to the power 3 plus 4x? If you observe carefully, this is an equation having multiple terms. So the trick is simple. If an equation has multiple terms, then we'll find derivative of each terms individually and place the same plus or minus symbols in between. So dy by dx becomes, tell me what is the derivative of x square. This is a power term. So on differentiation, 2 comes done, x is written as it is and the power value reduces by 1, which is 1. Now tell me what is the differentiation of 100. If you remember, we discussed that derivative of a constant value is 0. So derivative of 100 is 0. Now tell me what is the derivative of 3 into x to the power 3. Now this is a combination of constant value into a power term. So the trick is simple. We'll write the constant value as it is and find derivative of only the power term. The power value here is 3. So 3 comes down, x is written as it is and the power value reduces by 1, which is 2. And the last term is 4x. This is again a combination of constant value into a power term. So the constant value is written as it is, which is 4, and derivative of x to the power 1 is 1. Now we got the derivative of all individual terms. Now let's copy all the plus and minus symbols in between. Therefore, dy by dx is 2x minus 9x square plus 4. Is this clear? Let's look at one more example. Tell me what is the derivative of this equation. Now this equation has multiple terms, so the trick is simple. We'll find derivative of each terms individually and write the plus or minus symbols in between. So dy by dx becomes 2 into 2x minus 4 into 1 plus 0, which is nothing but 4x minus 4. Now this concludes unit 0 and we have covered all the basics that is required to solve any type of problem in this particular chapter. Now let's move on to unit number 1. Now in your institute mat, there are around 5 different methods to solve different variations of questions. Each of these methods is slightly complex and by the end of it, everything becomes confusing. So sir, what should we do? Tell me why am I here? I'm here to simplify things for you guys and I'll teach you guys one standard method, one base method in the most structured, logical and simplified way using which you can solve any question. Technically, we'll be learning 2 methods, but the second method is derived from the first method. Now that means understanding the first method is very important and if you understand the base method, trust me, you can ace this chapter. So first let's understand the approach to solve any question in this particular chapter. Now the moment you get a question, the first thing you need to do is form an equation as per the requirement. For instance, let's say the objective is maximization of total profit. So we'll obtain an equation in terms of total profit. If the objective is minimization of total cost, we'll obtain an equation in terms of total cost. So based on the objective of the question, the first step is to form an equation. Now talking about equation may be directly given to you in the question or necessary data will be given using which you'll have to form an equation. So step number 1 is forming an equation as per the requirement. Now once an equation is obtained, we'll go to step 2 and identify the number of variables. Now based on the number of variables, an equation might have single variable or an equation can have more than one variable, that is a multi-variable equation. Let's understand this with the help of an example. Let's say the equation is z is equal to x square plus 3x plus 10. Now tell me how many variables are present in this equation. If you observe carefully, you'll notice that there is only one variable here, that is x. Therefore, this is a single variable equation. Let's look at one more example. Let's say the equation is z is equal to x square plus 3xy plus y square. Now tell me, how many variables are present in this equation? If you go through this equation, you'll notice that there is more than one variable, that is x and y. Now since there are multiple variables here, this is a multi-variable equation. So keep in mind, based on the number of variables, equation can be of two types. If the number of variables is 1, then it is a single variable equation, and if the number of variables are 2, then it is a multi-variable equations. Equations with more than 2 variables will not be tested for your exams. Now based on the number of variables, the approach with which you solve a question changes slightly. If the given question is a single variable equation, then we'll make use of differentiation and solve the given question. We have already discussed how to find differentiation of a given equation. But if the given equation has multiple variables, if the given equation has more than one variable, then we'll use something called as partial differentiation. Now partial differentiation is similar to normal differentiation but with slight changes and adjustments. We'll discuss this later on in this marathon video. First, let's understand how to solve a question if the given equation has single variable, that is single variable optimization. Now before we proceed further, first let's understand what is first order derivative and second order derivative with the help of an example. Let's say the equation is y is equal to 3x minus x square plus 10. Now the equation here is y and this equation is in terms of x. Therefore, its derivative becomes dy by dx. Is this right? Now let's find the derivative. If you observe carefully, the first term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, and we'll find derivative of the power term, which is x to the power 1. Now we know if the power value is 1, its derivative is also 1. Therefore, derivative of x to the power 1 is 1. Minus the second term here is x square. Now this is a power term. The power value here is 2. So in its derivative, 2 comes down, x is written as it is, and the power value of x reduces by 1. Plus the last term here is 10. Now this is a constant value, and we know derivative of a constant value is 0. Therefore derivative of 10 is 0. That means dy by dx is 3 minus 2x. Now this is called as first order derivative. As simple as that. So for a given equation, if you find its derivative, that is called as first order derivative. Now let's understand what is second order derivative. This is something that we have not discussed. So for the given equation, if you find its derivative, that is called as first order derivative. Now second order derivative, as the name suggests, is derivative of first order derivative. That is d by dx of first order derivative. Now this can also be written as d square y by dx square. Now do not get confused here. I'll teach you guys a simple trick. So once first order derivative is obtained, assume this as an equation and find its derivative, which is nothing but second order derivative. Now the first order derivative obtained here is 3 minus 2x. Now let's find its derivative, that is d square y by dx square. If you observe carefully, the first term here is 3, which is a constant value. We know derivative of a constant value is 0, therefore derivative of 3 is 0, minus the second term here is 2x. Now this is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, and we'll find derivative of the power term, which is x to the power 1. Now we know if the power value is 1, its derivative is also 1. Therefore derivative of x to the power 1 is 1. That means d square y by dx square is minus 2. Now this is called as second order derivative. So now you guys have understood how to find first order derivative and second order derivative. The trick is simple. For the given equation, if you find its derivative, that is called as first order derivative. Now once this is done, we'll assume this as an equation and again find its derivative, which is called as second order derivative. Now coming back, let's understand how to solve a question of maxima and minima which has single variable, that is single variable optimization. Now a question of maxima and minima is solved using 3 steps. Let's understand each of these steps one by one. So step 1 is differentiating the given equation, which is nothing but finding the first order derivative. Now in the example we have considered the equation as 3x minus x square plus 10. If you observe carefully, the equation here is y and this equation is in terms of x. Therefore its derivative becomes dy by dx. Now had this equation been z and if it was in terms of x, then its derivative would have become dz by dx. Now since the equation here is y and this is in terms of x, its derivative becomes dy by dx. Now let's find its derivative. Now while understanding what is first order derivative and second order derivative, we have already obtained the first order derivative, that is 3 minus 2x. Therefore dy by dx is 3 minus 2x. So this is step number 1. So in step number 1, we'll differentiate the given equation or we'll find the first order derivative. Now tell me, why exactly are we doing these steps? What is the need of differentiation? What is our goal here? If you think about it, our goal here is to find the point of minima or maxima where either profit is maximized or cost is minimized. Now that means in this particular equation, I'll have to find the value of x which is either a point of minima or a point of maxima. For that reason, in order to find the value of x, we'll assume that the first order derivative is 0. So step number 2 is assuming that the first order derivative, which is dy by dx, is equal to 0, and then we'll find the value of x. Now here dy by dx is 3 minus 2x. We'll equate this to 0 and find the value of x. Now let me move this term to the other side. So the equation becomes 3 is equal to 2x. Now that means value of x is 3 by 2, which is 1.5. Now therefore at x is equal to 1.5, either profit will be maximized or cost will be minimized. This means x is equal to 1.5 is either a point of maxima or a point of minima. But we have one problem here. We do not know if this is a point of maxima or point of minima, and for that reason we'll go to step number 3. So in step 3, we'll again differentiate this equation, which is nothing but finding the second order derivative. So the first order derivative is dy by dx. So second order derivative becomes d square y by dx square. Now while understanding what is first order derivative and second order derivative, we use the same equation and the second order derivative obtained here is minus 2. Therefore d square y by dx square is minus 2. So step 1, step 2 and step 3 is done. Now with the help of this value obtained, we'll know if x is equal to 1.5 is either a point of minima or a point of maxima. Here comes the result. So if the second order derivative obtained is greater than 0, if d square y by dx square is a positive value, that means minima exist. If second order derivative or d square y by dx square is less than 0, if second order derivative is a negative value, that means maxima exists. And finally, if second order derivative or d square y by dx square is equal to 0, that means neither minima nor maxima exist. This is called as point of inflection. Now if you observe carefully, the second order derivative obtained here is minus 2. This is a negative value. Now since second order derivative is a negative value, this means maxima exists. Therefore, at x is equal to 1.5, the total profit will be maximized. We have successfully solved this question. Now let's have a quick recap. So a single variable question is solved using 3 steps. So step number 1 is differentiating the equation or finding the first order derivative. So the given equation here is y and it is in terms of x. So we'll find its first order derivative, which is dy by dx. Now once this is done, our goal here is to find the value of x. So in order to find the value of x, in step 2, we'll assume that the first order derivative is equal to 0. Now by equating it to the 0, we'll find the value of x. Now x is equal to 1.5 obtained here is either a point of maxima or a point of minima. But we don't know if this is a point of minima or point of maxima. For that reason, we'll go to step 3. So in step 3, we'll again differentiate this equation and find second order derivative. Now once this is done, we'll compare the value of second order derivative. If second order derivative is greater than 0, that means minima exists. And if second order derivative is less than 0, that means maxima exists. So keep in mind, this is ulta. If second order derivative is a negative value, that means maxima exists. And if second order derivative is a positive value, that means minima exist. I hope this is clear. Now let's look at basic terminologies which is required while forming equations. The first terminology here is revenue. Tell me, what exactly is revenue? In simple terms, revenue is the money earned by selling a certain number of units. Let's understand this with the help of an example. Let's say a chai wala sells 100 cups of tea every single day and the price is 10 rupees. Now tell me, what is his total revenue? So if he sells 100 cups of tea at rupees 10, then his total revenue is 100 into 10, which is rupees 1000. So I can say total revenue is price of the product into the number of units sold or the number of quantities sold. So if price is P and quantity sold is X, I can say total revenue is P into X. Now let's move to the next concept, that is average revenue. Now average revenue is nothing but total revenue divided by number of units sold. So I can write average revenue as total revenue divided by quantity sold or number of units sold, which is X. And the last concept here is marginal revenue. Now in simple terms, marginal revenue is the revenue generated by selling one extra unit or one additional unit. Let's use the same example and understand what is marginal revenue. Now this chaiwala made a revenue of 1000 rupees by selling 100 cups of tea. Now let's see what is the revenue generated if he sells one extra cup of tea. So if this chaiwala sells 101 cup of tea at the same price, which is rupees 10, then his total revenue is 101 into 10, which is rupees 1010. Now if you observe carefully, by selling one extra cup of tea, this chaiwala made a revenue of rupees 10. Now this revenue is what we call as marginal revenue. So marginal revenue is the revenue earned or revenue generated by selling one extra unit or one additional unit. Mathematically, we'll write marginal revenue as d by dx or derivative of total revenue. Is this clear? So total revenue is price into quantity sold. Average revenue is total revenue divided by quantity sold, and marginal revenue is derivative of total revenue. Now let's move to the next terminology, which is cost. You guys have studied cost most of the times. You guys know what is cost, but let's understand what is cost with the help of example. Let's say the cost of making one unit is rupees 10 and the total fixed cost for its production is rupees 500. Now let's see what is the total cost if we make certain number of units. So if 100 units of this product are made, then fixed cost is not going to change, which is rupees 500, and the variable cost here is 100 units into rupees 10, which is 1000 rupees. Now that means total cost is 1000 rupees plus 500, which is 1500. Now this is nothing but total variable cost plus total fixed cost, which is 1500. So I can say total cost is total variable cost plus total fixed cost. Now the next concept here is average cost. Similar to average revenue, average cost is total cost divided by quantity sold, which is X. And finally, we have marginal cost. Now in simple terms, marginal cost is the cost incurred to make one extra unit. Let's understand this with the help of the same example. Now the total cost here is 1500 to make 100 units. Now what is the total cost if one extra units are made? Let's understand that. So if 101 units of the same product are made, then fixed cost is going to remain same, which is 500, and variable cost is rupees 10 into 101, which is 1010. Now that means total cost here is 1010 plus 500, which is 1510. Now if you observe carefully, by making one extra unit, the cost incurred here is rupees 10. Now this cost is what we call as marginal cost. So marginal cost is the cost incurred or cost required to make one extra unit or one additional unit. So mathematically, we'll write marginal cost as d by dx or derivative of total cost. Is this clear? So total cost is total variable cost plus total fixed cost. Average cost is total cost divided by number of units sold, and marginal cost is d by dx or derivative of total cost. Let's move to the next terminology, which is profit. Now we speak about profit all the time. Though you are a CMA or not a CMA, profit is something which everybody discusses. So let's understand what is profit. Now in simple terms, profit is the money earned after subtracting all the cost from revenue generated. Let's understand this with the help of an example. Let's use the same example of chaiwala. Now this chaiwala sells 100 cups of tea every single day at rupees 10. Now that means his total revenue is 100 into 10, which is rupees 1000. So the total revenue generated by this chaiwala is 1000 rupees. Now tell me, is this as profit? Absolutely not. He will also incur some cost, and let's say every single day this chaiwala incurs a cost of 250 rupees. Now that means the total profit earned by this chaiwala is 1000 minus 250, which is rupees 750. So mathematically we can write total profit as total revenue generated minus total cost. Now keep in mind, profit is represented using this special case, which is called as pi. So total profit is total revenue generated minus total cost. Now we know total revenue generated is price into x. So I can write total profit as p into x minus total cost. Is this clear? Now the next concept here is average profit. This is very similar to what we have already discussed. Average profit is total profit divided by number of units sold, which is x. And finally, we have marginal profit. Now marginal profit is the profit earned by selling one extra unit. Let's use the same example and understand what is marginal profit. Now this chaiwala earned a profit of 750 rupees by selling 100 cups of tea. Now let's see what is the profit earned by this chaiwala if he sells one additional unit. So if this chaiwala sells a total of 101 cups of tea at the same price, which is rupees 10, then his total revenue is 101 into 10, which is 1010. Now the cost incurred by this chaiwala is 250, therefore total profit is 1010 minus 250, which is 760. Now if you observe carefully, by selling one extra cup of tea, the profit earned here is rupees 10, and this profit is what we call as a marginal profit. So marginal profit is the profit earned by selling one extra unit or one additional unit. Now mathematically, marginal profit is written as d by dx or derivative of total profit. So total profit is total revenue generated minus total cost. Average profit is total profit divided by number of units sold, and marginal profit is derivative of total profit. Is this clear? Now let's have a quick recap of marginal revenue, marginal cost and marginal profit. So what is marginal revenue? Marginal revenue is the revenue generated by selling one additional unit. What is marginal cost? Marginal cost is the cost incurred or the cost required to make one additional unit, and marginal profit is the profit earned by selling one extra unit. Now mathematically, marginal revenue is written as derivative or d by dx of total revenue. Marginal cost is derivative of total cost, and marginal profit is derivative of total profit. So what is marginal revenue? It is derivative of total revenue. Marginal cost is derivative of total cost, and marginal profit is derivative of total profit. Now I am repeating these things again and again because these concepts are very important, and in the previous attempts, questions regarding marginal revenue, marginal cost and marginal profit were asked multiple times in MCQs. So keep in mind, these concepts are very important and there is a high chance these questions can be asked in MCQs. Moving on to the next concept, that is equilibrium of a firm. If you remember, in the beginning of the chapter we discussed that any firm, any business has two core principles or two core objectives. So the first principle or the first objective is maximization, where the goal is to maximize the sales, maximize the revenue so that maximum profits can be earned. And the second one is minimization of cost. Now here's the catch. According to economics, a firm may have multiple goals, multiple objectives, but the primary objective is maximization of total profit. Now that means a firm is said to be in equilibrium when the objective is achieved, that is the profit is maximized. So keep in mind, this is very important while solving questions. If the word equilibrium is mentioned, that means the objective is maximization of total profit. Now there are two more terms here, equilibrium price and equilibrium output. So the price at which maximum profits can be earned is called as equilibrium price, and the quantity or the number of units at which maximum profit is earned is called as equilibrium output. So keep in mind, this is a golden rule while solving questions. If the word equilibrium or monopolist is used in the question, then that means the objective is maximization of total profit. Now let's solve a question which was asked in December attempt of 2023 exam. Zoxin Limited is a manufacturing company which is planning to introduce a new doll in the market. Rather than setting the selling price of the doll based on production cost, management polls the retailers of the doll to see how many dolls will they buy for various prices. Now instead of setting the selling price of the product just based on production cost, this company did something smart. They conducted a survey and asked different retailers how many units of doll will you buy at various price levels. Now from the survey, a demand function was obtained which is x is equal to 1500 minus 75p. So the demand function is x is equal to 1500 minus 75p. Now this function tells us the relationship between x and p. Here x is the number of units demanded and p is the price of the doll. Now using this function, let's obtain an equation for p. If I move this term to the other side, the equation becomes x plus 75p is equal to 1500. Now let me move this term x to the other side. So the equation becomes 75p is equal to 1500 minus x. That means p is equal to 1500 minus x divided by 75. Now the first term here is 1500 divided by 75, which is 20. Therefore p is 20 minus the second term is x divided by 75. X divided by 75. So using this equation given in the question, we have obtained an equation for p which is 20 minus x divided by 75. Now the cost function is also given in the question, which is c is equal to 4x plus 1400. So the equation for total cost is c is equal to 4x plus 1400. Now using this data, you are required to calculate three things. Evaluate how many number of dolls are to be sold to the retailers so that maximum profits can be attained. Now that means the objective here is maximization of total profit. So the first step or the first thing that we need to do is obtain an equation in terms of total profit. Now we know equation for total profit is total revenue earned minus total cost. Now the function for total cost is given in the question, which is 4x plus 1400. So let's obtain an equation for total revenue using the data given in the question. We know total revenue is price of the product, which is pre, into the number of units sold, which is x. Now equation for price is 20 minus x by 75. Therefore total revenue is 20 minus x by 75 into the number of units sold, that is x. That means total revenue is 20x minus x square by 75. So now we have equation for total revenue and we also have equation for total cost. That means total profit is total revenue, that is 20x minus x square by 75 minus equation for total cost is 4x plus 1400. 4x plus 1400. Now if I open this bracket, the equation becomes 20x minus x square by 75 minus 4x minus 1400. If you observe, we have a term 20x here and 4x here. So 20x minus 4x is 16x minus x square by 75 minus 1400. So we have obtained an equation for total profit, that is 16x minus x square by 75 minus 1400. So keep in mind, no matter what the question is, the first thing you need to do is form an equation as per the requirement. Since the objective here is maximization of total profit, we obtained an equation in terms of total profit. Once an equation is obtained, solving the question is very easy. Now I want you guys to go through this equation. If you notice, there is only one variable here, that is x. That means this is a single variable equation. As discussed earlier, single variable optimization is solved using 3 steps. So the first step is differentiating this equation and finding the first order derivative. So the step number 1 is finding the first order derivative. Now this equation is total profit and it is in terms of x, therefore its derivative becomes d by dx of total profit. Now let's differentiate this equation. The first term here is 16x. If you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is and we'll find derivative of the power term, that is x to the power 1. Now we know if the power value is 1, its derivative is also 1. Therefore derivative of x to the power 1 is also 1 minus the second term here is x square by 75. Now I can also write this term as 1 divided by 75 into x square. Is this right? Now if you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, which is 1 divided by 75, and we'll find derivative of the power term. Now let's apply power rule. The power value here is 2, so in its derivative, 2 comes down, x is written as it is, and the power value of x reduces by 1, which is 1, minus the last term here is 1400, which is a constant value. We know derivative of a constant value is 0. That means derivative of 1400 is also 0. Therefore, d by dx of total profit is 16 minus 2x divided by 75. Step 1 is done. Now tell me, what is our goal here? What is our objective here? If I go back to the question, you are asked to evaluate the number of dolls to be sold by this company so that maximum profits can be earned. Here number of dolls is represented by x. That means our goal here is to find the value of x. So in order to find the value of x, we'll assume that the first order derivative is 0. So in step 2, we'll assume that the first order derivative, which is d by dx of total profit, is 0. Now the first order derivative of this equation is 16 minus 2x by 75. Therefore 16 minus 2x by 75 is equated to 0. Now let's solve this equation and find the value of x. If I move this term to the other side, the equation becomes 16 is equal to 2x by 75. Now let me move this term 75 to the other side. So the equation is 16 into 75 is equal to 2x. That means value of x is 16 into 75, that is 1200, divided by 2, which is 600. Therefore x is 600. So at x is equal to 600, if the number of dolls produced are 600, either profit will be maximized or profit will be minimized. But the problem is, we don't know if x is equal to 600 is a point of minima or point of maxima. So for that reason, we'll perform step number 3. So in step 3, we'll find the second order derivative. So the first order derivative obtained is 16 minus 2x by 75. D by dx of total profit, that is first order derivative, is 16 minus 2x by 75. Now let's differentiate this equation again and find the second order derivative. So second order derivative becomes d square divided by dx square. The first term here is 16. Now this is a constant value and we know derivative of a constant value is 0. Therefore derivative of 16 is also 0 minus the second term here is 2x divided by 75. Now I can also write this as 2 by 75 into x. Now if you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, which is 2 divided by 75, and we'll find derivative of the power term. The power value here is 1 and we know derivative of a term with power value 1 is also 1. Therefore derivative of x to the power 1 is 1. Therefore d square pi by dx square is minus 2 divided by 75. Step 1, step 2 and step 3 is done. Now based on the value of second order derivative, we'll know if x is equal to 600 is a point of minima or point of maxima. The trick is simple. If the second order derivative value is less than 0, if second order derivative is a negative value, that means x is equal to 600 is a point of maxima. And if second order derivative is a positive value, that means x is equal to 600 is a point of minima. Now if you observe carefully, d square pi by dx square is a negative value, that means x is equal to 600 is a point of maxima. So since the second order derivative, that is d square pi by dx square, is a negative value, is less than 0, x is equal to 600 is a point of maxima. Requirement number 1 is done. So if 600 units of this doll are produced, total profit will be maximized. Now let's go to requirement number 2. Identify the price the company should charge so that maximum profits can be earned. So now we'll have to identify the price at which company can earn maximum profits. Now equation for price P is 20 minus x by 75. In requirement 1, we obtained the value of x, that is 600. So if I put x is equal to 600 at this equation, we'll get the price at which company earns maximum profit. Let's do that. So equation for price is 20 minus x by 75. Now let's put the value of x, that is 600. So at x is equal to 600, price P is 20 minus 600 by 75. Now 600 by 75 is 8. Therefore price P is 20 minus 8, which is 12 rupees. So if this company charges 12 rupees per doll, it will earn maximum profit. Requirement number 2 is done. Now let's go to requirement number 3. Assess the maximum profit earned by this company, that is Zoxin Limited. Now equation for total profit is 16x minus x square by 75 minus 1400. So in this equation, if I put the value of x, which is 600, we'll get to know what is the total profit earned by this company. Let's do that. So equation for total profit is 16x minus x square by 75 minus 1400. Now let's put the value of x, which is 600. So at x is equal to 600, total profit is 16 into 600 minus 600 square divided by 75 minus 1400. Now if we compute these values, we'll get total profit as rupees 3400. Therefore, total profit earned by this company, that is Zoxin Limited, is 3400. The given question is successfully solved. The next concept is partial differentiation. In Unit 1, we learned how to solve a question of maxima and minima if the equation has single variable, that is single variable optimization. Now the question is, how to solve a question of maxima and minima if the given equation has two variables? What if the question has both x and y? So in such cases, we'll be using partial differentiation. So keep in mind, if the given equation has single variable, then we'll use normal differentiation to solve the question. But if the given function or given equation has more than one variable, If the given equation is a multivariable equation, then we'll be using partial differentiation. Now, partial differentiation is similar to normal differentiation that we have already studied, but with slight changes and adjustments. Let's understand this with the help of an example. F is 3x square plus 2xy plus y square. Now tell me how many variables are present in this equation. If I go through this equation, you'll notice that there are two variables here, x and y. Now that means I'll have to differentiate this equation first with respect to x and then with respect to y. Now since I'll have to differentiate this equation twice, first with respect to x and then with respect to y, we'll be using partial differentiation. So the question is, how to find partial differentiation? The trick is simple. When you are partially differentiating a function with respect to one variable, you'll assume that the other variable is constant. For example, in this particular example, when I'm partially differentiating function x with respect to x, I'll assume that the other variable, that is y, as constant. Similarly, when I'll be partially differentiating this function f with respect to y, I'll assume that the other variable, that is x, to be constant. As simple as that. Now let me give you guys one more thought process behind it to understand it even better. Now in CMA Final, there are a total of 8 subjects divided into 2 groups. Let's say in the first group, you have completed studying 2 subjects and there are 2 subjects pending, SCM and SFM. Now tell me, when you are studying the subject of SCM, at the same time, are you also studying SFM? The answer is no. When you are studying SCM, your whole focus is on SCM and you will ignore SFM. Similarly, when you are studying the subject of SFM, your whole focus is on SFM and you will ignore SCM. That's the logic here. When we are partially differentiating this function with respect to x, our focus is only on x and we will ignore the other variable, that is y. So y is assumed as constant. Similarly, when we are partially differentiating function f with respect to y, our focus is only on y and we will ignore the other variable. So x is assumed as constant. That's the trick here. Now partial derivative is represented using this keyword, which is called as del. So partial derivative of function f with respect to x is written as del f divided by del x. Now there is one more way to write it. I can also write this as fx. So this tells us that we are differentiating function x partially with respect to x. Now let's partially differentiate this function with respect to x. The first term here is 3x square. If you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, which is 3, and we'll find derivative of the power term, that is x square. Let's apply power rule. The power value here is 2, so in its derivative, 2 comes down, x is written as it is, and the power value of x reduces by 1, that is 1, plus the second term is 2xy. Now I can also write this as 2yx. Is this right? Now since we are partially differentiating function x with respect to x, we have assumed that y is constant. That means the term 2y is constant here. Now if you notice, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value, which is 2y, is written as it is, and we'll find derivative of the power term, that is x. Now the power value is 1 and we know derivative of a term with power value 1 is also 1. Therefore derivative of x to the power 1 is 1, plus the last term is y square. Now since we have assumed y as constant, this whole term is constant and its derivative is 0. Therefore partial derivative of function f with respect to x is 6x plus 2y. Now similarly, let's find partial derivative of function f with respect to y, that is del f by del y. We can also write this as fy. The first term here is 3x square. Now since we are partially differentiating function x with respect to y, we have assumed x as constant. So the whole term becomes constant and its derivative is 0 plus the second term is 2xy. Now x is constant here, therefore the term 2x is also constant. Now if you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, which is 2x, and we'll find derivative of the power term, that is y to the power 1. Now the power value is 1 and we know derivative of a term with power 1 is 1. Therefore derivative of y to the power 1 is 1 plus the last term is y square. Now let's apply power rule. The power value is 2, so in its derivative the power value comes down, y is written as it is, and the power value of y reduces by 1, that is 1. Therefore partial derivative of function y with respect to y is 2x plus 2y. Now this is how you find partial derivative. So keep in mind, if the given equation has single variable, then we'll use normal differentiation to solve the question. But if the given equation has multiple variable, then we'll be using partial differentiation. Now let's understand how to solve a question of maxima and minima which has multiple variables, that is multivariable optimization. We'll understand this by comparing it with single variable optimization. As you guys already know, single variable optimization is solved using 3 steps. So for the given equation, in the first step, we'll differentiate the given equation or find the first order derivative. For instance, if the given equation is y and it is in terms of x, then we'll find the first order derivative, that is dy by dx. This is step number 1. Now our goal here is to find the value of x, which is either a point of minima or a point of maxima. So in order to find the value of x, in step 2, we'll assume that the first order derivative is 0. Here the first order derivative is dy by dx, so we'll assume dy by dx is equal to 0, solve the equation and find the value of x. Now the value x obtained here is either a point of minima or a point of maxima. But the problem is, we don't know if this is a point of minima or a point of maxima. For that reason, we'll perform step number 3, where we'll find second order derivative. So we'll again differentiate this equation and find second order derivative. Now once this is done, based on the value of second order derivative, we'll obtain a result. If second order derivative value is greater than 0, if second order derivative value is positive, that means minima exist. And if second order derivative is less than 0, if second order derivative is a negative value, that means maxima exists. Now this is how you solve a question using single variable optimization. Now talking about multivariable optimization, the first 3 steps here are same as that of single variable optimization with 1 additional steps. That means multivariable optimization is a 4-step process. Let's understand this with the help of an example. F is equal to 3x square plus 2xy plus y square. So the first step here is finding the first order derivative, which is same as that of single variable optimization. Now if you go through this equation, you'll notice that there are 2 variables here, x and y. Now that means we'll have to differentiate this equation first with respect to x, that is fx, and then with respect to y. So this is step number 1, where we'll differentiate the given equation with respect to 2 variables. Now our goal here is to find the value of x and y. So in order to find the value of x and y, in step 2, we'll assume that the first order derivative is equal to 0. This is same as that of single variable optimization. So in step 2, which is also called as necessary condition, we'll assume that the first order derivative is 0. Now the first order derivative obtained here is fx and fy. So we'll equate this to 0, solve this equation and find the value of x and y. Now the value obtained x and y is called as critical value. We have a problem here. We don't know if x and y, the critical value obtained, is either a point of minima or a point of maxima. For that reason, we'll perform step number 3. So in step 3, we'll find all the possible second order derivative. Now the example that we considered is f is equal to 3x square plus 2xy plus y square. Now in this equation, we have 2 variables, that is x and y. So on partially differentiating this equation with respect to both the variables, we'll have fx and fy. We did this in step number 1. Now in step number 3, we'll have to again partially differentiate this equation with respect to both variables, that is x and y. That means we'll have 4 different combinations here. So if I partially differentiate fx with respect to x, I'll have fxx. If I partially differentiate fx with respect to y, I'll have fxy. Similarly, if I partially differentiate fy with respect to x, I'll have fyx. And if I partially differentiate fy with respect to y, I'll have fyy. Now if you observe carefully, fxy and fyx are similar. That means calculating any one among these values is sufficient. So in total, we'll have 3 different combinations of second order derivative. So the first one is fxx, the second one is fxy, and the third one is fyy. So from the first order derivative obtained in step 1, we'll have 3 combinations of second order derivative. Now fxx is assumed as A, fxy is assumed as B, and fyy is assumed as C. So keep in mind, this is very important. Fxx is assumed as A, fyy is assumed as C, and the combination of xy, that is fxy, is assumed as B. So this is step number 3. I know this sounds all confusing, but trust me, when we actually solve a problem, you'll understand it even better. Now talking about single variable optimization, based on the value of second order derivative, we obtained the result. Based on the value of second order derivative, we got to know if maxima exists or minima exists. Now coming back to multivariable optimization, since we have 3 different combinations of second order derivative, we cannot directly obtain a result. That is the reason we'll perform one extra step, that is step number 4. So in step 4, using all these values, we'll calculate D. Now value of D is A into C minus B square. So this is step number 4, where we'll compute the value of D, which is A into C minus B square. Now based on the value of D, we'll obtain a result. So remember this, a valid solution exists to a problem only if D is greater than 0. If D is less than 0, then that means saddle point exists. And if D is equal to 0, that means the test fails. So remember this, in case of multivariable optimization, a valid solution exists only if D is greater than 0. Now the question is, when will maxima exist and when will minima exist? Now this is computed based on the value of A and C. Now if I go back to single variable optimization, maxima exists if second order derivative is less than 0 and minima exists if second order derivative is greater than 0. The same logic is applicable here. If value of A and C is greater than 0, then that means minima exists. And if value of A and C is less than 0, that means maxima exists. So keep in mind, a valid solution to a problem only exists if D is greater than 0. So if A and C is less than 0, that means maxima exists. And if A and C is greater than 0, that means minima exists. Now this is how we solve a question using multivariable optimization. I know all these things, all this concept is going over your head, but trust me, when we are actually solving a problem, you'll understand it even better. Now let's solve a question. A company produces 2 products, X and Y. Now a company manufactures 2 products, product X and product Y. The total profit earned by this company, which is given in terms of 1000, is expressed as P is equal to 100x minus x square minus 2xy plus 200y minus 3y square. Now the total profit earned by this company is given in terms of an equation, which is this one. So let's copy this equation. That is P is equal to 100x minus x square minus 2xy plus 200y minus 3y square. Now using the equation given, you are required to find the profit maximizing quantities of the products. Now that means the objective here is maximization of total profit. So you are required to find the profit maximizing quantities of the product. So you will have to find out how many units of X should be made, how many units of Y should be made, so that maximum profits can be earned by this company. You are also required to find out the maximum profit earned by this company. Now let's solve this question. Now if you remember, in this particular chapter, that is Maxima and Minima, no matter what the question is, the first thing you'll have to do is form an equation as per the requirement. Now our objective here is maximization of total profit. So the first thing that we'll have to do is form an equation in terms of total profit. Now the good thing is, equation for total profit is already given in the question. So using this equation, let's solve the question. Now I want you guys to go through this equation and tell me how many variables are present. If you go through this equation, you'll notice that there are two variables here, variable x and variable y. Now since there are two variables here, this is a multivariable equation. So let's solve this question using multivariable optimization. So the first step here is differentiating the given equation and finding the first order derivative. So step 1 is finding the first order derivative. Now the equation here is in terms of x and y. So that means we'll have to partially differentiate this equation first with respect to x and then with respect to y. So if I partially differentiate this equation with respect to x, this becomes px. Now we know the trick here. If you are partially differentiating with respect to one variable, we'll assume that the other variable is constant. So here we'll assume that y is constant. The first term here is 100x. If you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is and we'll find derivative of the power term, that is x. Now the power value is 1 and we know derivative of a term with power value 1 is also 1. Therefore derivative of x to the power 1 is 1 minus the second term is x square. Now this is a power term, so let's apply power rule. The power value here is 2. So in its derivative, the power value comes down, that is 2. X is written as it is and the power value of x reduces by 1 minus the third term here is 2xy. Now I can also write this as 2yx. Is this right? Now since we are partially differentiating with respect to x, we'll assume that y is constant. Now that means the term 2y here is a constant value. Now if you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value which is 2y is written as it is and we'll find derivative of the power term. The power value is 1, so its derivative is also 1 plus the next term is 200y. Now since y is assumed as constant here, the whole term is a constant and its derivative is 0 minus the last term is 3y square. Now y is assumed as constant, so the whole term becomes a constant and its derivative is 0. Therefore partial derivative of p with respect to x is 100 minus 2x minus 2y. So this is equation number 1. Now let's partially differentiate this equation with respect to y, that is py. Now since we are partially differentiating with respect to y, we'll assume the other variable, that is x, as constant. Now let's find its derivative. The first term here is 100x. Since x is assumed as constant, the whole term becomes constant and its derivative is 0 minus the second term is again x square. X is assumed as constant here, so this term becomes a constant and its derivative is 0 minus the next term is 2xy. Now since we have assumed x as constant here, 2x becomes constant. Now if you observe carefully, this term here is a combination of a constant value multiplied by a power term. So in its derivative, the constant value is written as it is, which is 2x, and we'll find derivative of the power term. The power value here is 1, so its derivative is also 1 plus the next term is 200y. Now this term here is a combination of a constant value multiplied by a power term. So the constant value is written as it is and we'll find derivative of the power term, that is y to the power 1. Now the power value is 1, so its derivative is also 1 minus the next term is 3y square. Now we'll write the constant value as it is, which is 3, and find the derivative of the power term, that is y square. Now let's apply power rule. The power value here is 1. So on applying differentiation, 2 comes down, y is written as it is, and the power value of y reduces by 1, that is 1. Therefore, partial differentiation of p with respect to y is minus 2x plus 200 minus 6y. This is equation number 2. So step number 1 is done, where we computed the first order derivative. Now tell me, what is our goal here? If you go back to the question, you are required to find out the profit maximizing quantities of the product x and y. Now that means our goal here is to find the value of x and find the value of y. So in order to find the value of x and y, in step 2, we'll assume that the first order derivative is 0. So in step 2, we'll assume that the first order derivative is 0. Now the first order derivative obtained is px and py. So we'll assume that px is 0 and py is 0. Now partial derivative of p with respect to x is 100 minus 2x minus 2y, and we'll equate this to 0. Partial derivative of p with respect to y is minus 2x plus 200 minus 6y. We'll again equate to this 0 and find the value of x and y. Now let's solve this equation. Now from equation A, 100 minus 2x minus 2y is equal to 0. Now let me move the term 2x and 2y to the other side. So the equation becomes 2x plus 2y is equal to 100. So this is going to be equation number 1. So from B, we have obtained that minus 2x plus 200 minus 6y is equal to 0. So if I move the term minus 2x and minus 6y to the other side, the equation becomes 2x plus 6y is equal to 200. Now let's solve both these equations and find the value of x and y. The trick is simple. First let me write down the equations. So the equation is 2x plus 2y is equal to 100, and the second equation is 2x plus 6y is equal to 200. The trick is simple. In the second equation, we'll turn plus symbol into minus symbol and minus symbol into plus symbol. So this is plus symbol, this becomes minus, this plus symbol becomes minus, and this plus symbol becomes minus. Now minus 2x plus 2x is 0. Minus 2y plus 6y is plus 4y is equal to 200 minus 100 is 100. That means value of y is 100 divided by 4, which is 25. So using these equations, we computed the value of y. Now let's put this value in any one of these equations and find the value of x. So from equation star, we know 2x plus 2y is equal to 0. Now let's put the value of y is equal to 25 in this equation. So if y is equal to 25, 2x plus 2 into 25 is equal to 100. That means 2x is 100. Now if I move this term to the other side, this becomes minus 50. Therefore value of x is 50 divided by 2, which is 25. So now we have obtained the value of x and y, which is 25 and 25. Now we have a small problem here. Now x is equal to 25 and y is equal to 25 is either a point of minima or a point of maxima. But we don't know if this is a point of minima or point of maxima, and for that reason we'll go to step number 3. In step 3, we'll find second order derivative. Now second order derivative is simply derivative of first order derivative. Now in step 1, we differentiated function p with respect to x and y and obtained two equations for first order derivative, that is px and py. Now let's copy these equations. So from 1, partial differentiation of function p with respect to x is 100 minus 2x minus 2y, and from 2, partial differentiation of function p with respect to y is minus 2x plus 200 minus 6y. Now since function p is in terms of x and y, we'll have to again differentiate both these equations, first with respect to x and then with respect to y. So now let's partially differentiate equation 1 with respect to x. So the second order derivative becomes pxx. Now this means we are partially differentiating px with respect to x. The first term here is 100. Now since 100 is a constant value, its derivative is 0 minus the second term is 2x. Now this is a combination of a constant value multiplied by a power term. So in its derivative, constant value is written as it is and we'll find derivative of the power term. Now the power value here is 1, therefore its derivative is 1 minus the last term is 2y. Now since we are partially differentiating with respect to x, we'll assume y as constant. So the whole term becomes constant and its derivative is 0. Therefore pxx is minus 2. Now let's assume that this value is a. Similarly, let's partially differentiate equation 1 with respect to y. So the second order derivative becomes pxy. This means we are partially differentiating px with respect to y. The first term here is 100. Since this is a constant value, its derivative is 0 minus the second term is 2x. Since we are partially differentiating with respect to y, we'll assume x as constant. So the whole term becomes constant and its derivative is 0 minus the last term is 2y. Now this is a combination of a constant value multiplied by a power term. So we'll write the constant value as it is and find the derivative of the power term. Now the power value is 1, therefore its derivative is 1. That means value of pxy is minus 2. Now let's assume that this value is b. Now from equation 2, we obtained py as minus 2x plus 200 minus 6y. Now let's differentiate this equation with respect to y. So if we partially differentiate equation 2 with respect to y, the second order derivative becomes pyy. Now this means we are partially differentiating py with respect to y. Now let's find the value. The first term here is minus 2x. Since we are partially differentiating with respect to y, we'll assume x as constant. So the whole term becomes constant and its derivative is 0 plus the second term is constant, therefore its derivative is also 0 minus the last term is 6y. Now we'll write the constant value as it is and find derivative of y. Since the power value is 1, its derivative is also 1. Therefore pyy is minus 6. Now let's say this value is c. So keep in mind, pxx is assumed as a, pyy is assumed as c, and the combination of x and y, that is pxy, is assumed as b. Now using all these values, let's go to step number 4 and find the value of d. So in step 4, we'll compute d and value of d is ac minus b square. Now value of a is minus 2 and value of c is minus 6. That means a into c is minus 2 into minus 6 minus value of b is minus 2. Therefore b square is minus 2 whole square. Now minus 2 into minus 6 is plus 12 minus minus 2 square is plus 4. Therefore value of d is 8. Now based on the value of d, we'll have a valid solution. Keep in mind, a valid solution exists to a problem only if d is greater than 0. Now if you observe carefully, value of d is 8 and this is greater than 0. So since d is greater than 0, a valid solution exists to this problem. Now the question is, when will maxima exist and when will minima exist? The trick is simple. If value of a and c is greater than 0, that means minima exists, and if value of a and c is less than 0, that means maxima exist. If you observe carefully, value of a is minus 2 and value of c is minus 6. Since both a and c is less than 0, maxima exist. Requirement number 1 is done. Therefore, profit maximizing units of this product are 25 and 25. That is value of X and Y. Now let's go to requirement number 2. You are asked to find the maximum profit earned by this company. Now equation for total profit is given in the question. So let's use this equation and find the total profit earned by this company. So the equation for total profit is P is equal to 100x minus x square minus 2xy plus 200y minus 3y square. Now in requirement number 1, we computed the value of x and y, which is 25 and 25. So let's put this value of x and y in this equation and compute the total profit earned by this company. So at x is equal to 25 and y is equal to 25, value of P is 100 into 25 minus 25 square minus 2 into 25 into 25 plus 200 into 25 minus 3 into 25 square. Now if I compute all these values, I'll get the value as 3750. Now in the question, it is mentioned that the total profit earned is in terms of 1000. That means total profit earned by this company is rupees 3750 thousands. We have successfully solved the given question. I hope now you guys have understood how to solve a question of maxima and minima. Let's move on to the next chapter, that is learning curve. Now learning curve might sound technical, but it is something we have all experienced in real life. Once you guys have understood what learning curve is, trust me, you'll start noticing it everywhere. So what is learning curve? Let's look into that. Imagine a worker is assigned with a new task for the very first time. He has never worked on this task before, he has no prior experience and is still figuring out how to do it properly. Now because of that, he ends up taking the most amount of time during his first attempt. Now here's where it gets interesting. When the same person performs the same task for the second time, he is more confident, he makes fewer errors and the time taken is less. When he does the same task for the third time, time taken is even less. When he does the same task for the fourth time, time taken is even less compared to the previous attempts. So what's happening here? When a person repeats the same task again and again, he gains more experience, he gets more accurate and his performance keeps improving. Now as a result, the time taken keeps dropping with every repetition. Now this entire process is what we call as learning curve. Now in real world, there are two types of work. The first one is manual work performed by humans and the second one is automated work performed by machines. Now let me tell you, learning curve is only applicable for manual work and not automated work. This is because humans learn and improve with every repetition, whereas machines performs the task the same way every single time. Let's look at a few examples to understand this in a better way. How many of you here know how to cook? Well, the only dish I know to cook properly even today is Maggi. But if I go back in time and think about the first time I cooked Maggi, I messed it up. I put too much water, I overcooked the noodles and I kept on reading the instructions. Now as a result, when I cooked Maggi for the first time, I took around 15 minutes. Now when I cooked Maggi for the second time, I got a little better at it. When I cooked Maggi for the third time, time taken was even less. Now since I've cooked Maggi multiple times, today I can cook Maggi in under 5 minutes. Now this drop in cooking time while making Maggi again and again is an example of learning curve. Now what if I tell you, you guys have experienced learning curve in your CMA final preparation. Let's say you are studying the subject of strategic cost management for the first time. Now to complete the entire subject of strategic cost management, you take around 150 to 200 hours. Let's say you take 150 hours. Now since you have covered the entire subject once, when you study the same subject for the second time, time taken is not 150 hours. You've watched videos, you've made notes and you have understood concepts. So when you revise the same subject for the second time, time taken is around 80 hours. Now when you revise the same subject for the third time, time taken is even less. You can complete the subject in around 50 hours. Now one day before the exam, when you revise the same subject for the fourth time, you complete the entire syllabus in 10 to 12 hours. Now this drop in time while studying the same subject again and again is a perfect example of learning curve. Now you guys might be thinking, learning curve is observed in real life, but why is it included in our syllabus? Do real world business actually use learning curve? Let's look into that. Now a worker is assigned with the task of making study table. This worker has never made study table before. So when he makes the first study table, he takes around 50 hours. Now he has gained some experience. He knows how to make a study table. So when the same worker makes study table for the second time, he takes around 35 hours. Now here's the scenario. There are two companies, company A and company B. Company A has no idea about learning curve. Now since the worker has taken 50 hours to make the first table, company A estimates that a total of 100 hours is required to make two tables. Now labor cost of this worker is 100 rupees per hour. So company A ends up paying 100 into 100, that is 10,000 rupees. Now on the other hand, company B understands learning curve and it knows when the worker makes study table for the second time, time taken is less. Now this worker takes 50 hours to make the first table and 35 hours to make the second study table. So company B estimates that a total of 85 hours is required to make two study tables. Now labor cost of this worker is 100 rupees per hour. Therefore company B ends up paying 8,500 rupees to this worker. Now if you observe, company A has paid 10,000 rupees whereas company B has paid 8,500 rupees to make the same two tables. Now company B was able to save 1,500 rupees because it understands learning curve and it made the right cost estimation. Now this is exactly why learning curve is required in business. So what is learning curve? When a person performs a task for the first time, they take the most amount of time to do it because they are learning how to do it. However, when the same task is repeated again and again, the person starts to understand it better, he becomes faster at it, and as a result, the time taken to complete the task keeps reducing. Now this entire process of getting better over time and the reduction in the time taken is called as learning curve. In simple words, learning curve is the more you do a task, the better and faster you become. As we have already discussed, learning curve is only applicable for manual work and not automated work. Now that you have understood what learning curve is, let's go to the next concept, that is theory of learning curve. Now theory of learning curve is also called as doubling approach. It states that if a worker repeats the same task again and again, then every time production doubles, the average time per unit or the average cost per unit drops by a constant rate. Now this constant rate by which time drops is called as learning rate. Let's understand this with the help of an example. A worker takes 10 hours to make 1 unit of a product. Since the number of unit is 1, the average time taken is also 10 hours. Now let's assume that the learning rate for this worker is 80%. This means this particular worker has an 80% ability to learn and improve. Now according to the theory of learning curve, every time production doubles, the average time drops by a constant rate. Since the learning rate is 80%, when production doubles from 1 to 2, average time becomes 80% of the previous average. Now 80% of 10 is 8 hours. Therefore the average time required to make 2 units is 8 hours. Now keep in mind, if learning rate is 90%, then average time required to make 2 units is 90% of 10, that is 9 hours. Now let's double the production again. So when production doubles from 2 to 4, average time becomes 80% of the previous average, that is 80% of 8, which is 6.4 hours. Therefore average time required to make the first 4 units is 6.4 hours. Now keep in mind, learning rate applied is always on average time and not the total time. Now let's double the production again. So when production doubles from 4 to 8, average time becomes 80% of the previous average, that is 80% of 6.4. which is 5.12. Therefore, the average time required to make the first 8 units is 5.12 hours. Now we have obtained average time required to make all these units. Can we calculate the total time? Yes, we can. Average time required to make the first 2 units is 8 hours. Therefore, the total time required is 8 into 2, that is 16 hours. Now, average time required to make the first 4 units is 6.4. Therefore, the total time required is 6.4 into 4, that is 25.6. Now, average time required to make the first 8 units is 5.12. Therefore, the total time required is 5.12 into 8, that is 40.96. Now, if you observe, every time production doubles, average time drops by a constant rate. So, according to the theory of learning curve, average time drops by a constant rate, but this happens only if the production doubles. So, using doubling approach, now we have obtained the average time and total time for all these number of units. Now, the total time required to make the first 8 units is 40.96, and the total time required to make the first 4 units is 25.6. Now, using this data, tell me what is the total time required to make the next 4 units, that is 5th, 6th, 7th and 8th unit. Now, before we proceed further, I will give you guys a small example. Suppose I am travelling from Bangalore to Chennai. Now, the total distance from Bangalore to Chennai is 350 kilometers. Now, while I am travelling from Bangalore to Chennai, I will pass through one more city, that is Mysore. Now, the total distance from Bangalore to Mysore is 150 kilometers. Now, tell me what is the total distance from Mysore to Chennai? This is very simple. The total distance from Mysore to Chennai is the total distance from Bangalore to Chennai, that is 350 kilometers, minus the total distance from Bangalore to Mysore, which is 150 kilometers. 350 minus 150 is 200. Therefore, the total distance from Mysore to Chennai is 200 kilometers. Now, we will use the same logic and calculate the total time required to make 5th to 8th unit. Now, the total time required to make the first 8 unit is 40.96, and the total time required to make the first 4 unit is 25.6. Therefore, the total time required to make 5th to 8th unit is 40.96 minus 25.6, which is 15.36 hours. Now, this time that we have obtained is called as incremental time. Now, similarly, we can calculate the time required to make 3rd and 4th unit. Now, the time required to make 3rd and 4th unit is the total time required to make the first 4 unit, that is 25.6, minus the total time required to make the first 2 unit, which is 16 hours. 25.6 minus 16 is 9.6 hours. Therefore, total time required to make 3rd and 4th unit is 9.6 hours. So, now using doubling approach, we have learned how to calculate average time, how to calculate total time, and we have also learned how to calculate incremental time. Now, let's have a quick recap of doubling approach. Now, theory of learning curve, also called as doubling approach, states that if a worker performs the same task again and again, then every time production doubles, the average time per unit or the average cost per unit drops at a constant rate. Now, this constant rate by which time drops is called as learning rate. Suppose learning rate is 80%. According to the theory of learning curve, every time production doubles, average time per unit becomes 80% of the previous average. So, when production doubles from 1 to 2, average time becomes 80% of the previous average, that is 80 hours. When production doubles from 2 to 4, average time becomes 80% of the previous average, that is 64 hours. When production doubles from 4 to 8, average time becomes 80% of the previous average, that is 51.2 hours. As we have already discussed, learning rate is applied on average time and not total time. So, what exactly is learning rate? Let's look into that. In simple words, learning rate is the ability of a person to learn and improve. If learning rate is 80%, this means this particular worker has an 80% ability to learn and improve. Now, according to the theory of learning curve, when production doubled from 1 to 2, average time became 80% of the previous average. So I can write it as average time required to make the first 2 units is the average time required to make the first unit into learning rate. Learning rate here is 80%. Now this means learning rate is average time required to make the first 2 units divided by average time required to make the first unit. Now average time required to make the first 2 units is 80 hours and average time required to make the first unit is 100 hours. Therefore learning rate is 80 by 100, that is 80%. Now I can generalize this equation and write it as learning rate is average time or cost for 2n units divided by average time or cost for n units. Here n is the size of the lot. So if value of n is 2, average time, learning rate is average time required to make 2n units, that is 4 units, divided by average time required to make n units, that is 2 units. Now average time required to make the first 4 units is 64 hours and average time required to make the first 2 units is 80 hours. 64 by 80 is again 80%. So keep in mind, if average time for all these number of units are given, then you can make use of this formula, that is average time for 2n units divided by average time for n units and find the learning rate. Now let me ask you guys a question. We have 3 scenarios here. Learning rate being 90%, learning rate being 80% and learning rate being 70%. Now among these 3, tell me which is the best one. Is it 90% learning rate, or is it 80% learning rate, or is it 70% learning rate? Now if you think 90% learning rate is the best one, then your answer is wrong. Let me tell you why. Suppose a worker takes 10 hours to make 1 unit of a product. So if learning rate is 90%, when production doubles from 1 to 2, average time becomes 90% of 10, that is 9 hours. If learning rate is 80%, when production doubles from 1 to 2, average time becomes 80% of 10, that is 8 hours. If learning rate is 70%, when production doubles from 1 to 2, average time becomes 70% of 10, that is 7 hours. Now if you observe carefully, average time reduced more when learning rate was 70% and average time reduced less when learning rate was 90%. That means 70% learning rate is better than 80% learning rate and 80% learning rate is better than 90% learning rate. So keep in mind, if learning rate is 90%, then average time will drop by 10%. If learning rate is 80%, that means average time will reduce by 20%. If learning rate is 70%, that means average time will reduce by 30%. Therefore, higher the learning rate, lower is the improvement, and lower the learning rate, higher is the improvement. So keep in mind, among 90% learning rate, 80% learning rate and 70% learning rate, the best case is 70% learning rate. Let's have a look at these special points which are very important while solving the question. The first point says, if production is done batch-wise, learning effect applied is also batch-wise. Let's understand this with the help of an example. A company produces toys in a batches of 50 units. This means 50 toys are produced in one batch. Now the time taken to make the first batch is 1000 hours and the learning rate is 80%. You are required to calculate the average time and the total time taken for the first 2 batches. Let's solve this question. Now it is given in the question that 50 toys are made in one batch and the time taken for the first batch is 1000 hours. Since the number of batch is 1, the average time taken is also 1000 hours. As we have discussed, if production is done batch-wise, learning effect applied is also batch-wise. Now according to doubling approach, every time production doubles, average time reduces by a constant rate. Now learning rate is given in the question, that is 80%. So when production doubles from 1 to 2 batches, which is 100 units, average time becomes 80% of the previous average, which is 80% of 1000, that is 800 hours. Therefore, average time required to make the first 2 batches is 800 hours. Now, the total time required to make the first 2 batches is 800 into 2, that is 1600 hours. Now, let's write it down. Average time required to make the first 2 batches is 800 hours, and the total time required to make the first 2 batches is 1600 hours. So keep in mind, this is very important while solving a question. If production is done batch wise, learning effect applied is also batch wise. Now let's move to the next point. So far we have seen how labor time reduces with each repetition due to the effect of learning. Now let's see if learning effect is applicable on cost. If you think about it, the amount of money you pay to a worker, which is labor cost, depends on the amount of time he works, which is labor time. Now this means labor cost and labor time are directly linked to each other. Therefore, learning effect is applicable on labor cost and labor related cost. Now there is one more cost associated with the product, which is material cost. Let's see if learning effect is applicable on material cost. Assume 100 rupees worth of raw material is required to make 1 unit of a product. So if I make 1 unit, 10 unit or 100 units of the same product, material cost is going to be 100 rupees. This value is not going to change. Therefore, learning effect is not applicable on material cost. So remember this is very important while solving a question. Learning effect is applicable on labor hour. Learning effect is applicable on labor cost and labor related cost. But learning effect is not applicable on material cost. Now let's solve a question. This question was asked in December attempt of 2023 exam. What does the question say? Heavy India Shipbuilders produces a special type of boat and the learning rate here is 90%. It is agreed that boats will be supplied at variable cost plus 20%. This means selling price of the boat is variable cost plus 20% of variable cost. Therefore, selling price of the boat is 120% of variable cost. Now, variable cost of the boat depends on material cost, labor cost and variable overhead. As we have already discussed, learning effect is only applicable on labor cost and labor related cost. Learning is not applicable on material cost. Material cost for the first boat is 8,000 rupees. So no matter how many boats we produce, material cost per boat is going to be 8,000 rupees. This value is not going to change. Now for the first boat, material cost is 8,000 rupees, labor cost is 4,000 rupees and variable overhead is 200% of labor cost. Using this data, you are required to calculate the average selling price for an order of 4 boats and 8 boats. Let's solve this question. It is given in the question that labor cost for the first boat is 4,000 rupees. Learning rate here is 90%. Now according to doubling approach, every time production doubles, average labor cost becomes 90% of the previous average. Now let's use doubling approach and find the average labor cost for an order of 4 boats and 8 boats. So when production of boats doubles from 1 to 2, average labor cost becomes 90% of the previous average. That is 90% of 4,000 rupees. Therefore, average labor cost for the first 2 boats is rupees 3,600. When production doubles from 2 to 4, average labor cost becomes 90% of the previous average. That is 90% of 3,600. Therefore, average labor cost for the first 4 boats is rupees 3,240. When production of boat doubles from 4 to 8, average labor cost becomes 90% of the previous average. That is 90% of rupees 3,240. Therefore, average labor cost for the first 8 boats is rupees 2,916. So using doubling approach, we have calculated the average labor cost for the first 4 boats and first 8 boats. Now it is given in the question that selling price is 120% of variable cost. Now let's go back to the question. you are required to calculate the average selling price for an order of 4 boats and 8 boats. Selling price is 120% of variable cost. Therefore, in order to calculate selling price, first we'll have to calculate average variable cost. Let's do that. Now, average variable cost depends on material cost, labor cost and variable overhead. So, for an order of 4 boats and 8 boats, let's calculate each of these costs one by one. Now, material cost of the first boat is given in the question, that is 8,000 rupees. As we have already discussed, material cost, learning is not applicable on material cost. So, no matter how many boats we make, material cost is going to be 8,000 rupees. So, for an order of 4 boats, material cost is 8,000 rupees. And for an order of 8 boats, material cost is 8,000 rupees. Moving on, the next cost is labor cost. We have already obtained it using doubling approach. So, for an order of 4 boats, average labor cost is rupees 3,240. For an order of 8 boats, average labor cost is rupees 2,916. Now, the last cost required to calculate variable cost is variable overhead. Now, if I go back to the question, it is specifically mentioned that variable overhead is 200% of labor cost. Now, we have already calculated labor cost for an order of 4 boats and 8 boats. Using these values, let's calculate variable overhead. For an order of 4 boats, variable overhead is 200% of rupees 3240, that is rupees 6,480. Similarly, let's calculate variable overhead for an order of 8 boats. We know variable overhead is 200% of labor cost. For an order of 8 boats, variable overhead is 200% of rupees 2916, that is rupees 5,832. Now, we have calculated all the cost that is required to calculate average variable cost. Therefore, average variable cost is material cost plus labor cost plus variable overhead. So, for an order of 4 boats, average variable cost is 8,000 rupees plus rupees 3,240 plus 6,480, that is rupees 17,720. Similarly, let's calculate average variable cost for an order of 8 boats. Average variable cost for an order of 8 boats is 8,000 rupees plus rupees 2,916 plus 5,832, that is rupees 16,748. So, now we have obtained average variable cost for an order of 4 boats and 8 boats. We know selling price of the boat is 120% of variable cost. Therefore, average selling price for an order of 4 boats is 120% of rupees 17,720. Therefore, average selling price for an order of 4 boats is rupees 21,264. Similarly, let's calculate average selling price for an order of 8 boats. Average selling price for an order of 8 boats is 120% of variable cost. Now, variable cost for an order of 8 boats is rupees 16,748. Therefore, average selling price is 120% of rupees 16,748. That is rupees 20,097.6 rupees. So, we have calculated average selling price for an order of 4 boats and for an order of 8 boats. We have successfully solved this question. Now you guys have understood how to solve a question using doubling approach. Doubling approach, which is also called as theory of learning curve, states that if a worker repeats the same task again and again, then every time production doubles, the average time or the average cost drops at a constant rate. So if the number of units made falls in the doubling sequence, that is 1, 2, 4, 8 and so on, we can make use of doubling approach and solve the given question. Now there is one drawback of doubling approach. What if the production doesn't double? How to solve a question if the number of units made is 3, 5 or 10. Since these number of units do not fall in the doubling sequence, doubling approach cannot be used here. So keep in mind, in such cases where doubling approach cannot be used, we'll make use of formula approach to solve the given question. Now this means a given learning curve question can be solved using two methods. The first one is doubling approach and the second one is formula approach. Now let's see when to use doubling approach and when should we use formula approach. If the number of units made falls in the doubling sequence, that is 1, 2, 4, 8, 16 and so on, we'll make use of doubling approach to solve the given question. On the other hand, if the number of units does not become double of the preceding unit, that is, the number of units made do not fall in this doubling sequence, then we'll make use of formula approach to solve the given question. Now let's see how to solve a given question using formula approach. The formula to be used is y is equal to a into x to the power b. Here y is average time or average cost required to make x number of units. A is the time taken to make the first unit. X is the cumulative number of units. And B is learning index, which is also called as learning coefficient. Now value of B is log of learning rate divided by log of 2. So if learning rate is 80%, value of B is log of 0.8 divided by log of 2. That is minus 0.322. Now in your exam, 95% of the time, value of B will be given to you in the question. So keep in mind, average time or average cost for x number of units is computed using this formula, that is y is equal to a into x to the power b. Now there is one tricky part in this formula, that is calculation of x to the power b. Let's understand this with the help of an example. A worker takes 100 hours to make the first unit. This means value of A is 100. If learning rate is 90%, calculate the average time taken for the first 10 units. Value of B is given in the question, that is minus 0.322. As you guys already know, a given question can be solved using two methods. The first one is doubling approach and the second one is formula approach. Now you are required to calculate the average time for the first 10 units. Since 10 do not fall in the doubling sequence, doubling approach cannot be used here. So we'll have to make use of formula approach to solve this question. Now average time taken for 10 units is given by the formula y is equal to a into x to the power b. Here value of a is 100 hours, x is the number of units, that is 10, and value of b is given in the question, which is minus 0.322. Now using these values, let's calculate the average time required to make the first 10 units. That is 100 into 10 to the power minus 0.322. Now if you observe carefully, this value cannot be obtained directly using the calculator. Now this is the tricky part in this formula. Now in order to calculate this value, we can make use of two methods. Either you can solve this using log approach, or you can find this value using a simple calculator trick. If you are comfortable with log approach, you can go ahead with this method and find this value. But personally, I would recommend you guys to use the calculator trick to find this value. So keep in mind, average time for x number of units is obtained using this formula, that is y is equal to a into x to the power b. Now let's solve a question. This question was asked in June 25 and December 23 attempt of model question paper. What does the question say? The usual learning curve model is y is equal to a into x to the power b. Y is the average time A is the time taken for the first unit and x is the cumulative number of unit. Now value of B is given in the question, that is minus 0.322. The time taken for the first unit is 10 hours. Now using this data, you are required to calculate the average time for the first 20 units. Now we know average time for x number of unit is given by the formula y is equal to a into x to the power b. Now a is the time taken for the first unit, that is 10 hours. X is the number of unit, that is 20, and value of b is given in the question, that is minus 0.322. Now using these values, let's calculate the average time for the first 20 unit. Therefore average time for the first 20 unit is 10 into 20 to the power minus 0.322. Now keep in mind, 20 to the power minus 1 can be written as 1 divided by 20. 20 to the power minus 2 can be written as 1 divided by 20 whole to the power 2. 20 to the power minus 3 can be written as 1 divided by 20 whole to the power plus 3. Therefore, 20 to the power minus 0.322 can be written as 1 divided by 20 whole to the power plus 0.322. Therefore, average time for the first 20 units is 10 into 1 divided by 20 whole to the power plus 0.322. Now if you observe carefully, this particular value cannot be obtained directly using a calculator. As we have discussed earlier, in order to find this value, you can either use log approach or you can make use of a simple calculator trick to find this value. Now I'll teach you guys how to obtain this value using a simple calculator trick. So now we'll find this value using this calculator trick. In step number 1, we'll take the base value and press square root 12 times. Now the base value is 1 divided by 20. So in my calculator, I'll press 1 divided by 20. That is 0.05. Now on this value, I'll press square root key 12 times. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Step number 1 is done. Now on step number 2, I'll subtract 1 from the result. Therefore, in my calculator, I'll press minus 1. In step number 3, you'll multiply this value by power. The power value here is 0.322. Therefore, in my calculator, I'll press into 0.322. Now in step number 2, you have subtracted 1 from the result. So in step number 4, I'll add 1 to this value. Therefore, in my calculator, I'll press plus 1. Now the last step, which is step number 5, you'll press into is equal to 12 times. Now keep in mind, first you'll press into and then you'll press is equal to. Into is equal to is one repetition. So in total, you'll press into is equal to 12 times. That is, into is equal to once, into is equal to twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the final result obtained in my calculator is this value. Therefore, value of 1 divided by 20 whole to the power 0.322 is 0.3812. Therefore, average time required to make the first 20 units is 10 into 0.3812. That is 3.812 hours. Requirement number 1 is done. Now let's see what is requirement number 2. Calculate the total time required for the first 30 units. Now we know average time for x number of unit is given by the formula y is equal to a into x to the power b. A is the time taken for the first unit, that is 10 hours. X is the number of unit, that is 30, and value of b is given in the question, that is minus 0.322. Now using this value, let's calculate the average time for the first 30 unit. That is 10 into 30 to the power minus 0.322. Now I'll write this value as 10 into 1 divided by 30 whole to the power plus 0.322. Now we'll find this value using the simple calculator trick. Let's find the value of 1 divided by 30 whole to the power plus 0.322 using this calculator trick. Now step number 1 is take the base value and press square root 12 times. The base value here is 1 divided by 30. So in my calculator, I'll press 1 divided by 30. Now on this value, I'll press square root 12 times. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Step number 1 is done. In step number 2, we'll subtract 1 from the result. So in my calculator, I'll press minus 1. In step number 3, you'll multiply this value by power. The power value is 0.322. So I'll press into 0.322. Now since you have subtracted 1 in step number 2, in step number 4, I'll add 1 to this value. So I'll press plus 1. Now the last step, which is step number 5, you'll press into is equal to 12 times. Into is equal to once, into is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the final result obtained here is the value of this, that is 1 divided by 30 whole to the power 0.322 is 0.3345. Therefore average time required to make the first 30 units is 10 into 0.3345, that is 3.345 hours. Now we are required to calculate the total time required for the first 30 units. Therefore, total time required for the first 30 units is 30 into 3.345. That is 100.35 hours. Therefore, the total time required to make the first 30 unit is 100.35 hours. Requirement number 2 is also done. Now let's look at requirement number 3. Calculate the total time required for units 31 to 40. Now the total time required for units 31 to 40 is the total time required to make the first 40 units minus the total time required to make the first 30 unit. So let's calculate the total time required to make the first 40 units. We know average time for x number of unit is given by the formula y is equal to a into x to the power b. Now value of a is 10 hours, number of units is 40 and value of b is given in the question, that is minus 0.322. Therefore average time required to make the first 40 units is 10 into 40 to the power minus 0.322. Now I'll write this value as 10 into 1 divided by 40 whole to the power plus 0.322. Now let's find this value using the simple calculator trick. In step number 1, you will take the base value and press square root key 12 times. The base value is 1 divided by 40. So in my calculator, I'll press 1 divided by 40. Now on this value, I'll press square root key 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In step number 2, you'll subtract 1 from the result. So I'll press minus 1 in my calculator. In step number 3, you'll multiply this value by power. The power value is 0.322. So I'll press into 0.322. Now since you have subtracted 1 in step number 2, in step number 4, I'll add 1 to this value. So I'll press plus 1. Now the last step, which is step number 5, you'll press into is equal to 12 times. Into is equal to once, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I've obtained the value. Therefore, value of 1 divided by 40 whole to the power 0.322 is 0.3045. Therefore, average time required to make the first 40 units is 10 into 0.3045, that is 3.045 hours. Now let's calculate the total time required to make the first 40 units. the total time required to make the first 40 units is 40 into 3.045. That is 121.96 hours. Now we have obtained the total time required to make the first 40 units, that is 121.96 hours. Now in requirement number 3, you are required to calculate the total time taken for 31 to 40 unit, that is total time required to make the first 40 units, which is 121.96 minus the total time required to make the first 30 units. Now we have already obtained the total time required to make the first 30 units in requirement number 2. Therefore total time required to make 31 to 40 units is total time taken to make the first 40 units, that is 121.96 minus the total time required to make the first 30 unit, that is 100.35. Therefore total time required to make 31 to 40 unit is 121.96 minus 100.35, that is 21.61 hours. Requirement number 3 is also done. You have successfully solved this question. This question was asked in June attempt of 2023 exam. The question says, Gangotri Limited is developing a new product. Since this is a new product, learning effect will be applied on this product. During its expected life, 16,000 units of this product will be sold. The selling price of this product is given, that is rupees 102. Production will take place in batches of 1000 units. Now this means in one batch 1000 units will be produced. As you guys already know, if production is done batch wise, learning effect applied is also batch wise. The direct labor cost is expected to reduce due to the effects of learning for the first 8 batches. Thereafter, the direct labor cost will remain constant at the same cost per batch as in the 8th batch. Now this means learning effect applied on this product will be only for the first 8 batches. Learning stops after making the first 8 batches. Now since learning stops after making the first 8 batches, labor cost of the 8th batch and labor cost from 9th to 16th batch is going to be same. The direct labor cost of the first batch is given in the question, that is rupees 55,000. The learning rate here is 90% and the direct material cost is rupees 50 per unit. It is given in the question that learning index for a 90% learning curve, that is value of B, is minus 0.152. Now using this data, you are required to calculate the expected direct labor cost of the 8th batch. I want you guys to read this line again. Calculate the expected direct labor cost of the 8th batch. So in the question, you are asked to calculate labor cost of the 8th batch and not the first 8 batches. Let's solve this question. Labor cost of the 8th batch is labor cost of the first 8 batches minus labor cost of the first 7 batches. So in order to calculate labor cost of the 8th batch, first we'll have to calculate labor cost of first 8 batches and labor cost of first 7 batches. Now since production is done batch wise, learning effect applied is also batch wise. First let's calculate labor cost for the first 8 batches. Average labor cost for x number of batches is given by the formula y is equal to a into x to the power b. Here a is labor cost of the first batch, which is rupees 55,000. X is number of batches, that is 8, and value of b is given in the question, that is minus 0.152. Now using this data, let's calculate average labor cost for the first 8 batches, that is 55,000 into 8 to the power minus 0.152. Now if you go back to the question, value of 8 to the power minus 0.152 is 0.729. Now let's use this value and calculate average labor cost for the first 8 batches. Average labor cost for the first 8 batches is 55,000 into 0.729. That is rupees 40,000, 95 rupees. Now we have calculated average labor cost for the first 8 batches. Therefore, total labor cost for the first 8 batches is average labor cost for the first 8 batches, that is 40,095 into number of batches, that is 8. Therefore, total labor cost for the first 8 batches is rupees 3,20,760. Now similarly, let's calculate the total labor cost for the first 7 batches. Average labor cost for x number of batches is given by the formula y is equal to a into x to the power b. Here a is the labor cost for the first batch, which is rupees 55,000. X is the number of batches, that is 7, and value of b is given in the question, that is minus 0.152. Now let's use this value and calculate average labor cost for the first 7 batches, that is rupees 55,000 into 7 to the power minus 0.152. Now if I go back to the question, value of 7 to the power minus 0.152 is 0.744. Now let's use this value and calculate average labor cost for the first 7 batches, that is 55,000 into 0.744. Therefore, average labor cost for the first 7 batches is 40,920. Now let's calculate the total labor cost for the first 7 batches. Total labor cost for the first 7 batches is average labor cost for the first 7 batches, that is 40,920 into number of batches, that is 7. Therefore, total labor cost for the first 7 batches is 40,920 into 7, that is rupees 2,86,440. Now we have calculated labor cost for the first 8 batches, that is rupees 3,20,760, and we have also calculated the total labor cost for the first 7 batches, that is 2,86,440. Now using these values, let's calculate labor cost of the 8th batch. Labor cost of 8th batch is labor cost of the first 8 batches, that is 3,20,760 minus labor cost of the first 7 batches, that is 2,86,440. Therefore, labor cost for the 8th batch is 3,20,760 minus 2,86,440, that is rupees 34,320. Requirement number 1 is done. Now let's go back to the question. Assess the expected contribution to be earned from the product over its lifetime. Now contribution means the total profit earned. Therefore, you are supposed to calculate the total profit earned by Gangotri Limited on this particular product. If you notice, it is given in the question that selling price of the product is rupees 102. Selling price of one product is rupees 102. Therefore, total earnings made by Gangotri Limited on this particular product is rupees 102 into 16,000 units. That is rupees 16 lakh 32,000 rupees. Now if I go back to the question, it is given that material cost is rupees 50 per unit. As you guys already know, learning is not applicable on material cost. Therefore, for 16,000 units, the total material cost is rupees 50 into 16,000 units. That is rupees 8 lakh. Now let's calculate the direct labor cost for 16 batches. It is given in the question that learning effect is applicable only on the first 8 batches. We have already computed the direct labor cost for the first 8 batches that is 3,20,760. Therefore, direct labor cost for the first 8 batches is rupees 3,20,760. Now, since learning stops after the 8th batch, the labor cost of 8th batch and labor cost of the next 8 batches, that is 9, 10, 11 until the 16th batches, is going to be same. Now, in requirement number 1, we have already computed labor cost of 8th batch, that is 34,320. Therefore, labor cost of the next 8 batches, that is 9 to 16th batch, is labor cost of the 8th batch, that is 34,320 into number of batches. Therefore, labor cost for the next 8 batches is 34,320 into 8, that is rupees 2,74,560. Now, labor cost for the first 8 batch is rupees 3,20,760 and labor cost for the next 8 batch is rupees 2,74,560. Therefore, total labor cost for 16 batches is 3,20,760 plus 2,74,560, that is 5,95,320. So now we have computed the total earnings made by Gangotri Limited on this product, that is rupees 16,32,000. The total material cost is rupees 8 lakh and the direct labor cost is rupees 5,95,320. So in requirement number 2, you are asked to calculate the total profit earned by Gangotri Limited. The total profit earned by Gangotri Limited is total earnings made by Gangotri Limited minus the total material cost minus the direct labor cost. Therefore, total profit earned by Gangotri Limited is rupees 16,32,000 minus 8 lakh minus 5,95,320. Therefore, total profit earned by Gangotri Limited is rupees 2,36,680. Requirement number 2 is also done. We have successfully solved this question. Now, this concludes the end of this chapter. Now, let's have a quick recap of the things that we have learned. So, what is learning curve? Learning curve says that if a person performs a task for the very first time, he takes the most amount of time to do it. However, when the same person repeats the task again and again, his performance keeps improving and as a result, the time taken to complete the task keeps dropping. Now, this entire process is called as learning curve. In simple words, the more you do a task, the better and faster you become. Now, there are 2 types of work in real world. The first one is manual work, which is performed by humans, and the second one is automated work, which is performed by machines. Now, humans learn and improve with every repetition, whereas machines performs the task the same way every single time. Therefore, learning is only applicable for manual work and not automated work. Now, you guys know learning curve question can be solved using 2 methods. The first one is doubling approach and the second one is formula approach. Now, doubling approach says that if a worker repeats the same task again and again, then every time production doubles, the average time or the average cost per unit drops at a constant rate. Let's understand this with the help of an example. Learning rate of this worker is 80%. Now, this means this particular worker has an 80% ability to learn and improve. Now, according to the theory of learning curve, every time production doubles, average time will drop by 80%. Now, the time taken for the first unit is 10 hours. So, when production doubles from 1 to 2, since learning rate is 80%, average time becomes 80% of the previous average, that is 8 hours. When production doubles from 2 to 4, average time becomes 80% of the previous average, that is 6.4 hours. When production doubles from 4 to 8, average time becomes 80% of the previous average, that is 5.12 hours. Now, keep in mind, learning rate applied is always on average time and not the total time. Using average time, we can also compute total time. Now average time required to make the first 2 units is 8 hours. Therefore total time required to make the first 2 units is 8 into 2, that is 16 hours. Average time required to make the first 4 units is 6.4 hours. Therefore the total time required to make the first 4 units is 6.4 into 4, that is 25.6. Now the second approach to solve a given question is formula approach. Now average time or average cost for x number of units is computed using the formula y is equal to a into x to the power b. Here y is the average time or average cost for x number of units. A is the time taken for the first unit, x is the cumulative number of unit, and value of b is learning index or learning coefficient. Now you guys might be thinking, when should we make use of doubling approach and when should we make use of formula approach? Let's understand that. Doubling approach is used if cumulative number of units becomes double of the preceding level. That is, the number of units falls in this doubling sequence. If the number of units made is 3, 5 or 10, since these number of units do not become double of the preceding level, doubling approach cannot be used here. So keep in mind, if the number of units made do not fall in the doubling sequence, we'll make use of formula approach. When number of units falls in the doubling sequence, we'll make use of doubling approach. Now these are the special points which are very important while solving a question. The first point says that if production is done batch wise, learning effect applied is also batch wise. Point number 2 says learning effect is applicable on labor cost and labor related cost, but learning effect is not applicable on material cost. This concludes the end of this chapter. I hope things are clear. Alright students, we'll start with a new chapter, simulation. Now the meaning of the word simulation is to imitate, predict or estimate. In simple words, simulation is like creating a replica or copy of reality. Now the question is, why do we have to create a replica of reality? Since reality is uncertain, unpredictable and risky, you never know what's going to happen in the future. Now to be on the safer side, we make use of simulation, create replica of reality. As a result, we are well prepared for what lies ahead. Let's understand this with the help of few examples. A lot of you out there prefer giving in mock exams before your final exams. Now we all know mock exams is not your actual exam. It is just a replica of how your final exam is going to look like. Although mock exam is not your actual exams, it gives you clarity on how prepared you are and what are the things that you'll have to work on so that you can ace your final exams. The next example is Money Heist. Yes, one of the most iconic series on Netflix. If you have watched this series, do you remember what the professor made the team do before the actual robbery? The team practiced it in a simulated bank, not a real one, but an exact replica of a real bank. In real heist, there is no scope for errors, there is no room for mistakes, and that is the reason the team practiced it in a simulated bank. Similarly, in real world business scenarios, if plans and strategies are implemented without proper planning, without testing the possible outcomes, the chances of error is high. And that is exactly why we'll be studying simulation in this particular chapter. Now in real world business scenarios, we face uncertainty every single day. How many customers will come tomorrow? How much stock should we hold? How much production should we plan? We can't say any of these with certainty. But instead of sitting helpless, what we can do is make use of simulation, estimate the possible scenarios, and be well prepared for what lies ahead. So in this particular chapter, we learn how to simulate or forecast future using the given data, and this is done using Monte Carlo simulation. Let's understand how this works with the help of an example. When I was in my college, there was an auntie who sold dosa, idlis, sambar, chutney. Now the idlis auntie made was very famous among all the students. But auntie faced one problem. The number of idlis she sold was never the same. Some days her place was overcrowded with students, while on few days the business was dull. Now if she overcooked, the idlis would get wasted and she would lose her money. On the other hand, if she undercooked, students would go to the next stall and as a result, she would lose out on her profits. Now for this reason, auntie started collecting data regarding the number of idlis she sold every single day. She did this for 100 days and this is what she has found. There is a 25% chance that she sells 50 idlis, 35% chance that she sells 60 idlis, 30% chance that she sells 70 idlis, and a 10% chance that she sells 80 idlis a day. Now using this data, tell me students, how many idlis should auntie prepare in the next 3 days? Can anyone give me the exact number? The answer is no. Since the future is uncertain, since reality is uncertain, nobody can give me the exact value of the number of idlis auntie should prepare. But if you have a look at this data, you'll notice that in the past 100 days, the number of idlis auntie has sold is either 50, 60, 70 or 80. Now that means the number of idlis auntie should prepare in the coming days is more likely going to be one among these values. Now let's simulate or estimate the number of idlis auntie should prepare by playing a simple game. I'll write down all these values in a piece of paper and place it in a box. Once this is done, I'll close my eyes and randomly pick a value. Keep in mind, I don't know what the value is. I'll randomly pick a value. The value is 60. Therefore, I'll assume the number of idlis auntie should prepare tomorrow is 60. Now pause for a moment and think about it. Is this the right approach? Yes, I do agree that from the data collected regarding the number of idlis sold, the value is more likely going to be one among these. Now auntie has collected data for 100 days, but while simulating, we have only considered these values. One more thing to note here is, all these values has a different probability. But in the initial approach, we only had 4 values and each value had an equal chance of occurrence. Now since probability of all these values was not considered, the initial approach was wrong. Now let's play the game of simulation the right way. Now instead of 4 values, since the data is collected for 100 days, I'll have 100 chits in this box. I'll have numbers starting from 0 to 99 and every number here represents one among these values. Now to proceed further, I should know which of these values does each of these numbers represent. So for that reason, I'll find the range of random numbers for each values. Now range is obtained by first calculating cumulative probability. Cumulative probability is obtained by adding each probability one by one. I'll write down the first probability as it is. Now the next cumulative probability is 0.25 plus 0.35, that is 0.6. 0.6 plus 0.3 gives me 0.9. And finally, 0.9 plus 0.1 gives me 1. If you notice, cumulative probability ended at 1 and this is true for all the questions. So how did we obtain cumulative probability? I'll write down the first probability as it is. Once this is done, I'll add each probability one by one. 0.25 plus 0.35 is 0.6, 0.6 plus 0.3 is 0.9 and 0.9 plus 0.1 is 1. Now what is the interpretation of cumulative probability? This means that there is a 25% chance auntie sells 50 idlis. There is a 60% chance that auntie sells either 50 or 60 idlis. There is a 90% chance that auntie sells 50, 60 or 70 idlis. And from the data collected, there is a 100% chance that auntie sells 50, 60, 70 or 80 idlis. Now using cumulative probability, let's find the range for each values. Now since the numbers are from 0 to 99, range starts with 0 and it ends at 1 less than cumulative probability, which is 24. After 24 we have 25, so the next range starts at 25 and ends at 1 less than 60, which is 59. After 59 the next number is 60, so the next range starts at 60 and ends at 1 less than 90, which is 89. After 89 we have 90, so the last range starts at 90 and ends at 1 less than 100, which is 99. Now what is the meaning of this? From the data collected, there is a 25% chance that auntie sells 50 idlis, so I have assigned 25 random numbers to this value starting from 0 to 24. From the data collected, there is a 35% chance that auntie sells 60 idlis, so I have assigned 35 numbers from 25 to 59 to this value. There is a 30% chance that auntie sells 70 idlis, so I have assigned 30 numbers from 60 to 89 to this value. And finally, there is a 10% chance that auntie sells 80 idlis, so I have assigned 10 numbers to this value. We have obtained a range for all these values. Once the range is obtained, we will play the game of simulation. Now in this box, which has 100 random numbers, I will pick 3 numbers randomly. So the first random number is 43. I will again pick a random number. The next random number is 61. I will again pick a random number. The last value is 93. Now using these random numbers, we will estimate the expected number of idlis auntie should prepare in the next 3 days. The first value is 43. Now go to the previous range table and see which value does this represent. Now 43 lies in this range. That means the number of idlis auntie should prepare on day 1 is 60. The second random number is 61. Now 61 lies in this range. Therefore, the expected number of idlis auntie should prepare on day 2 is 70. Now the last random number is 93. 93 lies in the last range. Therefore, the expected number of idlis auntie should prepare on day 3 is 80. We have successfully solved the given simulation problem. While solving a simulation problem, all you have to do is read the question carefully, understand what is asked in the question, and play the game of simulation. Now in a simulation problem, random numbers will be given to you in the question. Let me tell you the beauty of simulation. In this particular example, we made use of 3 random numbers. Now instead of 3 random numbers, if we make use of hundreds and thousands of random numbers, the value obtained, the simulated value obtained is going to be more accurate. Let's have a quick recap of the things that we have learned. Simulation is a method to predict, estimate or forecast the future using the given data. In simple words, simulation is like creating a replica or copy of reality. Now the values we get after simulation is not the actual reality, but it is very close to the actual reality. This will help us to make better business decisions. As discussed earlier, simulation problem is solved using Monte Carlo simulation. Now any given simulation problem can be solved by following these 3 steps. First, we will prepare a random number range table. This is done by using the probability of the given data. Once a range table is obtained, we will find the simulated values using the random numbers given in the question. Step number 3 is performing analysis or working on the problem as specified in the question. Now let me tell you, step number 1 and step number 2 are same for all the questions. For a given simulation problem, step 3, that is performing analysis, changes based on what is asked in the question. Let's solve the first question. A small retailer has collected data over the past 200 weeks regarding the amount that he has received, which is weekly receipts, and the payment that he has made, which is weekly payments. Now this data is given to you in this table. For the data collected for weekly receipts, you will notice that there is a 20% chance he receives 3,000, 30% chance that he receives 5,000, 40% chance that he receives 7,000 rupees, and 10% chance that he receives 12,000 rupees. Similarly, data and probability for weekly payments is also given. Now using this data and the random numbers given below, you will have to simulate the expected weekly receipts and the expected weekly payments for the next 6 weeks. It is given in the question that the current bank balance of the retailer is 8,000 rupees. You are required to find out the estimated bank balance at the end of 6 weeks, the highest weekly balance during the 6-week period, and the average weekly balance in the 6-week period. Now before we start solving the question, as we have already discussed, The simulation problem is solved using 3 steps. First, we'll make use of the probability given in the question and prepare a range table. Once a range table is obtained, we'll make use of the random numbers given in the question and find the simulated values. Step number 3 is performing analysis or working on the problem as specified in the question. Now let's solve this question. Step number 1 is preparing a random number range table. Now this is the flow of steps to be followed to prepare range table. We'll make use of the probability given in the question and first find cumulative probability. Once cumulative probability is obtained, we'll make use of cumulative probability and find the range for each values. This is the data given for weekly receipts and this is the data given for weekly payments. First, let's compute cumulative probability. Now cumulative probability is obtained by adding each probability one by one. Now since this is the first probability, I'll write it as it is. Now the next probability is 0.3. Adding 0.2 to this value, we'll have 0.2 plus 0.3 which is 0.5. The next probability is 0.4. Now adding 0.5 to 0.4, we'll have 0.9. The last probability is 0.1. Adding 0.9 to 0.1, we'll have 1. If you notice, cumulative probability ended at 1 and this is true for all the questions. So how did we obtain cumulative probability? We'll add each probability one by one. The first probability is 0.2. 0.3 plus 0.2 gives me 0.5. 0.4 plus 0.5 gives 0.9. 0.1 and 0.9 gives 1. Now a lot of students have confusion regarding what exactly is cumulative probability. Let's understand that. Now this value means there's a 20% chance the weekly receipt received is 3000. There's a 50% chance that the weekly receipt received is either 3000 or 5000. There's a 90% chance that the weekly receipt received is 3000, 5000 or 7000. From the data collected, there's a 100% chance that the weekly receipt is one among these values. Now using cumulative probability, we can find the range for all the values. Keep in mind, range always starts at 0. So the first range starts at 0 and ends at 1 less than cumulative probability. Here the cumulative probability is 20, so the range ends at 19. After 19, the next value is 20, so the next range starts at 20 and ends at 1 less than 50, which is 49. After 49, we have 50, so the next range starts at 50 and ends at 1 less than 90, which is 89. And finally, the last range starts at 90 and ends at 1 less than 100, which is 99. If you observe carefully, range started at 00 and ended at 99. This is true for all the questions. Now let's understand what exactly is range. What is the interpretation of range? From the data collected, you will notice that there is a 20% chance weekly receipt received is 3000. For that reason, I have assigned 20 random numbers to this value. There is a 30% chance that the weekly receipt received is 5000. So I have assigned 30 random numbers to this value starting from 20 and ending at 49. Weekly receipt being 7000 rupees has a probability of 40. So I have assigned 40 random numbers to this value. Finally, weekly receipt being 12,000 rupees has a probability of 10. So I have assigned 10 random numbers to this value. Now similarly, let's obtain the range table for weekly payments. First, we'll calculate cumulative probability. The first probability is 0.3, so I'll write it as it is. 0.3 plus 0.4 is 0.7. 0.7 plus 0.2 is 0.9. And finally, 0.9 plus 0.1 is 1. Now using cumulative probability, let's find the range for all the values. As discussed earlier, range starts at 0 and ends at 1 less than 30, which is 29. The next range starts at 30 and ends at 1 less than 70, which is 69. After 69, we have 70, so the next range starts at 70 and ends at 1 less than 90, which is 89. After 89, we have 90, so the last range starts at 90 and ends at 1 less than 100, which is 99. Step number 1, that is preparing range table for the given data, is done. Now step number 2 is finding simulated values. In our question, it is expected weekly receipts and expected weekly payments using the random numbers given in the question. Now these are the random numbers given in the question for weekly receipts and these are the random numbers given in the question for weekly payments. Let's calculate the simulated weekly receipts for all these random numbers. The first random number is 3. Now go to the previous table, that is the range table, and see which value does 3 indicate. If you observe carefully, 3 lies in this range. That means the expected weekly receipt is going to be 3000 rupees. The next random number is 91. 91 lies in the last range. Therefore, the expected weekly receipt is going to be 12,000 rupees. The next random number is 38. 38 lies in this range. Therefore, the expected weekly receipt is going to be 5,000 rupees. 55 lies in this range. Therefore, the expected weekly receipt is going to be 7,000 rupees. The next random number is 17. 17 lies in the first range. Therefore, the expected weekly receipt is going to be 3,000 rupees. Now the last random number for weekly receipt is 46. 46 lies in this range. Therefore, the expected weekly receipt is going to be 5,000 rupees. Now similarly, using the random numbers given for weekly payments, let's obtain the simulated or expected weekly payments. The first random number is 61. Go to the previous range table and see in which range does 61 lie. 61 lies in this range. Therefore, the expected weekly payment is going to be 6,000 rupees. The next random number is 96. 96 lies in the last range. Therefore, the expected weekly payment is going to be 10,000 rupees. Now, the next random number is 30. 30 lies in this range. Therefore, the expected weekly payment is going to be 6,000 rupees. 32 lies in the same range. Therefore, expected payment is again going to be 6,000 rupees. 03 lies in the first range. Therefore, the expected weekly payment is going to be 4,000 rupees. Now, the last random number, which is 88, lies in this range. Therefore, the expected weekly payment is going to be 8,000 rupees. Step number 2, that is finding the expected simulated values, is done. In our case, we have calculated the expected weekly receipts and the expected weekly payments. As we have already discussed, step 1 and step 2 are common for all the questions. For a given simulation problem, step 3, that is working on the problem or making analysis changes based on what is asked in the question. Now let's go back to the question and see what exactly is asked. It is given in the question that the current bank balance of the retailer is 8,000 rupees. You are required to find out the estimated bank balance at the end of 6 weeks. So now using the weekly receipts and the weekly payments that we have obtained, we'll have to calculate the bank balance of the retailer at the end of each week. Now keep in mind, bank balance at the end of each week is bank balance of the retailer at the start of the week plus the amount that he has received in the week, that is weekly receipts, minus the payment that he has made, which is weekly payments. Now it is given in the question that the current bank balance of the retailer is 8,000 rupees. In the first week, retailer has received an amount of 3,000 rupees and he has made a payment of 6,000 rupees. Therefore, bank balance at the end of the first week is 8,000 rupees plus 3,000 rupees minus 6,000 rupees, which is 5,000 rupees. Now at the start of the second week, the bank balance of the retailer is 5,000 rupees. In the second week, he has received an amount of 12,000 rupees and he has made a payment of 10,000 rupees. Therefore, his bank balance at the end of the second week is 5,000 plus 12,000 minus 10,000, which is 7,000 rupees. Now at the start of the third week, bank balance of the retailer is 7,000 rupees. In third week, he has received an amount of 5,000 rupees and he has made a payment of 6,000 rupees. Therefore, his bank balance at the end of third week is 7,000 plus 5,000 minus 6,000, which is 6,000 rupees. Now at the start of the fourth week, bank balance of the retailer is 6,000 rupees. He receives an amount of 7,000 rupees and he makes a payment of 6,000 rupees. Therefore, his bank balance at the end of fourth week is 6,000 plus 7,000 minus 6,000, which is 7,000 rupees. Now at the start of the fifth week, bank balance of the retailer is 7,000 rupees. In the fifth week, he receives an amount of 3,000 rupees and he makes a payment of 4,000 rupees. Therefore, his bank balance at the end of fifth week is 7,000 plus 3,000 minus 4,000, which is 6,000 rupees. Now at the start of the sixth week, bank balance of the retailer is 6,000 rupees. In the sixth week, he receives an amount of 5,000 rupees and he makes a payment of 8,000 rupees. Therefore, bank balance at the end of the sixth week is 6,000 rupees plus 5,000 rupees minus 8,000 rupees, which is 3,000 rupees. Therefore, bank balance of the retailer at the end of the sixth week is 3,000 rupees. Let's write it down. The next question asked is the highest weekly balance during the 6-week period. Now if you have a look at this data carefully, in the 6-week period, you will notice that the maximum value is 7,000 rupees. Therefore, the highest weekly balance in the 6-week period is 7,000 rupees. The last question asked is, what is the average weekly balance in the 6-week period? Now to obtain average, first we'll have to add all these values. 5,000 plus 7,000 plus 6,000 plus 7,000 plus 6,000 plus 3,000 is 34,000. Now since we have simulated these values over a period of 6 weeks, to obtain average, I'll divide 34,000 by 6. Which gives me 5,666. The given simulation problem is solved. This question was asked in December 24 attempt. It is given in the question that a bakery bakes 100 cakes a day. Now the sale of the cakes varies every single day and it depends on the demand of the cake. Now this data is given to you in this table. The demand of cake being 97 has a chance of 10%. There is a 15% chance that the demand of cake is 98. There is a 20% chance that the demand of cake is 99. There is a 35% chance that demand of cake is 100. There is a 15% chance that the demand of cake is 102. And there is a 5% chance that the demand of cake is 103. Now using these details and the random numbers given here, you will have to simulate the demand for the next 10 days. The following details regarding the cakes are given. The production cost of the cake is 14 rupees. Selling price of the cake is 18 rupees. If a cake remains unsold, a loss of 3 rupees is incurred. If the demand of customer is not met, bakery incurs a loss of 1 rupees. Now using these details and the expected demand simulated, you'll have to examine the profit made by the bakery in the next 10 days. Let's solve the question. So step number 1 is preparing range table for the random numbers. Now this is the data given in the question. As discussed earlier, range table is obtained by first calculating cumulative probability, and once cumulative probability is obtained, we can find the range for all the values. Now cumulative probability is obtained by adding each probability one by one. Since this is the first probability, I will write it as it is. 0.10 plus 0.15 is 0.25. 0.25 plus 0.2 is 0.45. 0.45 plus 0.35 is 0.8. 0.8 plus 0.15 is 0.95. And finally, 0.95 plus 0.05 is 1. Once cumulative probability is obtained, we can find the range for all the values. Now keep in mind, range always ends at 1 less than cumulative probability. So for the first value, range starts at 0 and ends at 1 less than 10, which is 9. Now the next range starts at 10 and ends at 1 less than 25, which is 24. Range for 99 starts at 25 and ends at 1 less than 45, which is 44. Now the next range starts at 45 and ends at 1 less than 80, which is 79. After 79 we have 80, so the next range starts at 80 and ends at 1 less than 95, which is 94. And the last range starts at 95 and ends at 1 less than 100, which is 99. Step number 1, that is preparing range table for the random numbers, is done. Now step number 2 is finding the simulated values. In our case, that is the expected demands using the random numbers given in the question. The first random number is 9. Now go to the previous range table and see in which range does this number lie. If you observe carefully, 9 lies in the first range, therefore the expected demand on day 1 is 97. The second random number is 98. 98 lies in this range, therefore the expected demand on day 2 is 103. The third random number is 64. 64 lies in this range, therefore the expected demand on day 4 is 100. The next random number is 98. 98 lies in the last range, therefore the expected demand is 103. The next random number is 94. 94 lies in this range, therefore the expected demand is 102. 1 lies in the first range, therefore the expected demand is 97. The next random number is 78. If you observe carefully, 78 lies in this range, therefore the expected demand is 100. The next random number is 10. 10 lies in the second range, therefore the expected demand is 98. 15 lies in the same range, therefore the expected demand is again 98. Now the last random number is 19. If you observe carefully, 19 lies in this range, therefore the expected demand is 98. Step number 2, that is simulating the expected demand, is done. Now step number 3 is performing analysis. Let's go back to the question and see what exactly is asked. The following details regarding the cake are given, that is the production cost of the cake, selling price of the cake, loss incurred if cake is unsold, and the loss incurred by the bakery if the customer demand is not satisfied. Now using these details and the expected demand calculated in step number 2, we'll have to examine the profit earned by the bakery in the next 10 days. Now if you observe carefully, it is given in the question that the bakery bakes 100 cakes a day. Now no matter what the demand is, since bakery makes only 100 cakes a day, the number of cakes sold in a day cannot be more than 100. So let's calculate the number of cakes sold every single day. Now bakery makes 100 cakes a day, but the demand from customer is only 97. Therefore, the number of cakes sold on day 1 is 97. Now, the demand from customer is 103, but since bakery makes only 100 cakes a day, we cannot sell more than 100 cakes. The demand from customer is 100, bakery makes 100 cakes a day, therefore sales made is 100. Now, the demand from customer is 103, but since the bakery makes only 100 cakes a day, the number of cakes sold is 100. Demand is 102, therefore the number of cakes sold is 100. Now, bakery makes 100 cakes a day, but since the demand is only 97, number of cakes sold is 97. Now, the demand from customer is 100, bakery makes 100 cakes a day, therefore the number of cakes sold is 100. Now, bakery makes 100 cakes a day, but since the demand is only 98, the number of cakes sold is 98. On day 9, the demand is 98, therefore number of cakes sold is 98. On the last day, the demand from customer is 98, therefore number of cakes sold is 98. Therefore, the total number of cakes sold across 10 days is 97 plus 100 plus 100 plus 100 plus 100 plus 97 plus 100 plus 98 plus 98 plus 98, which is 988. Now, if you go back to the question, it is mentioned that the bakery incurs a loss of 1 rupees if customer demand is not satisfied. Now, let's compute the unsatisfied demand of customers for every single day. On day 1, the sales made is 97 and the demand from customer is also 97. Therefore, all the demand of customer is satisfied. On day 2, the sales made is 100, but since the demand of customer is 103, 3 demand of customer is not satisfied. On day 3, the sales made is 100, the demand from customer is also 100, therefore all the demand is satisfied. On day 4, the sales made is 100, but since the demand of customer is 103, 3 demand of the customer is not satisfied. On day 5, the sales made is 100, but since the demand of customer is 102, 2 demand of customer is not satisfied. On day 6, the sales made is 97 and the demand from customer is also 97, therefore all the demand is satisfied. On day 7, the sales made is 97, the demand from customer is also 100, therefore all the demand is satisfied. On day 8, the sales made is 98 and the demand from customer is also 98, therefore all the demand is satisfied. On day 9, sales made is 98, the demand from customer is also 98, therefore all the demand is satisfied. On day 10, the sales made is 98, the demand from customer is also 98, therefore all the demands are satisfied. Therefore, the total unsatisfied demand across 10 days is 3 plus 3 plus 2, which is 8. Now, using all this computation, let's examine the profit made by the bakery. If you notice, it is given in the question that the selling price of the cake is 18 rupees. Therefore, the total earnings made by the bakery is going to be 18 rupees into the number of cakes that is sold. Now, we have already computed the number of cakes that is sold, which is 988. Therefore, the total earnings made by the bakery is 18 into 988, which is 17,784. Now, in the question, it is mentioned that the production cost of the cake is 14 rupees. Therefore, the total production cost across 10 days is 14 rupees into the number of cakes which are made. Now, in a day, 100 cakes are made. Therefore, across 10 days, the total number of cakes which is prepared is 1000. 14 into 1000 is 14,000 rupees. In the question, it is mentioned that if a cake remains unsold, a loss of 3 rupees is incurred by the bakery. Now, we know 1000 cakes are prepared across 10 days and 988 cakes are sold. Therefore, the number of unsold cakes is 1000 minus 988, which is 12. Since 3 is the loss incurred, the total loss incurred for unsold cake is 3 into 12, which is 36 rupees. Now, in the question, it is mentioned that a loss of 1 rupee is incurred if the demand is not satisfied. We have already calculated the unsatisfied demand, which is 8 across 10 days. Therefore, the loss incurred for unsatisfied demand is 1 into 8, which is 8 rupees. Therefore, the total profit earned by the bakery is the total earnings made by the bakery minus the total production cost minus the total loss incurred for unsold cake minus the loss incurred by the bakery for unsatisfied demand, which is 17,784 minus 14,000 minus 36 rupees minus 8 rupees, which is rupees 3,740. The given simulation problem is solved. Let's move on to the next question. A similar question was asked in the December 23 attempt. Now I have considered this question because here we have covered two more scenarios. What does the question say? Mr. Petro runs a petrol pump and he has collected data regarding the customer arrival pattern and the customer service pattern. This data is given to you in this table. If you observe carefully, there is something called as inter arrival time. Now inter arrival time means the time gap between the arrival of one customer and the previous one. For the data collected for arrival time, you'll notice that there's a 22% chance a customer arrives 2 minutes exactly after the previous one. 30% chance that the customer arrives 4 minutes exactly after the previous one. 24% chance that a customer arrives 6 minutes exactly after the previous one. 14% chance that a customer arrives 8 minutes exactly after the previous one. And a 10% chance that a customer arrives 10 minutes exactly after the previous one. Similarly, data for service time and its probability is also given. It is given in the question that the pump opens at 8 o'clock and there is only one pump setup. Now using these random numbers, you'll have to estimate or simulate the customer arrival pattern and the customer service pattern. Once this is done, you are required to find out the probability of pump being idle and the average time spent by a customer waiting in a queue. Let's solve the question. As we have already discussed, the first step of solving a simulation problem is preparing a range table. Now this is the data given for arrival time and this is the data given for service time. Now range table is obtained by first calculating cumulative probability. Now cumulative probability is obtained by adding each probability one by one. Since this is the first probability, I'll write it as it is. Now 0.22 plus 0.3 is 0.52. 0.52 plus 0.24 is 0.76. 0.76 plus 0.14 is 0.9. And finally, 0.9 plus 0.1 is 1. Now using cumulative probability, let's find the range for all the values. Range starts with 0, 0 and ends at 1 less than 22, which is 21. The next range starts at 22 and ends at 1 less than 52, which is 51. After 51 we have 52, so the next range starts at 52 and ends at 1 less than 76, which is 75. The next range starts at 76 and ends at 1 less than 90, which is 89. And finally, the last range starts at 90 and ends at 1 less than 100, which is 99. We have prepared range table for the arrival time. Similarly, let's prepare range table for the service time. Now cumulative probability is obtained by adding each probability one by one. Since this is the first probability, I'll write it as it is. Now 0.28 plus 0.4 is 0.68. 0.68 plus 0.22 is 0.9. 0.9 plus 0.1 is 1. Now the range of the first value starts at 0 and ends at 1 less than 28, which is 27. The next range starts at 28 and ends at 1 less than 68, which is 67. The next range starts at 68 and ends at 1 less than 90, which is 89. After 89, the next number is 90, so the last range starts at 90 and ends at 1 less than 100, which is 99. Step number 1, that is preparing random number range table, is done. Now step number 2 is finding the simulated values using the random numbers given in the question. Now these are the random numbers given for arrival pattern and these are the random numbers given for service pattern. For arrival pattern, the first random number is 68. Now go to the previous table and see in which range does this number lie. If you observe carefully, 78 lies in this range, therefore the estimated arrival time is going to be 8 minutes. The next random number is 26. 26 lies in this range, therefore the estimated arrival time is going to be 4 minutes. 94 lies in this range, therefore the estimated arrival time is going to be 10 minutes. The next random number is 8. 8 lies in the first range, therefore the estimated arrival time is going to be 2 minutes. 46 lies in this range, therefore the estimated arrival time is going to be 4 minutes. The last random number is 63. If you observe carefully, 63 lies in this range, therefore the estimated arrival time is going to be 6 minutes. The simulated arrival time obtained here is in terms of minute, but what we want is the clock time of customer arrival time. Now keep in mind, the arrival time obtained here is the inter arrival time. That means this is the time gap between arrival of one customer and the next one. It is given in the question that the pump opens at 8 p.m. The first customer arrives 8 minutes after the pump opens, therefore his arrival time is 8:08. Now the next customer arrives 4 minutes after the previous one, therefore his arrival time is 8:12. Customer 3 arrives 10 minutes after the previous customer, therefore his arrival time is 8:22. Now the next customer arrives 2 minutes after the previous one, therefore his arrival time is 8:24. Customer 5 arrives 4 minutes after the previous one, therefore his arrival time is 8:28. Now the last customer arrives 6 minutes after the previous one, therefore his arrival time is 8:34. Now using these random numbers, let's estimate or simulate the service time for all the customers. The first random number is 44. Go to the previous table and see in which range does this number lie. If you observe carefully, 44 lies in this range, therefore the estimated service time is going to be 6 minutes. The next random number is 21. 21 lies in the first range, therefore the estimated service time is going to be 4 minutes. The next random number is 73. 73 lies in this range, therefore the estimated service time is going to be 8 minutes. 96 lies in the last range, therefore the estimated service time is going to be 10 minutes. The next random number is 63. 63 lies in this range, therefore the estimated service time is going to be 6 minutes. The last random number is 35. If I go back to the previous range table, 35 lies in this range, therefore the estimated service time is going to be 6 minutes. Now we have obtained the simulated service time for all the customers. Now the data obtained here is in terms of minutes. Using this data, let's find out the service start time and service end time for all the customers. The first customer arrived at 8:08. Since he is the first customer, the service of this customer will start immediately at 8:08. Now the service time of this customer is 6 minutes, therefore he will be occupied until 8:14. Now I want you guys to pause for a moment and read the question again. In the question, you are required to find out the probability of pump being idle and the average time spent by a customer waiting in a queue. If you think about it, either of two things can happen in a petrol pump. If the petrol pump is crowded, then the customer will have to wait in a queue. On the other hand, if the petrol pump is empty and if there are no customers, then the pump will be idle. Now using the service start time and service end time for all the customer, let's compute the customer wait time and the pump idle time. Now the pump opened at 8 o'clock and the first customer arrived at 8:08. This means the pump was idle for 8 minutes. Now customer 2 arrived at 8:12. Since the previous customer is occupied until 8:14, the service of this customer will start at 8:14. Now if you observe, customer 2 arrived at 8:12 and his service started at 8:14. That means he'll have to wait in the queue for 2 minutes. The service of this customer will go on for 4 minutes. Therefore, he will be occupied until 8:18. Customer 3 arrived at 8:22. Now the previous customer already left at 8:18. Therefore, his service will start immediately at 8:22. If you observe, the previous customer left at 8:18 and the next customer entered at 8:22. That means the pump was idle for 4 minutes. The service time of this customer is 8 minutes. Therefore, his service will end at 8:30. Customer 4 entered at 8:24, but the previous customer is already occupied until 8:30. Therefore, this customer will have to wait for 6 minutes. That is 8:30. Now, the service time of this customer is 10 minutes. Therefore, this customer will be occupied until 8:40. Customer 5 arrived at 8:28. Since the previous customer is already occupied until 8:40, this customer will have to wait until 8:40 to enter the queue. Now customer 5 entered at 8:28 and his service started at 8:40. That means his wait time is 12 minutes. The service of this customer will go on for 6 minutes. Therefore, his service will end at 8:46. Now the last customer arrived at 8:34. Since the previous customer is already occupied until 8:46, this customer will have to wait until 8:46. Customer 6 arrived at 8:34 and his service started at 8:46. This means the customer will wait in the queue for 12 minutes. Now the service time of this customer is 6 minutes. Therefore, his service will end at 8:52. Now we have obtained the customer wait time and the pump idle time for all the customers. The total customer wait time is 2 plus 6 plus 12 plus 12, that is 32. The total pump idle time is 8 plus 14, which is 12 minutes. Now we are required to find out the probability of pump being idle. Probability of pump being idle is the total idle time divided by total time. Now the total idle time is 12 minutes. The pump opened at 8 o'clock and the last customer was occupied until 8:52. This means the pump was occupied until 52 minutes. Therefore, the probability of pump being idle is the total idle time, which is 12 minutes, divided by total duration, which is 52 minutes. Now 12 by 52 is 0.23. The next question asked was average wait time for the customer. Now the average wait time for the customer is the total wait time divided by number of customers. The total wait time for 6 customers is 32 minutes. Therefore, the average wait time for customers is 32 divided by 6, which is 5.33. The given question is successfully solved. Let me be very clear, simulation is one of the easiest chapter in your syllabus. There is a high chance that a 7-mark question will be asked from this chapter in your final exam. Remember, there are no rigid formulas or fixed methods to solve a simulation problem, but the process always follows 3 broad steps. First, in step number 1, we'll make use of the probability given in the question and prepare random range table. In step number 2, we'll find the simulated values using the random numbers given in the question. Step number 3 is performing analysis or working on the problem based on what exactly is being asked. It can be anything. You may be asked to find the bank balance, or questions regarding demand, profit or average can be asked. As I've already mentioned it multiple times, step 1 and step 2 are common for all the questions. For a given simulation problem, step 3, that is performing analysis, changes depending on what exactly is being asked. I've tried covering different types of questions that can be asked in your exam. But since this is a marathon video, for sure I cannot be covering every possible variation. The trick is simple. Read the question carefully, understand what is being asked, and play the game of simulation. If you practice more questions, I can promise you, simulation is going to be one of the scoring chapters in your exam. Let's begin with the next chapter, that is game theory. So from the name of this chapter, one thing is very clear. We are talking something about games. So let's actually play one. A game all of us have played at some point in our life. Rock, paper, scissors. Now the rules of this game are very simple. Rock beats scissors, scissors beats paper, and paper beats rock. Now let's say you and I are playing this game. So if I choose rock and you choose scissors, I'll win the game. But if I choose rock and you choose paper, you will win the game. Is this right? Perfect. Now even in the simple game, there is something hidden. There's a key learning which is going to be the core and foundation of this chapter. So let's analyze what's happening here. Now tell me, if I am someone who chooses rock all the time, then will you not figure that out and choose paper? Now as a result of this, you will win the game. Is this right? Okay. Now that means my outcome does not depend only on what I do. My outcome, whether I win or lose, does not depend only on the action I take, but it also depends on what the other person does. Now that is learning number one. So in the game, your result, your outcome does not depend only on your action, does not depend only on what you do, but it also depends on what your competitor does. It also depends on your competitor's action. This is learning number one. Now if I choose rock all the time, if I choose rock very often, then you'll quickly figure that out and counter with paper. Is this right? Now if you realize that I'll switch to paper, then you'll quickly counter with scissors. Is this right? Now that is learning number two. For every strategy you opt, for every action you take, your competitor comes up with a counter strategy. So if I choose rock, he'll quickly come with paper. If I choose paper, he'll quickly realize that and come with scissors. That is learning number two. For every strategy you opt, for every action you take, your competitor will come up with a counter strategy. Now this is the essence of game theory. So what's exactly a game? Let's understand that. Now game is simply an activity between two or more players where one player wins and the other player loses. Now think about it. Real world business scenario is a series of games. Every business is playing a game of profits, a game of market share, a game of survival. Now you take any business in this world, every sector, every industry in business has competitors. When you talk about cab services, you have Ola and Uber. When you talk about telecom industries, there's Jio and Airtel. When you talk about food delivery, you have Swiggy and Zomato. Now that means every sector of business has competitors, and the goal of every businessman, the goal of every firm is to get ahead of their competitor and maximize their benefits. And that is exactly what we are going to learn in this chapter. So in this particular chapter, we learn how should one play a game, how should one take a strategy, how should one take a decision so that he gains maximum benefit. This is exactly what we are going to learn in this chapter. So what exactly is game theory? Now game theory is the study of decision making. Game theory is the study of strategies where two or more competitors are involved. Now let's look at a real world example to understand this even better. Jio versus Airtel. Let's go back in 2015. Back then, mobile data was super expensive. Today we get 2 GB of data every single day for rupees 350 a month. But back then, we had to pay 250 rupees for just 2 GB of data for an entire month. So how did this transition happen? Now this transition happened because of Jio. Back then, Airtel used to dominate this market. Airtel had a monopoly in telecom industry. So when Jio had a plan of entering this market, its goal was clear. It wanted to be a leader of this market and it wanted to have the maximum market share in this market. So since Jio is a new player here and since Airtel is already an established player here, Jio had to play the game smartly. So when Jio entered the market, it had 3 options. It had 3 strategies to choose from. So the first strategy was provide data at same pricing as Airtel. Option number 2 was reduce the prices slightly, and option number 3 was providing data at very affordable prices. Now Jio played the game smartly and it went ahead with option number 3 and started providing data at very affordable prices. Now as a result of this, people started shifting from Airtel to Jio. Now this means the market share of Jio started to increase and the market share of Airtel started to decrease. So keep in mind, in game theory, you'll have two types of player, maximizing player and minimizing player. Now the goal of maximizing player is to maximize his gains and the goal of minimizing player is to minimize his losses. Now a maximizing player is written along the row and a minimizing player is always written along the column, and this is true for all the questions. Now coming back, in this particular question, since Jio is the new player here, since Jio is just entering the market, its goal is to maximize the market share, therefore it is a maximizing player and we have written Jio along the row. Likewise, Airtel is already an established player in this market. Now because of Jio, Airtel started losing its customers and as a result, the goal of Airtel is to minimize the loss in market share. Now since Airtel is a minimizing player, we have written Airtel along the column. So keep in mind, this is very important. In game theory, maximizing player is written along the row and minimizing player is written along the column. Now let me ask you guys a simple question. Since Jio started providing data at very affordable prices, customers started shifting from Airtel to Jio. Now tell me, will Airtel sit quiet? What will Airtel do? It is very obvious. Now because it started losing its customer, because its business got affected, Airtel came up with a counter strategy. Now Airtel had two options. Option number one was continue with the same pricing. And option number two was reduced pricing. Now these are the two options, these are the two strategies available for Airtel and these are the three strategies available for Jio. Now let's look at different combinations. Let's say Jio went with strategy 1, that is same pricing as Airtel, and Airtel also went with the strategy 1, that is providing data at same prices. Now the payoff here is 5. This means because of these strategies opted by both the companies, market share of Jio increased by 5 and market share of Airtel decreased by 5. Now this is because Jio is a maximizing player and Airtel is a minimizing player. Let's look at one more combination. Let's say Jio went with option 2, that is reduce the price slightly, and Airtel went with option 1, that is continue with the same pricing. Now the payoff here is 10 and this means market share of Jio increased by 10 and market share of Airtel reduced by 10. Similarly, every value in this matrix, which is called as payoff matrix, represents the increase in market share of Jio and decrease in market share of Airtel. Now using this matrix, you'll have to figure out which is the best strategy for Jio and which is the best strategy for Airtel, such that Airtel maximizes its benefit and Jio maximizes its benefit and Airtel minimizes its loss. And this is exactly what we are going to learn in this chapter. So in this particular chapter, we'll learn how to choose the best strategy from the available option such that the row player maximizes its gain and the column player minimizes its loss. This is exactly what we are going to learn in this chapter. Now talking about strategies, strategies are of two types. The first one is pure strategy and the second one is mixed strategy. Let's understand this with the help of an example. Let's say this particular person has 10 lakh rupees in his bank account. Now he is looking for different ways to invest his money. He has two options in front of him. He can either invest this amount in FD or he can invest this amount in stocks. Now this person does not want to take any risk. He is very conscious about his money. This is his hard earned 10 lakh rupees which he has saved along the years. And he wants the good return on this money. But at the same time, he does not want to take a very big risk. So tell me, what should he do? Now I know a lot of students have this answer. You guys will say, let him invest all the 10 lakh rupees in stock. Few will say, not even stock, let him invest all the 10 lakh rupees in crypto. Now you guys have this mindset because as of now, you guys are not earning money. But in future, when you guys will be working and when you guys have your hard earned money with you, you guys will be very careful with it. Now since this person does not want to risk everything and at the same time wants a good return on it, he plays the game smartly. He invests 40% of his money in FD and 60% of his money in stock. As a result of this, his portfolio is diversified and the risk is also minimized. Now this is called as mixed strategies. So from the available option, if a person chooses multiple strategies with a certain probability, then that is called as a mixed strategy. Now had this person went ahead with only FD, had this person invested all the 100% of his money in FD, then we would call this as pure strategy. So in pure strategy, a person or a player opts only one strategy from the available option. Now this is the difference between pure strategy and mixed strategy. So in pure strategy, person opts only one strategy from the available options, and in mixed strategy, a player opts multiple strategies with a certain probability. Now a question in game theory can be classified into two types based on the type of the strategy. It is either a pure strategy game or a mixed strategy game. As discussed earlier, in pure strategy game, a player opts one single strategy from the available option, and that is going to give him the best output. Now pure strategy game is solved using Maxima and Minima principle. Talking about mixed strategy, here opting one strategy will not give the best output. So for that reason, player opts multiple strategy with a certain probability. Now a mixed strategy game is solved using odds method. So first let's understand how to solve a pure strategy game with the help of an example. Now we know that a game is played between two players. So let's say the two players are player A with strategy A1 and A2 and player B with strategy B1 and B2. As discussed earlier, in game theory, maximizing player is represented along the row and minimizing player is represented along the column. That means player A is a maximizing player. The goal of player A is to maximize his gains, and player B is a minimizing player. His goal is to minimize his losses. Now let's say player A opts a strategy A1. Now you guys know that in real world business scenarios, when a player comes up with a strategy, then his competitor will implement a counter strategy. Now that means if player A opts strategy A1, then player B will either implement strategy B1 or implement strategy B2. So let's say player A implements strategy A1 and player B implements strategy B1. Now this means A gains a profit of 5 and B incurs a loss of 5. Now if player A opts strategy A1 and player B opts strategy B2, then A gains a profit of 2 and B incurs a loss of 2. Similarly, every value here represents the profit earned by player A and the loss incurred by player B. So our goal here is to find the best strategy for both these players such that player A gains the maximum profit and player B incurs a minimum loss. So the question is how to find the best strategies. Now this is done using Maxima and Minimax principle. Now let's say player A opts strategy A1. So tell me, is it guaranteed that he gains a profit of 5? The answer is no. Now the profit of player A depends on the strategy B opts. So if B opts strategy B1, A gains a profit of 5, and if B opts strategy B2, his profit drops to 2. Now since we don't know which strategy the other player implements, since we don't know what our competitor might do, we'll have to play the game conservatively. Therefore, we'll identify the best strategy for player A by considering the worst case scenario. So if player A opts strategy A1, no matter which strategy B opts, he'll earn a minimum profit of 2 rupees. Is this right? Now similarly, if player A opts strategy A2, no matter which strategy B opts, he will earn a minimum profit of 4 rupees. Is this right? Now this is nothing but row minimum. If you observe carefully, in the first row the values are 5 and 2. Now among 5 and 2, the minimum value is 2. In the second row, the values are 6 and 4, and among 6 and 4, the minimum value is 4. Now tell me, what would you prefer? Would you prefer a profit of 2 rupees or would you prefer a profit of 4 rupees? The answer is very obvious. We would prefer a profit of 4 rupees, and this is the best strategy for player A. That means the best strategy for player A is A2. Now this value is called as Maximin. So remember, for a row player whose objective is maximization, we'll find a Maximin value. Now remember, maximum value is always computed from behind. So first we'll identify the minimum value in each row, and once that is done, among this minimum value, we'll identify the maximum value, that is 4. Now talking about column player, since his objective is minimization of loss, since he is a minimizing player, we'll find minimax value. Now similar to maximum value, minimax value is always computed from behind. So first let's find maximum value in each column, that is column max. Now in the first column, the values are 5 and 6. Tell me which is the maximum value here. The maximum value is 6. Now in the second column, the values are 2 and 4, and the maximum value here is 4. So once we identify the maximum value among these values, tell me which is the minimum value. Now among 6 and 4, the minimum value is 4, therefore 4 is the minimax value. Now that means the best strategy for player B is B2 and the best strategy for player A is A2. Now this is how we solve a question. Now if you observe carefully, maximum value is also 4 and minimax value is also 4. Now since maximum value is equal to minimax value, which is 4, saddle point exists. Therefore, the best strategy or the optimal strategies for player A and B is A2, B2. Value of game, that is VG, is 4. Now this means the expected gain for player A is 4 and the expected loss for player B is also 4. Now this is how we solve a question using pure strategy game. So the trick is simple. For a row player who is a maximizing player, you will find maximum value, and for a player B who is a minimizing player, you will find a minimax value. So if maximum value and minimax value are equal, that means saddle point exists and the given question is a pure strategy game. Now suppose maximum value and minimax value are not equal, that implies saddle point does not exist and it is a mixed strategy game. So let's have a quick recap. So in pure strategy game, the first step is computing maximum value and minimax value. Now a row player is a maximizing player, so for a row player we will find a maximum value. Similarly, column player is a minimizing player, so for a column player we will find minimax value. Now remember, both maximin and minimax are computed from behind. So in maximin, first we will find minimum value in each row, and once that is done, among these value we will identify the maximum value. This is called as a maximin. Now talking about minimax, here we will find the maximum value in each column, and once that is done, among these values we will find the minimum value, which is called as a minimax. So once maximin and minimax are computed, we will compare the value of maximin and minimax. So if maximin value and minimax value are equal, that means saddle point exists and the given question is a pure strategy game. I hope this is clear. The next concept is solving a mixed strategy question using odds method. Now before we proceed further, first let's understand the general approach to solve any question. As you guys already know, a given question can be of two types based on the type of the strategy. It is either a pure strategy question or a mixed strategy question. Now the problem is, while solving question, the type of strategy to be used won't be mentioned in the question. So you will have no idea if the given question is a pure strategy question or a mixed strategy question. For that reason, in step 1, we'll play the game like a pure strategy game. Now this is done using minimax and maximin principle. So once maximin value and minimax value is obtained, we'll compare if maximin value is equal to minimax value. So if value of maximin and minimax are equal, this means saddle point exists and this is a pure strategy question. You have successfully solved the problem. But if maximin value is not equal to minimax value, this means saddle point does not exist and this is a mixed strategy question. So in such cases where maximum value is not equal to minimax value, we'll go to step number 2, where we'll make use of mixed strategy approach to solve the question. Now mixed strategy question is solved using two phases. In phase 1, we'll reduce the given matrix to 2 cross 2. So remember this, if the given question is already a 2 cross 2 matrix, no changes are required, we can directly go to phase 2. But if the given question is not a 2 cross 2 matrix, then we'll have to convert it into a 2 cross 2 matrix, and this is done using dominance principle. We'll understand this later on in this marathon video. Now once the matrix is 2 cross 2, we'll make use of odds method and solve the given question using mixed strategy approach. Now let's understand how is this done with the help of an example. Now you guys know that a game is played between two players. So let's say the two players playing the game are player A with strategies A1 and A2 and player B with strategies B1 and B2. Now we know that in game theory, maximizing player is represented along the row and minimizing player is represented along column. That means player A is a maximizing player, his goal is to maximize his gain, and player B is a minimizing player. Now the goal of player B is to minimize his losses. Now since we don't know if this is a pure strategy game or a mixed strategy game, the first step here is to play the game like a pure strategy approach. Now this is done using Maxima and Minimax principle. Since player A is a maximizing player, along the row we'll find a maximin value. Similarly, since player B is a minimizing player, for player B we'll find a minimax value. Now keep in mind, both maximin value and minimax value are computed from behind. So first let's find the maximin value. So the first thing that we'll have to do is find the minimum value in each row, which is nothing but row minimum. Now in the first row, the values are 1 and 5. Tell me which is the minimum value here. The minimum value is 1. Moving on, in the second row, the values are 4 and 2. Tell me which is the minimum value here. The minimum value here is 2. Now once this is done, among these minimum values, we'll have to identify the maximum value. So among 1 and 2, the maximum value is 2. Therefore, this is the maximin value. Similarly, let's find a minimax value. So first we'll have to find a maximum value in each column, which is nothing but column max. In the first column, the values are 1 and 4. Tell me which is the maximum value here. The maximum value here is 4. Moving on, in the second column, the values are 5 and 2. Tell me which is the maximum value here. Among 5 and 2, the maximum value is 5. So once this is done, once maximum value is obtained, among these values, we'll have to identify the minimum value. Now among 4 and 5, the minimum value is 4. Therefore, this is minimax value. So now we have obtained maximin value and minimax value. Now tell me, are maximin value and minimax value same? If you observe carefully, maximin value is 2 and minimax value is 4. Now since maximin value is not equal to minimax value, saddle point does not exist. The given question is a mixed strategy question. So let's go to step number 2 and solve the question using mixed strategy approach. As discussed earlier, mixed strategy game is solved using two phases. So in phase 1, we'll reduce the given matrix to 2 cross 2. Now if you observe carefully, the given question is already a 2 cross 2 matrix. So no changes are required. We can directly go to phase 2 and solve the question using odds method. Now odds method is a 3-step process. Let's understand each of these steps one by one in detail. As the name suggests, the first step here is computing odds value for every row and every column. Now odds is the difference between two elements and this value is written in the other row or other column. Let's understand this with the help of this example. Now in the first row, the values are 1 and 5. Now tell me, what is the difference between these values? Now the difference between 1 and 5 is 4 and this difference is written here. Now let's move to the next row. The values here are 4 and 2. Now tell me, what is the difference between these two values? Now the difference between 4 and 2 is 2 and this difference is written in the other row, that is 2. Similarly, let's compute odds value along every column. In the first column, the values are 1 and 4. Now the difference between 1 and 4 is 3 and this difference is written here, that is 3. Similarly, in the second column, the values are 5 and 2 and the difference between 5 and 2 is 3 and the difference is written in the other column. Now this is how you compute odds value. The trick is simple. In the first row, we find the difference between two elements and we'll write it in the second row. In the second row, we'll find the difference between two elements and write it in the first row. Similarly, we'll perform this along the column. The difference between the two elements in the first column is written in the second column and the difference between two elements in the second column, that is 3, is written in the first column. So this is going to be step number 1. We will compute odds value for every row and every column. So step 1 is computing odds value for every row and every column. Now we know that this is a mixed strategy question and that means player A opts strategy A1 and A2 and player B opts strategy B1 and B2. Now since a player opts multiple strategy here, we'll have to calculate probability for each strategy. So step 2 is calculating probability for each strategy. Now probability for a strategy, it's odds value for a strategy divided by sum of odds. Now if you notice here, value of 2 plus 4 is 6 and value of 3 plus 3 is also 6. That means the sum of row odds and the sum of column odds are same, which is 6, and this is true for all the questions. Now let's find probability for all the strategies. Now for strategy A1, odds value is 2, therefore its probability is 2 divided by 6, which is 1 by 3. Moving on, for strategy A2, odds value is 4, therefore its probability is 4 divided by 6, that is 2 by 3. Similarly, let's find probability for the column strategies. The first strategy is B1 and its odds value is 3, therefore probability is 3 divided by 6, which is 1 by 2. Now for strategy B2, odds value is 3, therefore its probability is 3 divided by 6, that is 1 by 2. So now we have computed probability for each strategies. Now let's write it down. So probability for strategy A1 is 1 by 3. Probability for strategy A2 is 2 by 3. Probability for strategy B1 is 1 by 2 and probability for strategy B2 is 1 by 2. So this is step number 1. We will compute probability for each strategy. Now in step 3, we'll calculate the value of game for the given question. Now value of game can be computed by either considering the first row or by either considering the first column. You can use any approach you want and both the approaches will give you the same answer. So first let's consider the first row and try calculating the value of game. So step 3 is computing value of game. Now if I consider the first row, then value of game becomes 1 into probability of strategy B1, that is 1 by 2, 1 into 1 by 2 plus 5 into probability of strategy B2, that is 1 by 2 plus 5 into 1 by 2. Now this value comes out to be 6 by 2, which is 3. Therefore value of game is 3. Now let's use one more approach. Now instead of the first row, I'll consider the first column. The trick is simple. Value of game becomes 1 into probability of strategy A1, that is 1 by 3, plus 4 into probability of strategy A2, that is 2 by 3. Now even this approach will give you the value as 3. Therefore value of game is 3. Now this means the expected gain of player A is 3 and the expected loss of player B is also 3. So this is how you solve a question of mixed strategy approach using odds method. So odds method is a 3-step process. In step 1, you will compute odds value for every row and every column. Now this is very simple. In the first row, the difference between 1 and 5 is 4 and this is written here. In the second row, the difference between 4 and 2 is 2 and it is written here. Similarly, we will compute odds along the column. So once odds value is computed, using the odds value for all strategies, we will find probability for each strategy. So this is going to be step number 2. So once this is done, we will go to step 3 and find the value of game. Therefore, optimal strategy for player A is A1, A2 with probability 1 by 3 and 2 by 3. Optimal strategy for player B is B1, B2 with probability 1 by 2, 1 by 2 and value of game is 3. We have successfully solved the given question using mixed approach. The next concept is principle of dominance. Now you guys already know that a mixed strategy question is solved using odds method. But there is one problem here. Odds method can only be used if the size of the matrix is 2 cross 2. Now that means if the number of rows and number of columns are more than 2, odds method cannot be used. So in such cases, the first step that we'll have to do is reduce the matrix to 2 cross 2. Now this is done using principle of dominance. Here we have 3 rules. So let's understand each of these rules one by one. The first rule is row elimination. Let's understand this with the help of an example. Let's say you have 10 lakh rupees in your bank account. Now you are looking for different ways to invest this amount or buy an asset. You have 3 options in front of you. You can either buy a flat, or you can invest this amount in stocks, or you can invest the same amount in your friend's business. Now let's compare all these options in terms of 2 factors, that is expected return after 10 years and money earned every single year. Now if I buy a flat from this amount, the expected value after 10 years is going to be 25 lakhs and I'll earn 1.5 lakhs every single year as a rental income. Now option number 2 is investing in stocks. So if I invest 10 lakhs rupees in stock, after 10 years, the expected value is going to be 30 lakhs and every year I'll earn a dividend income of 30,000 rupees. Now the third option is investing the amount in friend's business. So if I invest 10 lakh rupees today, after 10 years, the expected value is going to be 20 lakhs. Now every single year, I'll be earning 60,000 rupees from this investment. Now let's compare all these options in terms of 2 factors and identify which is the best option. Now let's compare option 1 and option 2, that is buying a flat and investing in stocks. So if I buy a flat, after 10 years, its value is going to be 25 lakhs and if I invest it in stocks, after 10 years, the value is going to be 30 lakhs. Now that means investing in stocks is a better option when I consider this particular factor, that is expected return after 10 years. Now let's go to the second factor, that is money earned every year. So if I buy a flat, every single year I'll earn an income of 1.5 lakh rupees. But if I invest the same amount in stocks, I'll be earning only 30,000 rupees. That means investing in a flat is a better option if I want to earn a regular income. Now if you observe carefully, expected return generated is more if you invest the amount in stocks and money earned every year is more if we invest in flat. That means we cannot make a clear decision here. So let's look at one more option. Now let me compare option number 1 and option number 3. Now if I buy a flat, after 10 years the expected value is 25 lakhs, and if I invest it in a business, after 10 years the expected value is 20 lakhs. That means buying a flat is a better option here. Now let's compare the second factor. So if I buy a flat, I'll earn a regular income of 1.5 lakh rupees every single year, and if I invest in a business, I'll only earn 60,000 rupees. That means option number 1, that is buying a flat, is better option here. Now if you observe carefully, in terms of both the factors, buying a flat is a better option. That means investing in a business is a worst option and we'll eliminate this. Now this is nothing but rule number 1, that is a row elimination. Now we know in game theory, maximizing player is represented along the row and his goal is to maximize his gains. So if he wants to maximize his gain, then we'll have to eliminate the strategy where he'll earn minimum gains. So rule number 1 says that if all the elements in the row are less than or equal to all the elements of the corresponding row, then we can eliminate the row where you have lesser values. Now in this particular example, all the values in row 3 were less than all the values in row 1. Therefore, we have eliminated row number 3. Now this is rule number 1. Now let's go to rule number 2. Now the next rule, that is rule 2, is column elimination. Let's understand this with the help of an example. Let's say you're traveling from two cities, city A and city B. Now there are 3 different routes and you're confused which route should I choose. For that reason, we'll compare these 3 routes in terms of 2 factors, that is distance and time. Now if I travel in route 1, the total distance is 200 km and the time taken is 3 hours. If I travel in route 2, total distance is 250 km and the time taken is 2.5 hours. If I travel in route 3, total distance is 300 km and the time taken is 4 hours. Now it is very obvious that our goal here is to minimize the time taken and also the kilometers should also be less. So we'll have to choose a route where time is also less and the distance covered is also less. Now let's compare all these routes. So first let me compare route 1 and route 2. Now if I travel in route 1, total distance is 200 km and if I travel in route 2, total distance is 250 km. Since total distance is less in route 1 is better than route 2 in terms of distance. Now let's go to the second factor, that is time. So if I travel in route 1, time taken is 3 hours, but if I travel in route 2, time taken is 2.5 hours. Since time taken is less here, route 2 is better than route 1 in terms of time taken. Now if you observe carefully, route 1 is better than route 2 in terms of this factor and route 2 is better than route 1 in terms of this factor. That means we cannot make a clear decision here. Now let's go to the next combination, that is route 2 and route 3. Now if I travel in route 2, total distance is 250 km and if I travel in route 3, total distance is 300 km. Since total distance is less here, route 2 is better than route 3 in terms of distance. Now let's go to the second factor, that is time. If I travel in route 2, total time taken is 2.5 hours, but if I travel in route 3, time taken is 4 hours. Since time taken is less here, route 2 is better than route 3 in terms of time taken. Now if you observe carefully, in terms of both the factors, route 2 is better than route 3. That means route 2 dominates route 3 and route 3 can be eliminated. Now this is nothing but column elimination, which is rule number 2. Now we know that in game theory, minimizing player is represented along the column and his goal is to minimize his losses. So if all the elements of a column is greater than or equal to all the elements of the corresponding column, then in such cases we can eliminate the column having higher values or greater values. Now this is done because the goal of a column player is to minimize his loss, and if loss incurred from a strategy is always higher, then we'll eliminate that column or we'll eliminate that strategy because that becomes irrelevant. Now in this particular example, if you observe carefully, all the values in column 3 are greater than all the elements of column 2. Therefore, we have eliminated column number 2. Now this is a rule number 2. Now let's have a quick recap. So we studied 2 rules until now. So the first rule is column elimination. Now this says that if all the elements of a row is less than or equal to all the elements of the corresponding row, then we can eliminate the row which has a lesser values. Now rule number 2 talks about column elimination. Now this says that if all elements of our column is greater than or equal to all the elements of the corresponding column, then we can eliminate the column which has a greater values. Now keep in mind, you can use rule 1 or rule 2 in any order and reduce the matrix to 2 cross 2. Now 90% of the time, matrix can be reduced to 2 cross 2 using the first 2 rules. But even after using rule 1 and rule 2, if matrix cannot be reduced to size of 2 cross 2, then we'll make use of rule number 3. So rule number 3 is average rule. Now average rule talks about row elimination and it also talks about column elimination. So according to rule 1, we know that if all elements in a row are less than or equal to all the elements of the corresponding row, then we can eliminate the row having lesser values. Likewise, according to average rule, if all elements of a row are less than or equal to average of corresponding elements of 2 or more rows, then we can eliminate the rows having lesser values. So this is average rule of row elimination. So average rule of row elimination says that if all elements of a row are less than or equal to average of corresponding elements of 2 or more rows, then we can eliminate the row having lesser values. Now let's go to rule number 2 of average rule, that is column elimination. Now according to rule 2, we know that if all elements of a column are greater than or equal to all the elements of the corresponding column, then we can eliminate the column which has greater values. Likewise, according to column elimination of average rule, if all elements of a column are greater than or equal to average of corresponding elements of 2 or more columns, then we can eliminate the column having greater values. So this is rule number 3, that is average rule. So keep in mind, using these 3 rules, you can reduce the size of the matrix to 2 cross 2. Now 90% of the time, matrix can be reduced to 2 cross 2 using rule 1 and rule 2. Now even after using these 3 rules, if matrix cannot be reduced to 2 cross 2, then we'll make use of rule number 3, that is average rule. I hope this is clear and this concludes this chapter.